Hello everyone, welcome back to Maths Marathon classes. This time I'll be doing KCET 1984 to 2025 of the chapter Definite Integration. Okay, KCET started from the year 1984, 42 years back. So quite a lot of time, long back it is, 42 years. So I'll be covering the topic Definite Integration, all PYQs of Karnataka CET from 1984 to 2025, 42 years of questions. Okay, so we'll see the weightage of this chapter. Okay, number of questions asked in different years. Historically, we'll see how many questions are asked in each of the year. KCT started in the year 1984. So 1984, 5 questions, 85, 5 questions, 86, 4 questions. Likewise, you can see number of questions, and I put the star mark here. Star indicates that concept called limit of a sum in this definite integration was removed from the syllabus recently from 2024 onwards. So I put star mark. Wherever there is star mark, that indicates that the limit of a sum question is asked in that year. Okay. So 1991 there is a star mark. That means limit of a sum question is asked in the year 1991, 1992, 1993, and 1996, 1997, 1999. Correct. Then you can see star mark in the year 2022 as well as 2024. So in those years, questions were asked on limit of a sum. So I put indicated as a star. Okay. So recently see 2025 3 questions, 2024 3 questions, 2023 3 questions. On average 3 questions you can tell, 3 to 4 questions can be asked from this topic, definite integration. Okay, I will be doing concept wise and also explaining the concepts while solving the problems. That will be helpful for you to understand, the more beneficial. Okay, so we'll discuss the questions one by one. The first one on evaluation of definite integral by using the fundamental theorem of calculus. So f is a continuous function in the closed interval a b. We know integral from a to b f of x dx. After integrating a function f, you call it as capital F. You get a new function, call it as capital F. Capital F of x, limits from a to b. Evaluate the function at upper limit minus lower limit. Okay. Of course, you can add a constant c. If you add a constant c also, it is going to cancel. F of x plus c, you can write if you want. So lower limit, upper limit will cancel out. C will cancel out. When you apply the upper limit minus lower limit, you get what you get is f of b minus f of a. Okay. So questions are asked based on this. Don't look at don't tell the questions are very silly, because in the 1984, 85, those years, no, questions were relatively easy compared to the recent years. So don't have to laugh at these questions. Okay, so we'll work out anyway. We should not see the level of questions many years back, 1984, 85. If you go, questions were relatively easy compared to the questions asked in the recent years. Okay, so the first one we have integral from 0 to pi root x dx. We know integral of root x is 2 by 3 x root x. Correct. So integral of 0 to pi is given. Integral from 0 to pi root x dx. Integral of root x we know 2 by 3 x root x, or x power half. Root x means x power half. Integral of x power half is x power half plus 1 by half plus 1. X power 3 by 2 by 3 by 2, which is, I'll write it as 2 by 3 into x root x. 2 by 3 into x root x. Correct? 2 by 3 x power 3 by 2. X power 3 by 2 is nothing but x root x. Correct? So evaluate the function at upper limit minus lower limit. This is equal to 2 by 3 into, evaluate the function at upper limit, what you get is pi root pi, evaluate the function at upper limit, minus evaluate the function at lower limit. So this 0 into root 0 is 0. What I am getting is 2 by 3 into pi root pi. 2 by 3 into pi root pi, which is none of this. Question asked in the year 2000 KCET 1984. Okay, so none of this is the answer. Move on to the next one. Integral from 0 to pi by 3 tan x dx. We know integral of tan x is log of mod secant x. Correct. So integral from question is 0 to pi by 3 tan x dx. Integral of tan x is log of mod secant x. Then evaluate the function at upper limit minus lower limit. We know integral of tan x is log of mod secant x. log of mod secant x, limits from 0 to pi by 3. Evaluate the function at upper limit minus evaluate the function at lower limit. Put x equal to pi by 3, upper limit. What do you get? Log of mod secant pi by 3. Log of mod secant pi by 3 minus log of mod secant 0. Correct? Evaluate the function at upper limit x equal to pi by 3 minus evaluate the function at x equal to lower limit. Log of secant pi by 3 is 2. Cos pi by 3 is half. Secant pi by 3 is 2. Secant is reciprocal of cos function. And secant 0 is 1. Correct? Secant 0 is 1. Evaluate the function at upper limit minus evaluate the function at lower limit. Secant 0 is 1 and log 1 is 0. Correct? So what we get is log 2 minus 0. Log 2 minus 0 is equal to log 2. Answer is log 2. Learn the formulas. Integral of tan x, log of mod secant x. Evaluate the function at upper limit minus lower limit. X equal to pi by 3 you put. Log of mod secant pi by 3. Secant pi by 3 is 2. Put the lower limit x equal to 0. Secant 0 is 1. Log 1 is 0. Log 2 minus 0 is log 2. Answer is option A. Question asked in the year 1984, KCET 1984. Very simple question. You can crack these questions in less than 10 to 15 seconds. Correct? Not a big deal at all. Very simple questions. Move on to the next one. Question number 3. We have integral from 0 to 3 dx by x square plus 9. So this takes the form integral of 1 by x square plus a square. Dx means 1 dx. We know this formula. Integral of 1 by x square plus a square. Integral of 1 by x square plus a square is 1 by a tan inverse x by a. Correct? 1 by a tan inverse of x by a. We know this formula. Apply this formula and get the answer. Of course, we had a constant c for every indefinite integral. This is a definite integral. So dx means 1 dx. Integral of 1 by x square plus 9. This takes the form 1 by x square plus a square. Integral of 1 by x square plus a square is 1 by a tan inverse of x by a. So integral of 1 by x square plus 9 is 1 by 3 tan inverse of x by 3. 1 by 3 tan inverse of x by 3. Correct? Integrating this 1 by x square plus 9. Evaluate the function at upper limit minus lower limit. 1 by 3 is a constant. Lower limit is 0. Upper limit is 3. So this is equal to 1 by 3 into evaluate the function at upper limit. Tan inverse of 3 by 3 which is 1 minus tan inverse of 0 by 3. 0 by 3 is 0. Correct? So this becomes 1 by 3 into tan inverse of 1 is pi by 4. Tan inverse of 0 is 0. So pi by 4 into 1 by 3. Answer is pi by 12. Pi by 12 is answer. Option B is answer. Just direct integration and evaluating the function at upper limit minus lower limit. Integral of 1 by x square plus a square. 1 by a tan inverse x by a. Learn the formula and so that easily can answer. Move on to the next one. Question number 4 we have. Integral from 0 to 4 dx by root of 16 minus x square. Dx means 1 dx. It takes the form integral of 1 by root of a square minus x square. We know integral of 1 by root of a square minus x square is sine inverse of x by a. Correct? Integral of 1 by root of a square minus x square is sine inverse of x by a plus c. We had a constant c for every indefinite integral. For definite integral, if you add a constant also, it is going to cancel out. So I am not adding the constant, directly writing the integral value and evaluating the function upper limit minus lower limit. So integral of 1 by root of 16 is 4 square. 1 by root of 4 square minus x square. Integral of that will be sine inverse of x by 4. Sine inverse of x by 4. Evaluate the function at upper limit minus lower limit. Correct? Integral of 1 by root of a square minus x square is sine inverse of x by a. So evaluate the function at upper limit. What we get? Sine inverse of 4 by 4 which is 1 minus sine inverse of 0 by 4 which is 0. Sine inverse of 1 is pi by 2. Sine inverse of 0 is 0. So answer is pi by 2. Quite simple question. Elementary integrals. Correct? So answer is pi by 2. Option A is the answer. Integral of 1 by root of a square minus x square. Sine inverse of x by a is 4 here. So evaluate the function at upper limit minus evaluate the function at lower limit. Sine inverse of 1 is pi by 2. Sine inverse of 0 is 0. Pi by 2 minus 0 is pi by 2. Move on to the next one. Question number 5. We have integral from 0 to 3. Dx means 1 dx. 1 by root of a square minus x square. Similar to the previous one. There in the fourth question we had 1 by root of 16 minus x square. Now we have 1 by root of 9 minus x square. Integral of 1 by root of 9 minus x square. We know integral of 1 by root of a square minus x square is in that formula. Integral of 1 by root of a square minus x square is sine inverse of x by a. Sine inverse of x by 3 plus a constant c, correct? Now the limits are given to be 0 to 3. Integral from 0 to 3 dx by root of 9 minus x square is equal to sine inverse of x by 3. Evaluate the function at upper limit minus lower limit. Put x equal to 3. Sine inverse of 3 by 3 is 1. Sine inverse of 1 minus sine inverse of 0. Sine inverse of 1 is pi by 2. Sine inverse of 0 is 0. Pi by 2 minus 0, which is equal to pi by 2. Quite simple question. Answer is option C. Question asked in the year KCET 1986. Quite simple questions. Okay. So, move on to the next one. Question number 6. Integral from 1 to 4 x power 4 into root x. X power 4 into root x dx is equal to how much? So, root x means we know x power half. Correct? For simplify what is x power 4 into root x? X power 4 into root x means x power half. Multiplying means adding the powers. Correct? Because the bases are same. 4 plus half, 4 and a half. 4 and a half is 9 by 2. Correct? 4 and a half is 9 by 2. So integral of 1 to 4 x power 4 root x is the same as integral from 1 to 4 x power 4 into root x is x power 9 by 2. X power 9 by 2 dx. Integral of x power 9 by 2 is what? X power 11 by 2 divided by 11 by 2. Correct? Integral of x power n is x power n plus 1 by n plus 1 plus c. Integral of x power 9 by 2 is x power 9 by 2 plus 1 by 9 by 2 plus 1, which is x power 11 by 2 divided by 11 by 2. Limits from 1 to 4. 1 by 11 by 2 is 2 by 11. Correct? 2 by 11. Evaluate the function at upper limit. 4 power 11 by 2 minus 1 power 11 by 2. 1 to the power 11 by 2 is 1 itself. Correct? 4 power 11 by 2, we can write it as 4 power 5 into 4 power half. Correct? Because 5 plus half is 5 and a half. 5 and a half is 11 by 2. So 4 power 5 is going to be equal to 1024. Correct? 4 power 5 same as 2 power 10. 4 power half is root 4. Root 4 is 2. So this becomes 2048. 4 power 11 by 2. I am splitting it as 4 power 5 into 4 power half. Because 5 plus half is 5 and half, which is 11 by 2. 4 power 5 is same as 2 power 10, which is 1024. 4 power half is a root 4. Root 4 is 2. 2 into 1024 is 2048. So this becomes equal to how much? This is equal to 2 by 11 into 2048 minus 1, which is 2047 there. So this becomes 2 by 11 into 2047. If you multiply this, how much do you get? 4094 divided by 11. 4094 divided by 11. You should do the calculation. You will get in terms of decimal here. Correct? 11 3s are is 33. I think there is a mistake in the question. 4094 x power 4 into root x. Limits from 1 to 4. Correct? No? X power 9 by 2. 4 plus half. 4 and a half. 4 and a half is 4.5. Correct? No? 4.5 is 9 by 2. X power 11 by 2 by 11 by 2. There might be some mistake in this. Because 11 3s are is 33. 7 carry. 11 7s are. Correct? 37. I am getting 37. 11 3s are 33. 7 carry. 11 7s are 77. 2 carry. 11 2s are 22. 372 point something. There might be some error in this question. Okay. It's a faulty question. So we can leave it. I've done the method properly. Limits from 1 to 4. Okay. Go on to the next one. Integral from 0 to infinity e power minus x dx. We know integral of e power x is e power x. Integral of e power minus x is e power minus x divided by coefficient of x, which is minus 1. Integral of e power minus x is e power minus x divided by coefficient of x. Coefficient of x is minus 1, correct? So integral of f of ax plus b type it is. We know integral of f of ax plus b is. Integral of f of ax plus b is equal to capital F of ax plus b divided by coefficient of x. Coefficient of x is a, correct? After integrating, you get a new function, call it as capital F. Capital F is the antiderivative of small f. After integrating, you divide by coefficient of x. If terms inside the bracket is a linear term, correct? Here it's definite integral, limits from 0 to infinity. Evaluate the function at upper limit. Minus you keep outside. Evaluate the function at upper limit. E power minus infinity minus e power minus 0. This is minus of e power minus infinity is 0. E power infinity is infinity. E power minus infinity is 0. Minus 0 same as 0. E power 0 is 1. Minus of minus 1 becomes plus 1. Answer is 1. Option A. Question asked in the year KCET 1987. Move on to the next one. Integral from 0 to 2 dx by 4 plus x square. Dx means 1 dx. It takes the form integral of 1 by a square plus x square. Integral of 1 by a square plus x square, you know, 1 by a tan inverse x by a. So this will be 1 by 2 tan inverse of x by 2. 1 by 2 tan inverse of x by 2. Limits from 0 to 2. Constant keep outside. 1 by 2 into. Evaluate the function at upper limit. Tan inverse of 2 by 2 is 1. Minus tan inverse of 0 by 2 is 0, correct? So we get half into tan inverse of 1 is pi by 4, tan inverse of 0 is 0, correct? Pi by 4 into half, that is pi by 8. Pi by 8 is answer. Option C is answer. Quite simple question. Integral of 1 by a square plus x square type. 1 by a tan inverse of x by a is 2. 1 by 2 tan inverse of x by 2. Limits from 0 to 2. Evaluate the function upper limit minus lower limit. Get the answer. Question asked in the KCET 1987. Move on to the next one. Integral from 0 to 1 dx by 1 plus x square. Tan inverse x. We know integral of 1 by 1 plus x square is tan inverse of x. Tan inverse of x, limits from 0 to 1. Correct? Evaluate the function at upper limit minus lower limit. Tan inverse of 1 minus tan inverse of 0. Tan inverse of 1 is pi by 4. Tan inverse of 0 is 0. Pi by 4 minus 0. Pi by 4 is answer. Option C is answer. Question asked in the year 1989. KCET 1989. Please make a note. All simple questions, okay? Earlier years. Next one, integral from 0 to half dx by root of 1 minus x square. Dx means 1 dx. Integral of 1 by root of 1 minus x square is sin inverse of x. We know derivative of sin inverse of x is 1 by root of 1 minus x square. So integral of 1 by root of 1 minus x square is sin inverse of x. So integral of this is sin inverse of x. Integral of 1 by root of 1 minus x square is sin inverse of x. Limits from 0 to half. Evaluate the function at upper limit minus lower limit. So this is sin inverse of 1 by 2 minus sin inverse of 0. Sin inverse of 1 by 2 is pi by 6. Sin inverse of 0 is 0. Pi by 6 minus 0. Answer is pi by 6, which is option B. Question asked in the year KCET 1990. Quite simple question. Integral of 1 by root of a square minus x square is sin inverse of x by. In particular, we have integral of 1 by root of 1 minus x square is sin inverse of x. Evaluate the function at upper limit minus evaluate the function at lower limit. Sin inverse of half is pi by 6. Pi by 6. Sin inverse of 0 is 0. Pi by 6 minus 0 is pi by 6. Move on to the next one. Question number 11 we have integral from pi by 4 to pi by 2 cot x dx. We know integral of cot x is log of mod sin x. Integral of tan x is log of mod secant x. Integral of cot x is log of mod sin x. Integral of cot x. Integral of cot x is log of mod sin x plus a constant c, correct? Here it's given as a definite integral. So integral of cot x is log of mod sin x. Log of mod sin x. Limits from pi by 4 to pi by 2. Evaluate the function at upper limit minus lower limit. Evaluate the function at upper limit minus evaluate the function at lower limit. What do you get? Log of mod sin pi by 2 minus log of mod sin pi by 4. Log of mod sin pi by 4. Sin pi by 2 is 1, we know. So this becomes log of sin pi by 2 is 1 and sin pi by 4 is 1 by root 2. Correct? Sin pi by 2 is 1. Sin pi by 4 is 1 by root 2. Log 1 is 0. Log 1 is 0. Log 1 by root 2 is, we know log 1 by is minus log a. Correct? Property of log. Log 1 by a is log 1 minus log a. So log 1, I can write minus log a. Log 1 by root 2 will be minus log root 2. Minus log root 2. Log 1 by is minus log a. Log 1 minus log a. Log a by b is log a minus log b. So log 1 by is log 1 minus log a. Log 1 is 0. So 0 minus log a is minus log a. Log 1 by root 2 is minus log root 2. Minus of minus plus. So this is log root 2. Log root 2 is log 2 power half. Correct? Log root 2. They are not kept in the form of half log 2. They kept like this only. Log root 2 is the answer. Of course, we can simplify this further. Root 2 means 2 power half. Log 2 power half is half log 2. We can write it as half log 2 also because this is log of 2 power half. Correct? Root 2 is 2 power half. Log a power b is b log a. Property of log we have. Log a m power n also I can write. Log m power n is n log m. Correct? Properties of log also you need to learn. So log 2 power half is half log 2 also we can write. But they are kept in this form itself. Log root 2 in the answer is the answer. Option B. Question asked in the year 1991. Please make a note. Quite simple question or NCERT book level questions were asked in the earlier days. Correct? Move on to the next one. Question number 12 we have. Integral from 0 to a root of a square minus x square. We know integral of root of a square minus x square is x by 2 into root of a square minus x square plus a square by 2 sin inverse of x by. Correct? So writing the formula for this, we know the standard derivation integral of root of a square minus x square is x by 2 into root of a square minus x square plus a square by 2 sin inverse of x by. Correct? Integral of root of a square minus x square is x by 2 into root of a square minus x square plus a square by 2 sin inverse of x square. Limits from 0 to a. Evaluate the function at upper limit minus lower limit. 0 to a. Upper limit, put x equal to a by 2 root of a square minus a square. Evaluate the function at upper limit plus a square by 2 sin inverse of a by a. Correct? Evaluate the function at upper limit minus evaluate the function at lower limit. Put x equal to 0. Wherever there is x, you put 0. 0 by 2 root of a square minus 0 plus a square by 2 sin inverse of 0 by a. Correct? Evaluate the function at upper limit minus lower limit. Wherever there is x, you put the upper limit. A by 2 root of a square minus a square plus a square by 2 sin inverse of a by a. Here see this part, a square minus a square is 0. This part is gone. Here also 0 into this becomes 0. Here 0 by a is 0. Of course a is a non-zero number. 0 by a is 0. Sin inverse of 0 is 0. This part is 0. Correct? Even this part is 0. This part is 0. Only this part remains. So what is left is a square by 2 sin inverse of a by a. A by a is 1. Sin inverse of 1 is pi by 2. Or this is equal to pi a square divided by 4. Or directly also we can tell in the area of circle formula, how you derive area of circle by using integration method. We know 4 times area of the circle in first quadrant. Area of the circle we know x square plus y square equal to a square. If you take circle having center at origin and radius is a, area of the circle is pi a square, correct? So how do you find area of the circle? Using that also directly we can tell. Without the actual integration we can tell the answer. Because area of the circle is pi a square. How we derive the area of circle? By method of integration you must know. 4 times area in the first quadrant, correct? We take 4 times area of the circle in the first quadrant. Circle is in this form. X square plus y square is equal to a square. This part we find out. 4 times you multiply the area in the first quadrant, we get area of the circle. So if you don't multiply by 4, what we have is this part, correct? Area of circle is pi a square. Area of circle in the first quadrant is pi a square by 4. What does this expression represent? This integral represents area of the circle only in the first quadrant. So area of circle we know pi a square. This is pi a square divided by 4 because this represents area of the circle only in the first quadrant, correct? So quadrant of circle, correct? So 1/4 of area of circle, more generally. Area of circle is pi a square or pi r square, whatever. A is the radius here. So 1/4 of pi r square. 1/4 of pi a square is the answer because finding area of the circle only in the first quadrant. Hope it's clear. Because this is y is equal to root of a square minus x square. I am finding out, correct? Taking the positive square root. By finding out area of the circle, we find area of the circle in the first quadrant and multiply by 4. That's the method I'm telling you, correct? So directly also we can tell, orally we can answer, correct? If you simplify, take x square plus y square is equal to a square. Y as taking the positive square root, we get like this. Question asked in the year 1992. Please make a note. Move on to the next one. Question number 13 we have. Integral from -1 to +1 d by dx of tan inverse of 1 by x. We find out d by dx of tan inverse 1 by x, then integrate it. What is d by dx of tan inverse 1 by x? D by dx of tan inverse of 1 by x. Derivative of tan inverse x is 1 by 1 plus x square. Derivative of tan inverse 1 by x is minus 1 by, plus 1 by. Derivative of tan inverse x is 1 by 1 plus x square. Derivative of tan inverse 1 by x will be 1 by 1 plus 1 by 1 plus 1 by x the whole square into derivative of 1 by x, which is minus 1 by x square. Further differentiate it. Correct? Derivative of tan inverse is 1 by 1 plus x square. Derivative of tan inverse 1 by x is 1 by 1 plus 1 by x the whole square into derivative of 1 by x, which is minus 1 by x. So if you simplify this, what we get? Here you take 1 by x square, now this part, take LCM in the denominator, that goes to numerator. So we get x square divided by x square plus 1 into minus 1 by x square. Correct? Taking LCM here, that x square goes to numerator. X square by x square plus 1 into minus 1 by 1 minus 1 by x square. Here x square is going to cancel. We get minus 1 by 1 plus x square. So derivative of tan inverse of 1 by x is minus 1 by 1 plus x square. So that I am going to substitute here. Therefore given integral becomes minus 1 to plus 1 d by dx of tan inverse 1 by x. We got minus 1 by 1 plus x square, correct? Minus 1 divided by 1 plus x square. Minus you can keep outside. Integral of 1 by 1 plus x square is tan inverse x, correct? Integral of 1 by 1 plus x square is tan inverse of x. Now apply the limits and get the answer. Minus you keep outside. Integral of 1 by 1 plus x square is tan inverse x. Or integral of minus 1 by 1 plus x square, directly you can get cot inverse x also. That is also true. Plus cot inverse x or minus tan inverse x, both one and the same. Limits from minus 1 to plus 1. Minus of, evaluate the function at upper limit. Tan inverse of 1 minus tan inverse of minus 1. Evaluate the function at upper limit minus lower limit. Minus of tan inverse 1 is pi by 4. Tan inverse of minus 1 is minus pi by 4. Pi by 4 plus pi by 4 becomes pi by 2. Minus pi by 2 is the answer. Correct? Tan inverse of 1 is pi by 4. Tan inverse of minus 1 is minus pi by 4. Minus of minus plus pi by 4 plus pi by 4 is pi by 2. We get minus pi by 2. Option A is the answer. First differentiate tan inverse of 1 by x. We get minus 1 by 1 plus x square using chain rule. Derivative of tan inverse is 1 by 1 plus x square. 1 by 1 plus 1 by x the whole square into further derivative of 1 by x minus 1 by x square by using chain rule. Simplify it, you get the answer as minus 1 by 1 plus x square. That you're going to substitute here. Derivative of tan inverse 1 by x is minus 1 by 1 plus x square. Then integrate 1 by 1 plus x square. Minus is kept outside. Integral of 1 by 1 plus x square is tan inverse of x. Evaluate the function in upper limit minus lower limit. You get the answer as minus pi by 2. Move on to the next one. Question number 14. Integral from pi by 4 to pi by 2 cosecant square x. We know integral of cosecant square x is minus cot x. So integral of cosecant square x is minus cot x. Limits from pi by 4 to pi by 2. All these things are board exam level questions. So simple questions are asked, correct? In the earlier years, correct? Integral of cosecant square x is minus cot x. Evaluate the function upper limit minus lower limit, because derivative cot x is minus cosecant square x. So integral of cosecant square x is minus cot x. Evaluate the function upper limit minus lower limit. This is cot pi by 2 minus cot pi by 4. Evaluate the function upper limit minus lower limit. Cot pi by 2 is 0. Cot pi by 4 is 1. So we get minus of minus plus 1. Answer is option B. Question asked in the year 2005. Please make a note. Move on to the next one. Next we have the fundamental theorem of calculus. One more, the second fundamental theorem we can call it. A function is continuous on the closed interval AB, and d by dx of integral from a to x f of t dt is f of x. Okay. Integration and d by dx are going to cancel out. Okay. We are differentiating a definite integral, I can call. So if you differentiate a definite integral, what happens? Integration and d by dx are going to cancel out. Substitute the upper limit, evaluate the function in upper limit, okay, and derivative of upper limit, which is 1, derivative of x1. So integration and d by dx are going to cancel. So I can write in a proper way to make you understand. Integration and d by dx are going to cancel. Substitute the upper limit, what do you get? f of x into differentiate the upper limit, that is 1, minus f of a into derivative of a, 0, correct? Substitute the upper limit, differentiate the upper limit, minus substitute the lower limit, differentiate the lower limit. F of a into 0 is 0. So what we get is f of x, correct? That is what we get. So this is the differentiating a definite integral. More generally, we have Newton-Leibniz formula. It is shown here. Newton-Leibniz formula is like this. D by dx of integral from u of x to v of x f of t dt. Integration and d by dx are going to cancel. Evaluate the function at upper limit f of v of x into derivative of v of x, v dash of x, minus substitute the lower limit f of u of x into derivative of u of x is u dash of x. This is called Newton-Leibniz formula. More general it is. Okay. So whenever you want to differentiate a definite integral, you are differentiating a definite integral. Lower limit and upper limit are functions of x. For integration, the variable is t. This is more useful in JEE exams. Okay. Frequently asked questions on this Newton-Leibniz formula. Even it comes under integration chapter. Also, it can be asked in limits chapter. There also they come across many times. So whenever you want to differentiate a definite integral, we make use of this. So for integration, the variable is t, and we are differentiating with respect to x because lower limit and upper limit are functions of x. That's a key point to be noted. Okay, lower limit and upper limit are functions of x. So I am differentiating with respect to x, and for integration, the variable is t. dt is there, means variable for integration is t. So evaluate the function at upper limit, differentiate the upper limit, minus evaluate the function at lower limit, differentiate the lower limit. Okay. So only one question is asked based on this. Of course, this question is found in the NCERT book itself nowadays, correct? F of x given as integral from 0 to x t sin t. What is that? F dash of x. So f of x is given as integral from 0 to x t into sin t dt. F dash of x means you're differentiating this. F dash of x is equal to d by dx of, correct? Integral from 0 to x t sin t dt. This question is found in the NCERT textbook itself, in the exercise problem as MCQ at the end of the exercise. This question is found. So when you differentiate the definite integral, integration and d by dx are going to cancel. Substitute the upper limit. Upper limit is x. In place of t, put the upper limit. What do you get? X into sin x. X into sin x into derivative of x is 1 minus 0 into sin 0 into derivative of 0 is 0. So what we get is x into sin x. X into sin x. This part is 0. Correct? So answer is x into sin x. Option B. Question asked in the year 1999. Okay. Move on to the next one. Evaluating the definite integral by the method of substitution. Okay, so this is a very important method in integration, integration by method of substitution. Whenever a given integral is of the type a composite function, f of g of x into g dash of x, normally we make a substitution. It's also called as u substitution, correct, more generally. So we make a proper substitution and we need to differentiate it, and you need to change the limits, because it is a definite integral. So if it is, the question is given in terms of x, we make a proper substitution. The purpose of making substitution is to reduce the integral to the standard form. Okay, so because we don't have chain rule or quotient rule in case of integration. So to reduce the integral to standard form, we make a suitable substitution and differentiate it. Express in terms of new variable t. Express the given integrand in terms of a new variable t, and then also you need to change the limits, because the new limits are to find out. The earlier limits in the question were given in terms of x. After introduction of the new variable t, the limits has to be written, lower limit and upper limit should be written in terms of t. So whenever you make a substitution, you differentiate and you need to change the limits. You need to differentiate first, okay, and we need to change the limits. Express the limits in terms of the new variable t. Okay, that is the procedure to integrate by method of substitution whenever they give the definite integration. Okay, we'll work out the problems based on this. So first one we have integral from 0 to 1 tan inverse x the whole cube by 1 plus x square dx. So because derivative of tan inverse x is 1 by 1 plus x square, it is suitable to substitute t equal to tan inverse x. Put t equal to tan inverse x here. Put t is equal to tan inverse of x. Put t equal to tan inverse of x. Differentiate this. dt by dx, derivative of tan inverse x, 1 by 1 plus x square. And integration by method of substitution is applicable whenever the given integral contains both the substitute and the derivative. What you are going to substitute and its derivative both should be present in the given integral. Then only we can use the method of substitution. Derivative of tan inverse x, 1 by 1 plus x square. So dt is equal to dx by 1 plus x square. dt is equal to dx divided by 1 plus x square. Now we need to change the limits. As I told, these limits are valid only for x. dx means the variable of integration is x, and the limits is x is 0, x is 1. X equal to 0, lower limit. X equal to 1 is upper limit. So find out the values of lower limit and upper limit in terms of the new variable t. New variable is t now. When x equal to 0, t equal to how much? Find out. When x equal to 0, when x is equal to 0, t is equal to how much? T is tan inverse of 0, correct? Tan inverse of 0, which is equal to 0. When x equal to upper limit is 1. When x is equal to 1, we have t is equal to tan inverse of 1. Tan inverse of 1, which is equal to pi by 4. Correct? Limits will vary. X is 0 to 1. T is 0 to pi by 4. The given integral becomes 0 to pi by 4. Correct? X equal to 0 to 1. T is from 0 to pi by 4. Tan inverse of x is taken as t. Correct? T cube it becomes dx by 1 plus x square is dt. This becomes t cube dx by 1 plus x square. This part is dt according to this. Dx by 1 plus x square is dt. Integral of t cube with respect to t is going to be t power 4 divided by 4. T power 4 divided by 4. Limits from 0 to pi by 4. Evaluate the function at upper limit minus lower limit. Evaluate the function at upper limit. T equal to pi by 4. Pi by 4 power 4 minus 0 power 4. Correct? Pi power 4 divided by 4 power 4. All right. Minus 0 power 4 is 0. Correct? Now we can write the answer. Multiply last step. We can write this as pi power 4 divided by 4 power 4 into 4, that is 4 power 5. 4 power 5 is 2 power 10, which is 1024. 5 power 4 divided by 1024. Option C is the answer. Question asked from the year 1986. Very simple one. Method of substitution. Because there is tan inverse of x and also you can see 1 by 1 plus x square, we go by method of substitution. The purpose of making substitution is to reduce the integral to the standard form so that it is possible to integrate. Okay. Move on to the next one. Question number 2 we have integral from 0 to 1 sin inverse x the whole square by root 1 minus x square. We know that derivative of sin inverse of x is 1 by root of 1 minus x square. So it is suitable to put t equal to sin inverse of x and integrate by using the substitution method. Put t equal to sin inverse of x because derivative of sin inverse of x is 1 by root of 1 minus x square. Put t is equal to sin inverse of x. Differentiate this. dt by dx. Derivative of sin inverse x. 1 by root of 1 minus x square. Correct? So dt is equal to dx by root of 1 minus x square. dt is dx by root of 1 minus x square. Correct? Limits also we need to change because these limits are valid only for x. dx is present means the variable of integration is x. So x varies from 0 to 1. T is from what to what we need to find out. When x is equal to 0, find out t equal to how much? When x is equal to 0, when x is equal to 0, t is equal to how much? Sin inverse of 0. Sin inverse of 0, which is equal to 0. When x is equal to, upper limit is 1. When x is equal to 1, t is equal to how much? Sin inverse of 1, which is pi by 2. Correct? X varies from 0 to 1. T varies from 0 to pi by 2. Therefore, given integral becomes, given integral is I can call. I is equal to 0 to 1 sin inverse x the whole square divided by root 1 minus x square. X is 0 to 1, t is 0 to pi by 2. So this becomes integral from 0 to pi by 2. Sin inverse of x is t, correct? This becomes t square. Dx by root of 1 minus x square is dt from this. Dx by root of 1 minus x square is this part. Dx by root of 1 minus x square is dt. Integral of t square is t cube divided by 3. Limits from 0 to pi by 2. Evaluate the function at upper limit minus lower limit. 1 by 3 is kept outside. Evaluate the function at upper limit. Pi by 2 cube, which is pi cube divided by 8 minus 0 cube is 0. So we get the answer as pi cube divided by 24. Pi cube divided by 24. Option A is the answer. Very simple question. Use of integration by method of substitution. All board exam level questions these days. If we compare these questions with nowadays questions. Okay. Question asked in the year 1987. Move on to the next one. Integral from 0 to pi by 4 e power tan x by cos square x. Cos square x in the denominator, take it up, becomes secant square x. Correct? This could be written as integral from 0 to pi by 4. 0 to pi by 4 e power tan x cos square x, take it up, becomes secant square x. Correct? Cos square x, take it up, becomes secant square x. You know, derivative of tan x is secant square x. So it is suitable to put t equal to tan x. Derivative of tan is secant square. Correct? The substitute and the derivative both are present in the given integral. So put t is equal to tan x. Put t is equal to tan x. From this, dt is equal to secant square x into dx. When x is equal to 0, find out t equal to how much? When x is equal to 0, t is equal to tan 0. Tan 0 is 0. Correct? When x is equal to, upper limit is pi by 4. When x is equal to pi by 4, t is equal to, find out how much? Tan pi by 4. which is equal to 1. So limits will change now. X is 0 to pi by 4, t is 0 to 1. Correct? X is 0 to pi by 4, t varies from 0 to 1. E power, tan x is taken as t, so it becomes e power t dt. E power t, secant square x into dx. This part is dt from this. Correct? Dt is equal to secant square x into dx. Integral of e power t is e power t. Limits from 0 to 1. Evaluate the function at upper limit minus lower limit. E power 1 minus e power 0. E power 1 minus e power 0 is 1. So answer is e minus 1. Integral of e power t is e power t. Evaluate the function at upper limit minus lower limit. E power 1 minus e power 0. Some students have the habit of writing like this. E power 1 minus 0. Don't put there is an upper limit minus lower limit. This is wrong. It's wrong. Absolutely wrong. Don't do like this. Be cautious, okay, about this. Evaluate the function at upper limit minus evaluate the function at lower limit. E power 1 minus e power 0. E power 0 is 1. E minus 1 is answer. Option A is answer. Question asked in there, 1987. Move on to the next one. Question number 4 we have integral from 1 to 2 log x by x dx. We know derivative of log x is 1 by x. So put t equal to log x here. By using method of substitution we can do it. Put t is equal to log x. Put t is equal to log x. dt by dx. Derivative of log x is 1 by x. So dt is equal to dx by x. dt is equal to dx divided by x. Evaluate the function, change the limits now. When x equal to 1, t equal to how much? Whenever you make a substitution, you need to differentiate and you need to change the limits because these limits are valid only for x. When x is 1, t is equal to how much? T is equal to log 1. Log 1 is 0. When x equal to 2, when x is 2, t is equal to log 2. Correct? When x is 1, t is log 1. Log 1 is 0. When x is 2, t is log 2. So the given integral becomes, given integral you can call it as I is equal to here itself. Therefore the given integral I becomes equal to x is 1 to 2, t is 0 to log 2. Correct? 0 to log 2. When x is 1, t is 0. When x is 2, t is log 2. 0 to log 2. Log x is t, dx by x is dt. T dt it becomes. Log x is t, correct? Log x is taken as t. Dx by x is dt. Dx by x is dt from this. Integral of t with respect to t is t square by 2. T square divided by 2. Evaluate the function at upper limit minus lower limit. So this is equal to 1 by 2 into. Evaluate the function at upper limit. What do you get? Log 2 the whole square minus 0 square. This is equal to half into log 2 square. 0 square is 0. So answer is half into log 2 the whole square, which is option C. Integral of t dt. Integral of t with respect to t is t square by 2. Evaluate the function at upper limit minus evaluate the function at lower limit. Lower limit is 0. So the value of that is 0. Log 2 the whole square by 2, which is half into log 2 the whole square. Question asked in the year 1987. Move on to the next one. Integral from 1 to x log of x square by x dx. Here log of x square using the property of log I can write 2 log x. We know log m power n is n log m. Log m power n is equal to n log m. Correct? Integral from 1 to x. Integral from 1 to x log of x square divided by x dx could be written as integral from 1 to x log x square is 2 log x because log m power n is n log m. It's called as power rule. Correct? This is called as the power rule in case of logarithms. So this becomes 2 log x divided by x. Then integrate this. Substitute. Change the limits also. I'll put t equal to log x because derivative of log x is 1 by x. Put t is equal to log x. Put t is equal to log x. dt is equal to dx by x. Correct? dt by dx is 1 by x. Derivative of log x 1 by x. dt by dx is equal to 1 by x. Or dt is equal to dx by x. dt is equal to dx divided by x. Change the limits. When x equal to 1, t equal to how much? When x equal to 1, when x is equal to 1, t is equal to log 1. Log 1 is 0. When x equal to, upper limit is, when x is x only, correct? X is x. T is equal to, it becomes log x itself. Correct? Upper limit is given as x. So keep as it is. X is x. These two can be kept outside. X varies from 1 to x. T is 0 to log x. T varies from 0 to log x. Log x is taken as t. Log x is t. So log x is t. dx by x is dt. From this integral of t dt, that is t square by 2. 2 into t square divided by 2. 0 to log x. 2 cancels. Evaluate the function. Upper limit minus lower limit. 2 cancels. Correct? Log x the whole square minus 0 square. 0 square is 0. So answer is log x the whole square. This is option A. Log x square is 2 log x. 2 is kept outside. Becomes integral of t dt. Integral of t is t square by 2. 2 cancels. Evaluate the function at upper limit minus lower limit. Log x the whole square minus 0 square. Option A is the answer. Question asked in the year 1988. Please make a note. Want the next one? Integral from 0 to 1. Tan inverse x by 1 plus x square. We know derivative of tan inverse x is 1 by 1 plus x square. So put t equal to tan inverse x. Put t is equal to tan inverse of x. Derivative of tan inverse x is 1 by 1 plus x square. Correct? dt by dx is equal to derivative of tan inverse x 1 by 1 plus x square. So dt is equal to dx by 1 plus x square. Limits will change. When x is 0, t equal to how much? When x is equal to 0, t is equal to tan inverse of 0 is 0. When x is equal to, upper limit is 1, t is equal to tan inverse of 1, which is pi by 4. Correct? When x is 0, t is tan inverse of 0, which is 0. When x is 1, t is tan inverse of 1, which is pi by 4. So limits will change. So x is 0 to 1, t is 0 to pi by 4. 0 to pi by 4. Tan inverse of x is t. dx by 1 plus x square is dt. Correct? Tan inverse of x is t. dx by 1 plus x square is dt. Integral of t dt, which is t square by 2. Limits from 0 to pi by 4. Evaluate the function at upper limit minus lower limit. Pi by 4 square minus 0 square. Pi by 4 square minus 0 square, which is equal to half into pi square divided by 16, which is equal to pi square divided by 32. Pi square by 32. Answer is option C. Correct? Put t equal to tan inverse x. Derivative of tan inverse x 1 by 1 plus x square. So given integral becomes t dt. X is 0, t is 0. X is 1, t is tan inverse of 1, which is pi by 4. So limits will be from 0 to pi by 4. Integral of t is t square by 2. 1 by 2 keep outside. Evaluate the function in upper limit. Pi by 4 square minus 0 square. Pi square by 16 into half. That is pi square by 32. Question asked in the year 1988. Want the next one? Question number 7 we have. Integral from 0 to 1. Root of 1 minus x by 1 plus x. Here we can do it by two methods. Either we can go by rationalization method so that it becomes reduced to integral by method of substitution, or else we can go by putting trigonometric substitution. Put x equal to cos theta also we can do here. Because there is root 1 minus x and root 1 plus x, we can put x equal to cos theta and simplify and then integrate. There are two methods. I'll go by method of rationalization. Multiply and divide by the conjugate of denominator. So take the integral as I is equal to integral from 0 to 1, correct, root of what is given 1 minus x by 1 plus x, 1 minus x divided by 1 plus x dx is equal to integral from 0 to 1 root of 1 minus x by 1 plus x multiply and divide by 1 minus x, multiply and divide by 1 minus x, multiply and divide by the conjugate. So what do you get? This is equal to integral from 0 to 1, 1 minus x into 1 minus x, 1 minus x the whole square, root of 1 minus x the whole square I get, square root of 1 minus x the whole square divided by 1 plus x into 1 minus x is 1 minus x square, correct? A plus b into a minus b is a square minus b square. So root of 1 minus x the whole square is actually mod of 1 minus x. Mod of 1 minus x becomes 1 minus x because the interval is 0 to 1. In the interval 0 to 1, 1 minus x is positive, correct? So I can write this as integral from 0 to 1, root of 1 minus x the whole square is 1 minus x divided by root of 1 minus x square. Separating the terms. Numerator, take the square root. Take the square root for denominator separately. This could be written as, you can separate the terms. Numerator is sum of two terms. No, we can separate and write, divide individually. This becomes what? Integral from 0 to 1, 1 by root of 1 minus x square with respect to x, minus integral from 0 to 1, x by root of 1 minus x square. Correct? And we know integral of 1 by root of 1 minus x square is sine inverse of x. Limits from 0 to 1 for this. For this we can integrate by method of substitution, but I'll avoid all the steps. Directly by differentiation, we know that derivative of root 1 minus x square. What is derivative of root 1 minus x square is going to be equal to 1 by 2 root of 1 minus x square into minus 2x, which will simplify to minus x by root of 1 minus x square. Derivative of root of 1 minus x square is minus x by root of 1 minus x square. So integral of x by root, minus we can take inside. I'll make plus here and put minus sign here, correct? So the plus into minus is minus. So here what we get? Integral of minus x by root of 1 minus x square is going to be root 1 minus x square. Integration is the reverse process of differentiation, right? So if you differentiate root 1 minus x square, I get minus x by root 1 minus x square. If you integrate minus x by root 1 minus x square, I'll get root 1 minus x square. Of course, the constant I won't write because it is definite now. So root of 1 minus x square. Integral of, from this it follows, integral of minus x by root 1 minus x square is root 1 minus x square. So evaluate the function at upper limit minus lower limit and get the answer. Here, sine inverse of 1 minus sine inverse of 0, correct? What do we get? Therefore, sine inverse of 1 minus sine inverse of 0. Evaluate the function at upper limit minus lower limit. Here also, evaluate the function at upper limit, root of 1 minus 1 minus root of 1 minus 0. Correct? Put x equal to 1, 1 minus 1, right? Minus root of 1 minus 0. Sine inverse of 1 is pi by 2, sine inverse of 0 is 0. This is 0, even this is 0, correct? What do you get? Answer. Sine inverse of 1 is pi by 2. This is 0, this is 0, 1 minus 0 is 1, root 1 is 1. So pi by 2 minus 1, option B. Question answer in the year 1993. Please make a note. Next one, we have question number 8 from this. Integral from 0 to 1, root of 1 plus x by 1 minus x with respect to x. Question asked in the year 2019. This question is similar to the previous one. See, here they ask root of 1 minus x by 1 plus x. In this question, it is root of 1 plus x by 1 minus x. Reciprocal, correct? Inside the root, the terms are reciprocal of that asked in question number 7. Here also same way, you can rationalize, multiply and divide by the conjugate. Take the integral as I, 0 to 1, root of, multiply and divide by conjugate, okay? Root of 1 plus x by 1 minus x is given. Multiply and divide by 1 plus x within the square root. Multiply and divide by 1 plus x. So what we get? Integral from 0 to 1, root of 1 plus x into 1 plus x becomes 1 plus x the whole square. Correct? Divided by 1 minus x into 1 plus x is 1 minus x square. Correct? This is integral from 0 to 1. Root of 1 plus x whole square is 1 plus x. Correct? This becomes 1 plus x divided by root of 1 minus x square. Then as we did in the previous problem, numerator is sum of two terms, separate the terms, divide individually. So what we get? Integral from 0 to 1. Integral from 0 to 1, 1 by root of 1 minus x square plus integral from 0 to 1, x by root of 1 minus x square. And we know integral of 1 by root of 1 minus x square is sine inverse of x. Limits from 0 to 1. Integral of x by root of 1 minus x square is minus root of 1 minus x square. We know derivative of root 1 minus x square. Derivative of root 1 minus x square is going to be equal to what? Minus x by root of 1 minus x square. So integral of x by root of 1 minus x square is minus root 1 minus x square. Correct? So if we integrate x by root of 1 minus x square, I am going to get minus root of 1 minus x square plus a constant. Correct? So integral of x by root of 1 minus x square is minus root 1 minus x square. Minus root of 1 minus x square. Limits from 0 to 1. Evaluate the function at upper limit minus lower limit. Sine inverse of 1 minus sine inverse of 0. Minus. Here upper limit root of 1 minus 1 minus root of 1 minus 0. Correct? Evaluate the function upper limit minus lower limit. Sine inverse of 0 is 0. 1 minus 1 is 0. 1 minus 0 is 1. Root 1 is 1. Minus of minus becomes plus. Sine inverse of 1 is pi by 2. Pi by 2. This is 0. This is 0. Minus of minus becomes plus. So answer is pi by 2 plus 1. Pi by 2 plus 1. Option D is answer. So you can remember this. If numerator is plus, you get pi by 2 plus 1. If numerator is minus, you get pi by 2 minus 1. Here in the previous question, we got pi by 2 minus 1. Correct? Numerator is minus. Root of 1 minus x by 1 plus x. Pi by 2 minus 1. Integral from 0 to 1, of course. Correct? Here we got pi by 2 minus 1 because numerator is minus. Next one we have here numerator is plus. So we get the answer as pi by 2 plus 1. Clear? Question asked in the year 2019. This was a question asked in the year 1993. So similar type questions do repeat, correct? So any exams, if you are attending the any competitive exams or board exams, if you are attending, means first and the foremost thing you are going to do is you should prepare with PYQs. That's the most important thing for any competitive exams in particular. Board exams too, you will refer to PYQs, correct? So previous year questions is the most important because many times questions do repeat and similar type of questions will be asked. And you'll know the level of questions. What is the level of questions they're going to ask, you'll come to know. So you have to prepare for PYQs first. Okay, if you're preparing for any competitive exams, first you revise with PYQs after studying all the formulas and synopsis. Okay, move on to the next one. And this question is found in the NCERT exemplar book also. Same question is found. Okay, if you see the chapter integration, NCERT exemplar book, it is found. Because there is cos x into dx, we put t equal to sin x. There are certain techniques. If sin x into dx is present, we put t equal to cos x. Sin x into dx is present, we put t equal to cos x. If cos x into dx is present, we put t equal to sin x. So because it is cos x into dx, we put t equal to sin x. Put t equal to sin x and integrate using method of substitution. Put t equal to sin x. Derivative of sin x is cos x. dt is equal to cos x into dx. Limits will change now. When x is 0, t equal to how much? Find out. When x is equal to 0, t is equal to sin 0. Sin 0 is 0. When x is pi by 2, t is equal to sin pi by 2. Sin pi by 2 is 1. Correct? When x is 0, t is sin 0, 0. When x is pi by 2, t is sin pi by 2, 1. So the given integral becomes all these things, no need to write also. Directly we can tell the answers orally. Just mind calculations. X is 0 to pi by 2, t is 0 to 1. E power sin x is t. Sin x is t. Cos x into dx is dt. Integral of e power t is e power t. Limits from 0 to 1. Evaluate the function at upper limit minus lower limit. E power 1 is e. E power 0 is 1. E minus 1 is the answer. Question asked in the year 1997. Here we get the answer e minus 1. See, same answer we got in another question where the question was different. Correct? Here I think, yeah. In this question also we got the answer as e minus 1. But it was 0 to pi by 4 e power tan x by cos per x. Correct? Answer was e minus 1 because it was integral from 0 to 1 e power t dt. Correct? Even in this question we have integral from 0 to 1 e power t dt. Integral from 0 to 1 e power t dt. So answer is e minus 1. Option C. Question asked in the year 1997. Correct? Simple one. It's found is also found in NCERT exemplar book. Same question. Want the next one? I1 and I2, two integrals are given here. I1 is integral from e to e square dx by log x. And I2 is integral from 1 to 2 e power x by x dx. Like comparing I1 and I2 here. So you must know that first of all, log x and e power x are inverse functions of each other. So to begin with, I'll start from I1. Okay, I1 is equal to integral from e to e square dx by log x. What we do is put t equal to log x. I'll use the method of substitution here in the first integral and go on simplified. Then I'll compare with the integral I2. Okay. So I1 is given like this. Integral from e to e square dx by log x. Put t is equal to log x here. Put t is equal to log x. Derivative of log x is 1 by x. dt by dx. Derivative of log x is 1 by x. dt is equal to dx by x. dt is equal to dx by x. Change the limits. When x is equal to e, find out t equal to how much? When x is equal to e. One more thing, what I'll do is, I'll not differentiate this. I'll convert log to exponential form. See, I can't compare with I2 if I do this. What I'll do is, t equal to log x. From there, I'll convert log to exponential form. I'll convert log to exponential form. Don't do these steps. Convert log to the exponential form. From this, we'll write, because t is equal to log x means log x base e. So x is equal to how much? X is equal to e power t from this. Important step. You must know this conversion. If log x base a is equal to b, from this, we can write this as a power b is equal to x. Log x base a equal to b means a power b is equal to x. A power b is equal to x. Correct? Learn this conversion. Both the ways it holds. Of course, a is positive and a not equal to 1. Even x is positive and x not equal to x is positive. Yeah. A is a positive. A and x both are positive. A and x both are positive and the base is never equal to 1. Correct? All these conditions you must know. So if t is equal to log x, from this I can write x is equal to e power t. convert log to exponential form. Now differentiate this. Dx by dt is equal to e power t, correct? Derivative of e power t is e power t. So dx is equal to e power t into dt. When x is equal to e, find out t is equal to how much? T is equal to log e. Log e is 1, correct? Log e, which is equal to 1. Log e means log e base, which is 1. When x equal to, upper limit is e square. When x is equal to e square, t is equal to what happens? T is log x. I am putting x equal to e square. So this becomes log e square. Log e square. Log e square is 2 log e. The value of log e is 1. So this becomes 2 into 1, which is equal to 2. Correct? So when x is e, t is 1. When x is e square, t is 2. So limits will change now. X is e to e square, t is 1 to 2. Log e means log e base e. Log e base e is 1. Log of a number to same base is 1. Correct? Log e is 1. Here also log e is 1. 1 into 2, 2. So t is 1 to 2. Correct? So this becomes integral from 1 to 2. What is dx? Dx is here. Dx is e power t dt from this step. Correct? Dx is e power t dt divided by log x is t. Log x is t. Integral from 1 to t e power t dt by t. That is same as integral from 1 to 2 e power x by x. Correct? Using property 1 actually. This is dependent on property 1 of definite integral. Integral from a to b f of x dx, same as integral from a to b f of t dt. Correct? Using property 1 of definite integral, I can tell the variables can be changed. Correct? Variables can be changed. The value of definite integral is not going to change. So this is same as nothing but I2. Correct? I2 is what? Integral from 1 to 2 e power x by x dx. This is nothing but I2. Started with I1, I am getting I2 by using substitution, and that to put t equal to log x and convert log to exponential form. Don't differentiate this directly. First write t equal to log x. From there we write x is equal to e power t, and that x equal to e power t differentiate with respect to t and change the limits. So I1 is equal to I2. I1 is equal to I2 is the answer. Option B is the answer. Hope it's clear. Log x and e power x are inverse functions of each other, and if t is equal to log x, x is e power t. That's a crucial step, important step to be noted here. That you differentiate. Don't differentiate directly t equal log x, because I am expressing log x in terms of e power x, so that I am comparing the two integrals I1 and I2. So I am getting I1 is equal to I2. And the last step is got by using property 1 of the definite integral. We have integral from a to b f of x dx. Integral from a to b f of x dx is same as integral from a to b f of t dt. Using this property, we got this from this step to this step. Lower limit and upper limits are same. The value of definite integral is going to be same if the only limits are same, only the variables are different. X or t, whatever, irrespective of the variable, the value of definite integral is not going to change. Correct? So if the variables are different, lower limit and upper limit is same, then the value of definite integral is going to be same. Correct? Is not going to change only if the variables are different. So I1 is equal to I2. Answer is option B, asked in the year 2000. Move on to the next one. Integral from 0 to pi by 2 cos x into sin x dx by 1 plus sin x. Because there is cos x into dx and denominator and numerator both contain sin, I will put t equal to sin x. Go by method of substitution. Put t equal to sin x. Put t equal to sin x. Derivative of sin x is cos x. dt is equal to cos x into dx. When x equal to 0, find out t equal to how much? When x equal to 0, t is equal to sin 0. Sin 0 is 0. When x is pi by 2, t equal to how much? Find out. When x equal to pi by 2, t is equal to sin pi by 2. Sin pi by 2 is 1. Correct? Limits will change. When x is 0, t is 0. When x is pi by 2, t is 1. Therefore, integral from 0 to 1. correct? X is 0, t is 0. When x is pi by 2, t is sin pi by 2, which is 1. So sin x is t, cos x into dx is dt, cos x into dx is dt, sin x is t. So this becomes t divided by 1 plus t dt, correct? Sin x is t, t by 1 plus t, cos x into dx is dt from this. Integral of t by 1 plus t. To integrate this, what I am going to do is add 1, subtract 1 in the numerator. Correct? This can be reduced to the standard form by adding and subtracting 1. Add and subtract 1 in the numerator. Then you can separate the terms. T by 1 plus t. How to integrate? Add 1, subtract 1. Because integrating any function, no, you have to reduce it to the standard form. Then only is possible to integrate. Now we can separate the terms. 1 plus t by 1 plus t becomes 1. So this becomes integral from 0 to 1. 1 plus t by 1 plus t is 1. Separate the terms. Divide this by this. Correct? 1 plus t. 1 plus t divided by 1 plus t dt minus integral from 0 to 1, 1 by 1 plus t. 1 plus t cancels. Integral from 0 to 1, 1 dt. Correct? Minus integral from 0 to 1, 1 by 1 plus t. Integral of 1 with respect to t is t. Limits from 0 to 1. Integral of 1 by 1 plus t. Log of mod 1 plus t divided limits from 0 to 1. If you want, you can divide by coefficient of t, which is 1. Correct? No need to divide also because it's 1. If you divide by 1 or don't divide by 1, that does not matter. Correct? Add 1, subtract 1, separate the terms. Integral of 1 with respect to t is t. 1 plus t by 1 plus t is 1. Add 1, subtract 1, separate the terms, divide individually. Correct? Integral of 1 by 1 plus t is log of mod 1 plus t divided by coefficient of t is 1. If you want, you can divide this by 1. So evaluate the function upper limit minus lower limit. What do we get? This is 1 minus 0, 1. Here upper limit, put t is equal to 1. What do you get? This is log of 1 plus 1, 2. Correct? Log 2 minus log of 1 plus 0 is 1. Log 1 is 0. Log 1 is 0. So what we get is 1 minus log 2. Correct? Log 1 is 0. What we get is 1 minus log 2. 1 minus log 2 is the answer. Option A. Question asked in the CET 2022 reasoning question. Because there is sin x in the numerator and denominator and cos x into dx is there, put t equal to sin x. So that you can integrate by method of substitution. T equal to sin x, differentiate, change the limits, express the given integral in terms of the new variable t and then integrate. To integrate this, we add 1, subtract 1 in the numerator, then separate the terms, divide individually. 1 plus t by 1 plus t is 1, 1 by 1 plus t. Integral of 1 by 1 plus t is log of mod 1 plus t. Evaluate the function in upper limit minus lower limit. 1 minus 0, 1. Here log 2 minus log 1. Log 1 is 0, so you get 1 minus log 2. Correct? Put t equal to 1, 1 plus 1 to log 2 minus log of 1 plus 0. Log 1 is 0, so you get 1 minus log 2. Option A. Move on to the next one. Question number 12 we have integral from 0 to 1 dx by e power x plus e power minus x. To integrate this, what I am going to do is, first you write e power minus x as 1 by e power x. You write e power minus x as 1 by e power x. Okay. So what do you get? The given integral becomes, take the integral as I, 0 to 1 dx by e power x plus e power minus x is equal to integral from 0 to 1 dx by e power x plus e power minus x is 1 by e power x. Correct? E power minus x is 1 by e power x. So this becomes integral from 0 to 1 e power x, you take LCM there, correct? Dx by, if you take LCM as e power x here, e power x into e power x becomes e power 2x. E power 2x plus 1. This e power x will go up. So this becomes integral from 0 to 1 e power x dx divided by 1 plus e power 2x is e power x square, right? 1 plus e power 2x. E power 2x written as e power x square. Now I can integrate this by method of substitution. Put t equal to e power x. Put t equal to e power x. Derivative of e power x is e power x. dt is equal to e power x into dx. When x is equal to 0, find out t equal to how much? When x is equal to 0, t is equal to e power 0, which is 1. Correct? When x is equal to 1, upper limit, t is equal to how much? Find out. When x is equal to 1, t is equal to e power 1, which is equal to e. Correct? So, when x is 0 to 1, t is 1 to e. T is 1 to e. E power x into dx is dt. E power x into dx is dt. Divided by 1 plus e power x is t. So, denominator is 1 plus t square. Correct? dt means 1 dt. Integral of 1 by 1 plus t square is tan inverse of t. Limits from 1 to e, which is tan inverse of e minus tan inverse of 1. Correct? So, which is equal to tan inverse of e minus tan inverse of 1 is pi by 4. So, tan inverse of e minus pi by 4. Option B is the answer. Quite simple question asked in the year 2018 CET exam. Okay. Write e power minus x as 1 by e power x. That's an important step. Then take LCM in the denominator. That e power x goes up. So, you get e power x by 1 plus e power 2x. E power 2x is e power x square, correct? Because the powers gets multiplied. 2 into x is 2x. Put t equal to e power x. Method of substitution. So that e power x into dx is dt by 1 plus t square. And express the limits in terms of the new variable t. When x is 0, t is e power 0, which is 1. When x is 1, t is e power 1. Limits from 1 to e. dt means 1 dt. Integral of 1 by 1 plus t square is tan inverse of t. Evaluate the function. Upper limit minus lower limit. Get the answer. Tan inverse of 1 is pi by 4. Tan inverse of e minus pi by 4 is the answer. Move on to the next one. Question number 13 we have integral from 0 to pi by 2 root of sine theta into cos cube theta d theta is equal to how much? Question asked in the year 2022, recent year question itself. Because the power of cos is odd number and sine theta is present inside the root, the substitute is going to be t equal to sine theta. Correct? What is highlighted is root here. Correct? Whatever present inside the root, whatever present in the power, such things, normally we take it as t whenever the functions are there. So here we put t equal to sine theta, correct? So derivative of sine theta is cos theta. So we can integrate by method of substitution. Our main aim is to reduce the integral to the standard form. Then only it's possible to integrate. So here we can integrate this by method of substitution by putting t equal to sine theta. And cos cube theta we can write it as cos square into cos. We can split cos cube as cos square into cos. And of course cos square we can write 1 minus sine square. So given integral becomes, I'll write the integral as I is equal to integral from 0 to pi by 2, 0 to pi by 2, root of sine theta into cos cube theta d theta, which is equal to integral from 0 to pi by 2, root of sine theta, cos cube theta we can write it as cos square theta into cos theta d theta. Then write cos square theta as 1 minus sine square theta. Integral from 0 to pi by 2, root of sine theta, cos square theta write 1 minus sine square theta into cos theta d theta. To integrate this, I'll use put t equal to sine theta because derivative of sine is cos. Cos theta d theta is there means you put t equal to sine theta. Put t equal to sine theta using the method of substitution. dt is equal to cos theta into d theta, correct? Differentiating with respect to theta. Change the limits. Whenever you make a substitution, differentiate and change the limits. When theta is equal to 0, t equal to sine 0. Sine 0 is 0. When theta is equal to pi by 2, t is equal to sine pi by 2, which is 1. Correct? When theta is 0, t is sine 0, 0. Theta is pi by 2, t is sine pi by 2, which is 1. Correct? Limits will change. 0 to 1. Theta is 0 to pi by 2. T is 0 to 1. Root of sin theta is t into 1 minus sin theta is t. So this becomes t square. Cos theta into d theta is dt. Correct? Cos theta into d theta is dt from this. Put t equal to sin theta. Now multiply this and then integrate. Root t into 1 is root t. This becomes integral from 0 to 1 root t minus t square into root t. T square into root t is t power 5 by 2. Correct? T power 5 by 2. T square into root t. Because t square is root t is t square into root t is t power half. Correct? T power 2 plus half, 2 and half, that is 5 by 2. Integrate this. Integral of root x is 2 by 3 x root x. Integral of root t is 2 by 3 t root t. And integral of t power 5 by 2 is t power 7 by 2 divided by 7 by 2. Limits from 0 to 1. Evaluate the function at upper limit minus lower limit. 2 by 3 into value of t is 1. 1 root 1 minus 0. Correct? 1 minus 0. Here 1 by 7 by 2 is 2 by 7. 2 by 7. Evaluate the function in upper limit. 1 power 7 by 2 minus 0 power 7 by 2. 1 minus 0, which is 1. Correct? So what we get is 2 by 3 minus 2 by 7. Take LCM. 7 and 3 LCM is 21. 3 7s are 21. 7 2s are is 14. 7 3s are 21. 3 into 2 is 6. So we get the answer as 8 by 21. Option C is the answer. 8 by 21. Quite good question compared to earlier questions we had. 2022 integration by method of substitution is asked. Correct? Integral of root x is 2 by 3 x root x, or integral of root x is 2 by 3 x power 3 by 2 also you can remember. Correct? Integral of root x power half, root x means x power half. Integral of x power half is x power 3 by 2 by 3 by 2, just 2 by 3 x root x. Integral of t power 5 by 2, so t power 5 by 2 plus 1 by 5 by 2 plus 1. T power 7 by 2 by 7 by 2. Correct? Limits from 0 to 1. Upper limit minus lower limit. 2 by 3 into 1 minus 0 minus 2 by 7 into 1 minus 0. 2 by 3 minus 2 by 7. LCM of 3 and 7 is 21. 3 7s are, 7 2s are 14. 7 3s are, 3 into 2 6. 14 minus 6 8. 8 by 21. Move on to the next one. Question number. Yeah, we have some integration by suitable substitution. Whenever there is root 1 minus x square, you put either sin theta or cos theta. Root of 1 plus x square, you put x equal tan theta or cot theta. All these things you must know. Root of x square minus 1 means we put x equal to secant theta or cosec theta, depending upon given condition. All these kind of substitution we learnt even in differentiation chapter and inverse trigonometry functions also. Correct? And if it is root of 1 plus x, root of 1 minus x, we put either x equal to cos theta or cos 2 theta. If it is root of x by 1 minus x or root of 1 minus x by x, we put x equal to sin square theta or cos square theta. If it is root of x by 1 plus x or root of 1 plus x by x, we put x equal to tan square theta or cot square theta. If it is root of x by x minus 1 or if it is root of x minus 1 by x, we put x equal to secant square theta or cosecant square theta. Okay, so all these things you must know. Okay, please learn these kind of substitution, quite useful in even in integration chapter. More generally, I gave another table here. So here it is in terms of a root of a square minus x square. Put x equal to a sin theta or a cos theta. If it is root of a square plus x square, put x equal to a tan theta or a cot theta. If it is root of x square minus a square, put x equal to a secant theta or x equal to a cosec theta. If it is root of x square minus a square, put x equal to a secant theta or a cosecant theta. If it is root of a plus x or root of a minus x, in that case put x equal to a cos theta or x equal to a cos 2 theta. If it is root of x by a minus x or root of a minus x by x, in that case you put x equal to a sin square theta or a cos square theta. If it is root of x by a plus x or root of a plus x by x, in that case we put x equal to a tan square theta or a cot square theta. If it is root of x by x minus a or root of x minus a by x, we put x equal to a secant square theta or x equal to a cosecant square theta. And lastly, we have x equal root of a minus x by x minus b or root of a minus x into x minus b. We put x equal to a cos square theta plus b sin square theta. All these things you should learn. Okay. So based on this also we got some questions, or not two questions are there based on this. One question is here, integral from 0 to half dx by 1 plus x square into root 1 minus x square. Here 1 plus x square and root 1 minus x square both are present. If it is root 1 minus x square, we put sin theta or cos theta. If it is 1 plus x square, we put tan theta or cot theta, correct? So here both are present. My aim is to reduce the integral to the standard form. So what we do is, because there is root 1 minus x square, I'll put x equal to sin theta and derivative of sin is also cos. So dx and root of 1 minus x square both become same when you put x equal to sin theta. So that is easier for me to integrate. So I'll put x equal to sin theta and proceed here. Put x equal to sin theta. Put x equal to sin theta. So that derivative of sin theta is cos theta. Dx is equal to cos theta into d theta. Change the limits. When x equal to 0, theta is equal to how much? Theta is equal to sin theta is 0. Sin theta is 0 means theta is equal to 0. When x equal to upper limit is half. Correct? When x equal to upper limit is half. So sin theta is half. Sin theta is half. That means theta is equal to pi by 6. Correct? When x is 0, sin theta is 0. So theta is 0. When x is half, half equal to sin theta. So theta is sin inverse of half, which is pi by 6. So express this in terms of theta now. The given integral I I'll call I is equal to, okay. So therefore the I becomes equal to what now? X is 0, theta is 0. X is half, theta is pi by 6. Dx is what? Cos theta d theta. Cos theta d theta divided by 1 plus x is sin theta. So this becomes sin square theta into root of 1 minus sin square theta. Putting x equal to sin theta. And 1 minus sin square theta is cos square theta. Root of cos square theta is mod of cos theta. But in the interval 0 to pi by 6, cos theta is positive. So root of cos square theta becomes mod of cos theta. Mod of cos theta is cos theta. 1 minus sin square is cos square theta. Root of cos square theta is mod of cos theta. Mod of cos theta becomes cos theta because cos theta is positive in the interval 0 to pi by 6. This becomes integral from 0 to pi by 6. What we have? Cos theta into d theta divided by 1 plus sin square theta into cos theta. Correct? Cos theta is going to cancel. 1 minus sin square, cos square theta. Root of cos square theta is mod of cos theta. Correct? Root of cos square theta is equal to mod of cos theta. And mod of cos theta is cos theta because cos theta is positive. Theta lies in the interval 0 to pi by 6. 0 to pi by 6 is part of the first quadrant. First quadrant, every trigonometry function is positive. Cos theta, because cos theta is positive. Cos theta is going to cancel. What you get is integral from 0 to pi by 6. 1 by 1 plus sin square theta d theta. Cos theta is going to cancel. To integrate this, what we do is we divide numerator and denominator by cos square theta. Integral of the type 1 by a square plus b square sin square theta can be integrated by dividing both numerator and denominator by cos square theta. Divide both numerator and denominator by cos square theta here. Divide both numerator and denominator by cos square theta. Therefore, the given integral I becomes equal to what? Integral from 0 to pi by 6. 1 by cos square theta is secant square theta. Numerator becomes secant square theta divided by 1 by cos square theta is secant square theta. Sin square theta by cos square theta is tan square theta. And derivative of tan is secant square. So in the denominator secant square, I'll write it as 1 plus tan square theta using the trigonometric identity. This secant square is going to be equal to 1 plus tan square theta. Okay, so 1 plus tan square becomes 1 plus 2 tan square theta. 0 to pi by 6 secant square theta divided by 1 plus 2 tan square theta. To integrate this, we'll put u is equal to root 2 tan theta. Okay, put u is equal to root 2 tan theta. From this, du by d theta is equal to root 2 into secant square theta. And also change the limit. Secant square theta into d theta becomes a du by root 2 from this. Correct? Du divided by root 2 is equal to secant square theta into d theta. Limits will change now again. When theta is equal to 0, find out u is equal to how much. When theta equal to pi by 6, find out u is equal to how much. That will do it here. When theta is equal to 0, theta is equal to 0, u is equal to how much? Theta is 0, tan 0, 0, 0 into root 2, 0, u is 0. Theta is equal to pi by 6, u is equal to how much? Tan pi by 6 is 1 by root 3, 1 by root 3 into root 2 by root 3, which is root of 2 by 3. Correct? Root of 2 by 3 I get. So limits will change now. 0 to root of 2 by 3. Secant square theta into d theta is du by root 2 divided by 1 plus u square. 1 by root 2 keep outside. 1 by root 2 keep outside. Integral of 1 by 1 plus u square is tan inverse of u. Tan inverse of u. Limits from 0 to root of 2 by 3. Correct? This is equal to 1 by root 2 into. Evaluate the function in upper limit minus lower limit. Lower limit is 0. Tan inverse of 0 is 0. Upper limit is root of 2 by 3. So tan inverse of root of 2 by 3. We get the answer as option E. Tan inverse of root of 2 by 3. Correct? Option A is the answer. Hope it's clear. 2 times we make a substitution here. Question asked in the year 2018. One by root 2 tan inverse of root of 2 by 3 minus tan inverse of 0 is 0. Option A is the answer. Hope it's clear. Dividing numerator and denominator by cos square theta. Integrals of the type 1 by a square plus b square sin square theta should be integrated by dividing both numerator and denominator by cos square theta. Then use secant square as 1 plus tan square. 1 plus tan square becomes 1 plus 2 tan square. Numerator keep as it is. Denominator secant square theta change it to 1 plus tan square theta using trigonometric identity. Then make a substitution u is equal to root 2 tan theta. Expressed in terms of u. Everything. Even the integrand as well as the lower limit and upper limit. Please make a note. Question asked in the year 2018. Move on to the next one. Integral from 1 by 2 to 1 by root 2 dx by x square into root 1 minus x square. Because there is root 1 minus x square, I'll make a substitution, put x equal to sin theta here. Put x equal to sin theta and proceed. Put x equal to sin theta. Derivative of sin theta is cos theta, correct? Dx equal to cos theta into d theta. Change the limits. When x equal to half, theta equal to how much? When x equal to half. Half equal to sin theta. So theta is equal to pi by 6. Correct? Sin theta is half means theta is pi by 6. When x is 1 by root 2. When x is 1 by root 2. What do you get? Sin theta is 1 by root 2. So theta is pi by 4. Correct? When x is 1 by root 2, sin theta is 1 by root 2. Sin theta 1 by root 2 means theta is pi by 4. So limits change. Write everything in terms of theta. Take this integral as I. Therefore, the given integral I is equal to what we have? 1 by 2 to 1 by root 2. Correct? Dx by x square into dx by x square into root of 1 minus x square we have. Limits will change. Limits, lower limit is pi by 6. Upper limit is pi by 4. Dx is cos theta into d theta. X is sin theta. So this is sin square theta here. Root of 1 minus sin square theta. 1 minus sin square theta is cos square theta. Root of cos square theta is mod of cos theta. Mod of cos theta is cos theta because cos theta is positive in the interval pi by 6 to pi by 4. So this will become integral from pi by 6 to pi by 4. Cos theta d theta divided by sin square theta into cos theta. Cos theta cancels. Integral from pi by 6 to pi by 4. Correct? Cos theta cancels. 1 by sin square theta is cosecant square theta. And integral of cosecant square theta is minus cot theta. Limits from pi by 6 to pi by 4. Evaluate the function at upper limit minus lower limit. Minus cot of pi by 4 minus cot of pi by 6. Cot pi by 4 is 1. Cot pi by 6 is root 3. Correct? Tan pi by 6 1 by root 3. Correct? Tan pi by 6 1 by root 3. Cot pi by 6 root 3. Minus we multiply inside. We get minus into minus plus root 3 minus 1. Root 3 minus 1. Option C is answer. Question asked in the year 1984. Good question. Okay. Putting x equal to sin theta by using method of substitution. Root of 1 minus x square is there. So put x equal to sin theta. Derivative of sin is cos. Root of 1 minus sin square also cos. Cos cancels. 1 by sin square cosecant square. Integral of cosecant square is minus cot theta. Limits from pi by 6 to pi by 4. Evaluate the function at upper limit minus lower limit. Cot pi by 4 is 1. Cot pi by 6 root 3. Minus multiply inside. Get root 3 minus 1. Minus 1 plus root 3 which is root 3 minus 1. Move on to the next one. Next we have use of trigonometric identities. All these things you know, trigonometric identities. The Pythagorean relationships, Pythagorean identities we call. Square relationships in trigonometry. Sin square plus cos square 1. 1 plus tan square is secant square. 1 plus cot square cosecant square. All these things you must know. Double angle formula. Sin 2 theta, cos 2 theta, tan 2 theta. All these things you must be knowing. Okay. Then only we can work out the problems based on these concepts. Okay. So all the formulas, the triple angle formula, sin 3 theta, 3 sin theta minus 4 sin cube theta, cos 3 theta, 4 cos cube theta minus 3 cos theta, tan 3 theta, 3 tan theta minus tan cube theta by 1 minus 3 tan square theta. All these formulas are quite important. Power reducing formula, cos square theta, 1 plus cos 2 theta by 2 sin square theta, 1 minus cos 2 theta by 2. Half angle formulas are also important. Sin theta, 2 sin theta by 2 cos theta by 2 is equal to 2 tan theta by 2 by 1 plus tan square theta by 2. Cos theta equal to cos square theta by 2 minus sin square theta by 2 is equal to 2 cos square theta by 2 minus 1 is equal to 1 minus 2 sin square theta by 2 is equal to 1 minus tan square theta by 2 by 1 plus tan square theta by 2. Tan theta is equal to 2 tan theta by 2 by 1 minus tan square theta by 2. 1 minus cos theta, 2 sin square theta by 2. 1 plus cos theta, 2 cos square theta by 2. All these things you must know. There are some defactorization formula converting the product to sum, correct? And also we have the factorization formula is not important. Defactorization formula is important here, okay? So the first question we have integral from 0 to pi sin x by 2 cos x by 2. Same question is found in the NCERT textbook nowadays, correct? You know sin x is 2 sin x by 2 cos x by 2, correct? We have the half angle formula, sin x as 2 sin x by 2 cos x by 2. So from this sin x by 2 cos x by 2 will be sin x divided by 2. So given integral becomes 0 to pi sin x by 2 into cos x by 2 is going to be equal to how much? Sin x divided by 2. Sin x divided by 2. Correct? Sin x by 2 into cos x by 2 is sin x divided by 2. Divide by 2 means keep 1 by 2 outside. Integral of sin is minus cos. Integral of sin is minus cos. Limits from 0 to pi. Evaluate the function. Upper limit minus lower limit. Minus half into upper limit is pi. Cos pi minus cos 0. Correct? Sin x by 2 into cos x by 2 is sin x divided by 2. Divide by 2 means keep 1 by 2 outside. Integral of sin is minus cos. Correct? So minus kept outside, minus half into. Evaluate the function at upper limit. Cos pi is minus 1. Cos 0 is 1. So this becomes minus half into minus 2, which is equal to plus 1. Option A is the answer. Hope it's clear. Using half angle formula, sin x by 2 cos x by 2 is sin x divided by 2. Divide by 2 means 1 by 2 keep outside. Integral of sin is minus cos. Minus half kept outside. Cos pi minus cos 0. Cos pi is minus 1, cos 0 is 1. Minus 2 into minus half plus 2. 2 cancels. Answer is 1. Question asked there 1984. Move on to the next one. Integral from 0 to pi by 4 tan square x dx. We don't have a ready formula to integrate tan square x, you must know. Tan square and cot square, we don't have a ready formula. Whenever I get tan square, we should write secant square minus 1. And whenever I get cot square, we should write cosecant square minus 1. So write tan square x as secant square minus 1 and then integrate. 0 to pi by 4 tan square x dx is equal to integral from 0 to pi by 4 secant square x minus 1. Tan square x, right? Secant square x minus 1. Integral of secant square x is tan x. Integral of 1 is x. Limits from 0 to pi by 4. Evaluate the function at upper limit minus lower limit. Tan pi by 4 minus pi by 4. Upper limit, lower limit, x equal to 0. Tan 0 minus 0. Correct? Tan pi by 4 is 1. 1 minus pi by 4. Tan 0 is 0. 0 minus 0 is 0. 1 minus pi by 4. Option B is answer. Tan square x, right? Secant square minus 1. Then integrate. Integral of secant square is tan. Integral of 1 is x. Evaluate the function in upper limit. Tan pi by 4 minus pi by 4 minus tan 0 minus 0. This part is entirely 0. Tan 0 is 0. 0 minus 0 is 0. This part is 0. Tan pi by 4 is 1. 1 minus pi by 4. Option B. Question asked there. 1985 and 1994. 2 times. Same question is asked. Move on to the next one. Integral from 0 to 2 pi root of 1 plus sin x by 2 dx. Question asked in the year 2025. Most recent question. Here we will simplify this. 1 could be written as cos square plus sin square. Our main aim is to simplify it first. Okay. So I will be using some of the half angle formulas and trigonometric arithmetics. We know sin theta is 2 sin theta by 2 cos theta by 2. Sin theta is how much? 2 sin theta by 2 cos theta by 2. Sin x by 2 will be how much? So replace theta by x by 2. In place of theta, you put x by 2. Sin x by 2 is equal to how much? 2 sin x by 2 by 2 x by 4 into cos x by 2 by 2 x by 4. Put theta as x by 2. Wherever there is theta, you put x by 2. Theta by 2 becomes x by 4. Theta is x by 2. x by 2 becomes x by 4. So this I'll simplify. Integral from 0 to 2 pi, integral from 0 to 2 pi, square root of 1, I'll write it as cos square x by 4 plus sin square x by 4. 1 is cos square plus sin square. Because the angle present is x by 4 here, I'll express 1 in terms of sin square and cos square. Sin square x by 4 plus cos square x by 4, right? 1 could be written as cos square x by 4 plus sin square x by 4. 1 is cos square x by 4 plus sin square x by 4. Sin x by 2 is 2 sin x by 4 cos x by 4. This takes the form a square plus b square plus 2ab, which is a plus b the whole square. I can complete the square for this. So this becomes integral from 0 to 2 pi, 0 to 2 pi, root of cos x by 4 plus sin x by 4 the whole square. Cos x by 4 plus sin x by 4 the whole square. Root of x square is mod x, correct? Root of x square is equal to mod x. You must know this. So many times I am insisting on this. Many students make mistake here. Root of x square is not x. Root of x square is mod x, strictly speaking. So root of cos x by 4 plus sin x by 4 the whole square is mod of cos x by 4 plus sin x by 4. This becomes integral from 0 to 2 pi mod of cos x by 4 plus sin x by 4. X belongs to the interval 0 to 2 pi. So x by 4 lies in which interval if I know? X belongs to, according to this, dx means the variable is x for the integral. X is 0 to 2 pi. X belongs to the interval 0 to 2 pi. X by 4 belongs to which interval? X by 4 belongs to 0 by 4 is 0. 2 pi by 4 is pi by 2. Correct? X belongs to 0 to 2 pi. X by 4 means divide by 4. 0 by 4 is 0. 2 pi by 4 is pi by 2. So in the interval 0 to pi by 2, cos plus sin is positive. Both are positive. In the first quadrant, 0 to pi by 2 is first quadrant. In first quadrant, every trigonometry function is positive. Cos x by 4 is positive. Sin x by 4 is positive. Positive plus positive is positive. This entire thing is positive. Correct? Is positive. So mod of x becomes x. Mod x is x if x is greater than or equal to 0. Because the terms inside the mod is positive, mod of cos x by 4 plus sin x by 4 becomes cos x by 4 plus sin x by 4. This becomes integral from 0 to 2 pi. I'll put bracket here, cos x by 4 plus sin x by 4. And integral of cos is sin. Integral of sin is minus cos. And when you integrate, you divide by coefficient of x because linear term is there, correct? Instead of x, they given x by 4. After integrating, you divide by coefficient of x. Integral of cos is sin. Sin x by 4 divided by coefficient of x is 1 by 4. Integral of sin is minus cos. Minus cos x by 4 divided by coefficient of x is 1 by 4. Limits from 0 to 2 pi. 1 by 4 is 4, correct? This becomes 4 times. Evaluate the function at upper limit. 2 pi. 2 pi by 4 is pi by 2. Sin pi by 2 minus sin 0 it becomes. Sin pi by 2 minus sin 0. 1 by 4 is 4. Evaluate the function at upper limit. 2 pi by 4, that is pi by 2. Cos pi by 2 minus cos 0. Correct? 1 by 4 is 4. Evaluate the function at upper limit minus evaluate the function at lower limit. Sin pi by 2 is 1. This becomes 4 into 1 minus 0 minus 4 into cos pi by 2 is 0. Cos 0 is 1. So what do you get? 4 into 1, 4. Here minus into minus becomes plus. 4 plus 4 is equal to 8. Answer is 8. Option D. 2025 CET exam. This year. Most recent question. Okay. Please make a note. On to the next one. Next we have integration by parts. One of the most important methods. Integral of first into second is first function keep as it is. Integrate the second minus integral of integrate the second, differentiate the first. You must know this formula. And also integrals of inverse trigonometry functions and all you must know. And isolate rule is there. Correct? I'm just recalling you that whenever you want to integrate using the integration by parts formula, integral of first into second, then formula if you want to apply, the first and the second function should be selected in according to the order of occurrence in isolate. I stands for inverse trigonometry function, L is logarithmic function, A is algebraic function, T is trigonometric function, E is exponential function, correct? So I have given the list of all these things. Inverse trigonometry function, you know, sin inverse x, cos inverse x, tan inverse x, etc. Logarithmic function, you know, log x base e, log x base 10, all those things are logarithmic function. Algebraic function, x square, 1 plus x, 2 plus x, all those things are algebraic function. Correct? T is trigonometry function, sin x, cos x, tan x, all those things. E is exponential function, e power x, a power x, 10 to the power x, 5 to the power x, all those things. So in according to the order of occurrence of isolate, we take the first and the second function normally. Okay. So, and this is, you have to remember actually for competitive exams, better to remember integral of log x is x log x minus x plus c. Integral of sin inverse of x is x into sin inverse of x plus root of 1 minus x square plus c. Integral of cos inverse x is x into cos inverse x minus root 1 minus x square plus c. Integral of tan inverse x into tan inverse x minus half log 1 plus x square plus c. Integral of cot inverse x is x into cot inverse x plus half log 1 plus x square plus c. Integral of secant inverse of x is x into secant inverse x minus log of mod x plus root x square minus 1 plus c. Integral of cosec inverse x is x into cosec inverse x plus log of mod x plus root of x square minus 1 plus c. All these things better to learn. Okay, memorize this so that you can answer the question instantly in lesser time. You can save the time. Okay, the first one we have integral from 1 to e log x dx. 1 to e log x dx. We know integral of log x is x log x minus x. Correct? That's to find integral from 1 to e log x into dx. Integral of log x is, we know, x log x minus x. X log x minus x. Limits from 1 to e. Evaluate the function at upper limit minus lower limit. What we get? This is e log e log e minus e, upper limit over, minus lower limit. Put x equal to 1. Wherever there is x, you put 1. 1 log 1 minus 1. Correct? Putting x equal to upper limit, e log e minus 1 log 1 minus 1. Log e value is 1, correct? Log e is 1. So e into 1, e minus e. Because log e means log e base e, which is 1. So e into 1, e minus e. Here log 1 is 0. Log 1 is 0. So 0 minus 1. Log 1 is 0. Correct? E minus e is 0. E minus e is 0. Minus of minus becomes plus 1. Answer is 1. Option D. 2 times asked in the 1994 and 1985. Learn this, very important. Integral of log x is x log x minus x. Limits from 1 to e. Evaluate the function at upper limit minus evaluate the function at lower limit. Log e is 1, 1 into e, e minus e is 0. Log 1 itself is 0, 0 minus 1, minus of minus plus 1. Move on to the next one. Integral from 0 to 1, tan inverse x dx. Just now I told to remember integral of tan inverse x into tan inverse x minus half log 1 plus x square. Please learn it. Remember the integrals of inverse trigonometric function as well as logarithmic function so that you can save the time. Integral of tan inverse of x is what? X into tan inverse x minus half log 1 plus x square. Limits from 0 to 1. Evaluate the function at upper limit minus lower limit. What do we get? This is 1 into tan inverse 1, 1 into tan inverse 1 minus half into log of 1 plus 1, that is 2. Upper limit, put wherever there is x, you put x equal to 1. Now put 0. Wherever there is x, you put 0. Get 0 into tan inverse of 0 minus half into log of 1 plus 0. 1 plus 0 square is 1. Tan inverse of 1 is pi by 4 minus half log 2. Tan inverse of 0 is 0. Log 1 is 0. Correct? Tan inverse of 0 is 0. Log 1 itself is 0. Half into 0, 0. 0 minus 0, 0. This part is gone, 0. So answer is pi by 4 minus half log 2. Option C is the answer. Integral of tan inverse x. X into tan inverse x minus half log 1 plus x square. Please learn this formula. Evaluate the function at upper limit minus evaluate the function at lower limit and get the answer. 1 into tan inverse 1 minus half log 1 plus 1. Correct? Pi by 4 minus half log 2. Lower limit is 0. 0 into tan inverse 0. Log 1 is 0. 0 minus 0. This part is completely 0. Correct? Please make a note of this. Question asked in the year 1993. On to the next one. Integral from 0 to pi x into cos x dx. Here also we can integrate by parts and get the answer. Integral from 0 to pi x into cos x. X is algebraic, cos x is trigonometric. According to Eilert, algebraic is first, then comes trigonometric, correct? According to Eilert, algebraic is first, then comes trigonometric. So integral of first into second. Integral of first into second. First function keep as it is. Integrate the second function. Integral of cos x is sin x. Minus integral of. Integrate the second function. Differentiate the first function. Correct? Integral of. Integrate cos x. Differentiate the first function. Derivative of x is 1. Limits from 0 to pi. 0 to pi. Correct? First function keep as it is. Integrate the second function. Integral of cos is sin minus integral of. Integrate the second function. Differentiate the first function. Take the upper limit. Upper limit is pi. Pi sin pi. Correct? Minus 0 into sin 0. Upper limit minus lower limit. Evaluate the function at upper limit minus evaluate the function at lower limit. Integral of sin is minus cos. Correct? Minus of minus plus cos x. Limits from 0 to pi. Sin pi is 0. Sin 0, 0. Both are 0. Correct? 0, 0. This part is entirely 0. And integral of sin is minus cos. Minus of minus plus cos. Here evaluate the function at upper limit minus lower limit. What do we get? This is cos pi minus cos 0. Cos pi is minus 1. Cos 0 is 1. correct? Minus 1, which is minus 2. Option C is answer. Integral of first into second. First function keep as it is. Integrate the second. Minus integral of. Integrate the second. Differentiate the first. Evaluate the function in upper limit minus lower limit. This part is entirely 0. Integral of sine is minus cos. Minus of minus plus cos. Cos pi minus cos 0. Cos pi is minus 1. Cos 0 is 1. Minus 2 is answer. Move on to the next one. Integral from minus 1 to plus 1. X into e power x dx. Now also integrate this by parts. Okay. So x is algebraic, e power x is exponential, correct? According to Eilert, x is first function, x is algebraic, e power x is exponential. Integral of first into second. Apply the formula. All board exam level type of questions. Simple questions. X is my first function, e power x is second function. Integral of first into second. First function keep as it is. Integrate e power x minus integral of integrate e power x, derivative of x is 1, correct? First function write as it is, integrate the second function minus integral of integrate the second function, differentiate the first function. Here limits from minus 1 to plus 1. Integrate from minus 1 to plus 1. Evaluate the function in upper limit minus lower limit. What do you get? 1 into e power 1 minus 1 into e power minus 1. Correct? Upper limit 1 e power minus 1 minus 1 into e power minus 1. Integral of e power x is e power x. Limits from minus 1 to plus 1. E power 1 is e. Minus of minus plus. E power minus 1, which is 1 by e I can write. Minus of, here upper limit, e power 1 minus e power minus 1. Correct? So what we get is e plus 1 by e minus e, minus into minus plus, e power minus 1 is 1 by e minus e is becoming 0, 1 by e plus 1 by e is 2 by e. 2 by e is answer. Correct? First function keep as it is, integrate the second, minus integral of, integrate the second, differentiate the first. Evaluate the function at upper limit minus lower limit. 1 e power 1 minus 1 e power minus 1. Here, integral of e power x, upper limit minus lower limit, e power 1 minus e power minus 1. E power 1 is e minus e cancels, 1 by e plus 1 by e becomes 2 by e, option A. Question answer there, 1989. Move on to the next one. Integral from 0 to 2, 0 to 1, x square into e power x dx. Integral from 0 to 1, x square into e power x dx. Here I can use one, you can use integration by parts, otherwise I can use one time saving result here, that is integral of uv. Okay, note down this result, integral of uv with respect to x is equal to first function keep as it is, integrate the second, minus differentiate the first, integrate the second, plus differentiate the first, integrate the second, minus differentiate the first, integrate the second. Like this it goes on until it becomes 0. Where this kind of result is applicable for integrals of this type. Integral of x power n into e power x, x power n into cos x, x power n into cos x, x power n into sin x. These type of integral we can apply this result. First function keep as it is, integrate the second function, minus differentiate the first, integrate the second, plus differentiate the first, integrate the second. Go on, continue, alternate plus minus. Also we have integral of this type, x power n into a power x dx. All these four, no, we can integrate by these type of integrals can be done by this method. So I'll apply that formula now. Integral of x square e power x. Otherwise, you have to apply integration by parts 2 times. To save the time, I can write the answer at one stretch. Integral from 0 to 1, x square into e power x dx is it. Correct? X square is algebraic. E power x is exponential. Correct? First function is algebraic here. Exponential is last according to Eilert. Eilert is there, no? Exponential is always last. Algebraic comes before exponential. So x square is algebraic, first function. E power x is second function. So if you integrate this by using this method, first function keep as it is. First function you write as it is, x square. Integrate e power x. Integral of e power x is e power x minus. Differentiate the first, integrate the second. Derivative of x square, 2x. Integral of e power x plus differentiate 2x, 2. Integrate e power x. Next step becomes 0. Derivative 2. Next step will be 0. Over. One stretch, I can write the answer. Limits from 0 to 1. Clear? I repeat once again. First function keep as it is. Integrate the second function. Integral of e power x minus. Differentiate the first function. Derivative of x square, 2x. Integrate e power x. Differentiate 2x, that is 2. Integrate e power x. Next term will be derivative 2, 0. Alternate plus minus. You follow? Alternate plus minus. First function write as it is. Integrate the second function minus. Looking at this term, differentiate the first function, integrate the second function. Plus, differentiate the first function, integrate the second function. Derivative of 2x, 2. Integral of e power x. Next term will be 0. Derivative of 2 will be 0. Correct? Evaluate the function at upper limit. 1 square into e power 1 minus 2 into 1 into e power 1. Putting x equal to 1. Wherever there is x, you put 1. 1 square e power 1. 1 square is 1. 1 into e power 1 minus 2 into e power 1 plus 2 into e power 1. Upper limit. Put x equal to 1. Wherever there is x, you put 1 here. Understood? 1 square e power 1. That is 1 into e. Minus 2 into 1 into e. E power 1 is e. Plus 2 into e power 1. Lower limit is 0. Put x equal to 0. 0 square into this. 0. 2 into 0. 0. Plus 2 into e power 0. Correct? Lower limit is 0. 0. 0. 2 into e power 0. Correct? This is e. Minus 2e plus 2e cancels. Minus 2e plus 2e will cancel. This will become 0. Correct? E remains here. Here e power 0 is 1. 0, 0, 2 into e power 0. E power 0 is 1. 2 into 1, 2. Minus 2. So e minus 2 is the answer. E minus 2. Option A. Hope it's clear. Question answer in the year 1988. Move on to the next one. Integral from 0 to 1 sin inverse 2x by 1 plus x square. Here also I advise you to learn these formulas, even though it's not found in the NCERT book nowadays, because some of them are deleted from ITF chapter also. So please learn these formulas. I recommend to learn these formulas. There are 3 formulas for 2 tan inverse x. 2 tan inverse of x is equal to sin inverse of 2x by 1 plus x square. Sin inverse of 2x by 1 plus x square. This is for x belonging to the closed interval minus 1 to plus 1. Okay. Another one is cos inverse of 1 minus x square by 1 plus x square. This is for x greater than or equal to 0. And the third one is this tan inverse of 2x by 1 minus x square. This is for x belonging to the open interval. X belonging to the open interval minus 1 to plus 1. Please learn these 3 formula. Okay. Now sin inverse of 2x by 1 plus x square is given. That becomes equal to tan inverse x. That is true for x belonging to the closed interval minus 1 to plus 1. So here the interval is 0 to 1. So it is part of this. The interval 0 to 1 is the part of this. So I can apply this formula. So this becomes integral from 0 to 1. Integral from 0 to 1 sin inverse of 2x by 1 plus x square. Sin inverse of 2x by 1 plus x square. This becomes equal to 2 tan inverse x. Correct? Integral from 0 to 1 to tan inverse x dx. 2 you keep outside. Integral from 0 to 1 tan inverse x dx. We know integral of tan inverse x is x into tan inverse x minus half log 1 plus x square. Apply that formula and evaluate the function at upper limit minus lower limit. Get the answer. 2 times integral of tan inverse x into tan inverse x minus half log 1 plus x square. Limits from 0 to 1. Evaluate the function at upper limit minus evaluate the function at lower limit. 2 into upper limit is 1. So what do you get? 1 into tan inverse 1 minus half into log of 1 plus 1. 1 plus 1 is 2. Upper limit. Now lower limit x equal to 0. 0 into tan inverse 0 minus half into log of 1 plus 0. This is 1. This is equal to 2 into tan inverse 1 is pi by 4 minus half log 2. This part is entirely 0. Log 1 is 0. Tan inverse 0 is 0. This part is gone. 0. No need to write that. So multiply this and write. What do you get? This is equal to 2 into pi by 4 is pi by 2. Correct? 2 into pi by 4 is pi by 2. 2 into half log 2 is half log 2. 2 cancels. So pi by 2 minus log 2, which is option C. Learn two things. One is sin inverse of 2x by 1 plus x square is 2 tan inverse x. 2 is kept outside. Integral of tan inverse x is x into tan inverse x minus half log 1 plus x square. Limits from 0 to 1. Evaluate the function at upper limit minus lower limit. Earlier they asked only integral from 0 to 1 tan inverse x. There we got pi by 4 minus half log 2. Correct? In the previous question we had pi by 4 minus log half log 2 we had. This question we had pi by 4 minus half log. Now it's double of this. Double of this is pi by 2 minus log 2. Correct? Pi by 2 minus log 2. Question asked in the year 1999. Please make a note. Two things if we learn, we can answer this question in 15 to 20 seconds maximum. Correct? No need to take even 1 minute. Next one we have in is equal to integral from 0 to 1 x power n into e power minus x dx. Want to find for all n belongs to natural numbers are given. Want to find I7 minus 7 times I6. So we'll integrate this by parts first. Consider in is equal to integral from 0 to 1 x power n into e power minus x dx. X power n is algebraic, e power minus x is exponential. According to Eilert, algebraic comes first, then comes exponential. Correct? Algebraic is first, exponential is next. So this is first function. This is second function. Integrate by parts. Integral of first into second. First function keep as it is. First function keep as it is. Integrate second function. Integral of e power minus x. E power minus x by minus 1. Minus. Integrate the second function. E power minus x divided by minus 1. Derivative of x power n is n into x power n minus 1. Here limits from 0 to 1 for this. Integral from 0 to 1 here. If you evaluate the function at upper limit, x equal to 1, put x equal to 1. 1 power n is 1, correct? 1 into e power minus 1, correct? Put x equal to 1. E power minus 1 divided by minus 1. Putting x equal to 1. 1 to the power n is 1. 1 into e power minus 1 by minus 1. Lower limit is 0. 0 is, this becomes 0. 0 power n is 0. Lower limit is 0. Minus will cancel, becomes plus. This n you keep outside. What we have integral from 0 to 1 e power minus x into x power n minus 1 dx. See, in is defined as integral from 0 to 1 x power n e power minus x. Now, this is nothing but in minus 1, correct? Because this and this are exactly same, but only the power of x is different. Here the power of x is n, here the power of x n minus 1, correct? E power minus x exponent. e power minus x power n minus 1. This becomes in minus 1. So started with in here, left hand side. In is equal to what we have? Minus e power minus 1, which is minus 1 by e plus n into this part is going to be in minus 1. This part is in minus 1. In minus 1. Because this and this, everything same, only the power of x different. If the power of x n means we call it as in. Here power of x n minus 1 means we call it as in minus 1. So this you take it to left hand side. This becomes in minus n into in minus 1 is equal to minus 1 by e. Minus 1. Now we can find I7 minus 7 into I6. Just put n equal to 7 in this. You'll get the answer. Put n is equal to 7. Put n is equal to 7. We get I7 minus 7 into I6 is equal to minus 1 by e. Put n is equal to 7. I7 minus 7 into I6 is equal to minus 1 by e is the answer. Option D. Question asked in the year 1998. Move on to the next one. This question is asked 2 times, once in the year 2006 and another time in the year 2013. I1 and I2, two things are given. I1 is integral from 0 to pi by 2 x into sin x dx. I2 is integral from 0 to pi by 2 x cos x dx. Apply integration by parts for both of them and get the relationship between I1 and I2 as given in the options. I1 is given as integral from 0 to pi by 2. Integral from 0 to pi by 2 x into sin x. Apply integration by parts. Integral of first into second. First function is algebraic. Second function is trigonometric according to Eilert. First function keep as it is. Integral of sin is minus cos. Minus integral of, integrate the second function, minus cos x. Derivative of x is 1. Correct? First function keep as it is. Integrate the second function. Integral of sin is minus cos. Minus integral of, integrate the second function, differentiate the first function. This is 0 to pi by 2. 0 to pi by 2. Upper limit is pi by 2. When you put the upper limit, cos pi by 2 becomes 0. So 0 into pi by 2 0. Lower limit x equal to 0. 0 into cos 0 becomes 0. Upper limit becomes 0 because cos pi by 2 0. Lower limit becomes 0 because 0. X is becoming 0. 0 into this becomes 0. Cos pi by 2 0. X is 0. So upper limit, lower limit both will become 0. Minus into minus plus. Integral of cos x is sin x. Correct? Limits from 0 to pi by 2. Here we get sin pi by 2 minus sin 1. Sin pi by 2 minus sin 0. Sin pi by 2 is 1. 1 minus 0 is 1. Correct? Minus of minus plus. Integral of cos x is sin x. Evaluate the function upper limit minus lower limit. Sin pi by 2 minus sin 0. Sin pi by 2 is 1. Sin 0 is 0. 1 minus 0, 1. I1 is 1. I2 you find out similarly. I2 is integral from 0 to pi by 2 x into cos x. Apply integration by parts for this. X is algebraic. Cos x is trigonometric. Integral of first into second. First function keep as this. Integral of cos x is sin x. Minus integral of cos x is sin x. Derivative of x is 1. Correct? First function keep as it is. Integrate the second function. Integral of cos x is sin x. Minus integral of, integrate the second function. Differentiate the first function. Limits from 0 to pi by 2. 0 to pi by 2. Here upper limit is pi by 2. Correct? Pi by 2 into sin pi by 2 becomes pi by 2 into sin pi by 2 minus 0 into sin 0. Upper limit minus lower limit. Integral of sin is minus cos. Minus of minus plus cos x. 0 to pi by 2. Correct? Integral of sin is minus cos. Minus of minus plus cos x. Here this part is 0. Sin pi by 2 is 1. 1 into pi by 2 is pi by 2. This is 0. This is cos pi by 2 minus cos 0. Cos pi by 2 is 0. Cos 0 is 1. What you get is pi by 2 plus cos pi by 2 0. Cos 0 is 1. So what you get is pi by 2 minus 1. Correct? Cos pi by 2 minus cos 0. Cos pi by 2 0. Cos 0 is 1. 0 minus 1. So pi by 2 minus 1. Want to find relationship. I1 equal to I2 is not possible because I1 we got 1. I2 we got pi by 2 minus 1. They can't be equal. They can't be. I1 is equal to pi by 2 into I2. This is also not possible. Option A is not possible. Option C is not possible. I1 plus I2 pi by 2 is possible. See, if I add I1 and I2, I get pi by 2. Option D is the answer. Correct? I1 plus I2 is equal to how much? I1 we got 1. I1 we got 1. I2 we got pi by 2 minus 1. 1 plus minus 1 will cancel. We get I1 plus I2 is pi by 2. Option D is the answer. Question asked 2 times. Once in 2006, another time in the year 2013. Please make a note. Move on to the next one. Integral from 0 to pi x into tan x by secant x cosec x. Of course, this question can be done by 2 methods. One is by using integration by parts, another by using the properties of definite integral. That way also we can do, but I'll be doing by using integration by parts. Okay, write tan as sine by cos, sec as 1 by cos, cosec as 1 by sine, expressed in terms of sine and cos, or the trigonometry functions involved here. Okay, given integral I call it as I here. 0 to pi x into tan, you write sine by cos, sine x divided by cos x divided by secant x is 1 by cos x, cosec x is 1 by sine x. Here cos x will cancel, sine x will go up, becomes integral from 0 to pi x into sine square x. This becomes integral from 0 to pi x into, of course, understood, right? Cos x will cancel, tan arrived sine by cos, sec is 1 by cos, cosec is 1 by sine, 1 by cos will cancel, sine into sine, this goes to numerator, denominator is denominator, goes to numerator, sine into sine becomes sine square x into sine square x. Now to integrate this, I'll use sine square x as 1 minus cos 2x by 2, the power reducing formula. Then I can integrate by parts. Integral from 0 to pi, this is x into 1 minus cos 2x divided by 2, sine square x, 1 minus cos 2x divided by 2. Divide by 2 means keep 1 by 2 outside. 1 by 2 keep outside. Integral from 0 to pi, x into 1, x dx minus integral from 0 to pi, x into cos 2x dx. Correct? 1 by 2 is kept outside, x into 1 x into cos 2x. Integral of x is x square by 2. For this you can apply integration by parts. First function is x, second function is cos 2x according to Eilert. Integrate this, get the answer. Half into integral of x is x square divided by 2. For this limits from 0 to pi minus half into, half I multiply inside to this as well as to this. Integral of first into second, first function keep as it is, integral of cos 2x is sine 2x divided by 2 minus integral of, integrate the second function, sine 2x divided by 2, derivative of x is 1. For this limits from 0 to pi, here also it is 0 to pi, this becomes 1 by 4 into pi square minus 0, correct, minus 1 by 2 into, here when you put the upper limit pi, sine 2 pi is 0, sine of n pi is 0, correct, sine of n pi is equal to 0 for all n belongs to z, sine of n pi is equal to 0 for all n belongs to z. So sine 2 pi is 0, upper limit becomes 0 because of this, Lower limit becomes 0 because of this. 0 into this becomes 0. Upper limit 0, lower limit 0 because sine 2 pi is 0, sine 0 0, 0 minus 0 0. This part is gone. Here minus 1 by 2 keep outside. Minus 1 by integral of sine is minus cos. So this will be minus cos 2x divided by 2. Minus cos 2x divided by 2 for this limits from 0 to pi. So this is pi square by 4. This part is 0. So I'll write the answer here. Pi square divided by 4. This part is over. This is 0. Minus, you can keep outside. Now minus into minus into minus will be minus. 1 by 2 into 1 by 2 into 1 by 2 is 1 by 8 into upper limit is pi. Cos 2 pi minus cos 0. Cos 2 pi minus cos of 2 into 0. This is equal to pi square divided by 4 minus 1 by 8 into cos 2 pi is going to be equal to 1. Cos 0 is equal to 1. 1 minus 1 0. This part is gone 0. So answer is pi square divided by 4. One can also do using the properties of definite integral this question. Okay. If you want, you can try by using properties of definite integral. You'll get the answer. Replace x by upper limit minus x. You can convert, at this stage, after expressing tan in terms of sine and cos, secant and cosec in terms of cos and sine, we can here apply the property of definite integral. Replace x by pi minus x. It becomes pi minus x into sine square pi minus x. If you concentrate on this, I'll show by using the properties of definite integral also we can do from this. Replace x by pi minus x. Okay, I'll add one page here. I is equal to integral from 0 to pi x into sine square x. If you replace x by pi minus x, this becomes I is equal to integral from 0 to pi. What do you get? Pi minus x into sine square of pi minus x. Sine square of pi minus x is equal to sine square x, because sine of pi minus x is sine x. So this will be 0 to pi. What I am getting is pi minus x into sine square x. And you can multiply this. We'll call this as equation 1. This will call it as equation 2. Add equations 1 and 2. Here open the bracket. Pi sine square minus x sine square. If you add the equations 1 and 2, x sine square is going to cancel. I plus I becomes 2i. Okay, 2i is equal to integral from 0 to pi. I get pi into sine square x. Then I can apply Wally's formula also. I should make 0 to pi as 0 to pi by using properties. Property 7, first case I am going to apply. So f of 2a minus x equal to f of x means integral from 0 to 2a f of x dx becomes 2 times integral from 0 to a f of x dx. So using that I can simplify this. I will be equal to pi by 2 into 2. Correct? Pi by 2, that is 2 times 0 to pi by 2 it becomes sine square x, and integral from 0 to pi by 2 sine square x is pi by 4 it is. So pi into pi by 4, we'll get pi square by 4 as answer. All these things you must know, many results here on definite integral if you are doing. Same answer will get. Okay? Answer is pi square divided by 4. Option C. Question asked in the year 2023. Please make a note. Move on to the next one. Definite integration in this. Integral of e power x into f of x plus f dash of x. We are very familiar with this, correct? We know this is equal to e power x into f of x, correct? Integral of this type. E power x into f of x plus f dash of x is e power x into f of x plus c. Quite familiar result, correct? From the NCERT book. So this integral takes this form. So what we do is we express the numerator in terms of denominator. One step we have to simplify. Then it becomes this form. So the given integral is what? 0 to 1. Integral from 0 to 1. X into e power x divided by 2 plus x the whole cube. X into e power x divided by 2 plus x the whole cube is there. So what we do is in the numerator add 2 and subtract 2. So that I can express in terms of denominator 0 to 1 x plus 2 minus 2, correct, into e power x divided by 2 plus x the whole cube. Add and subtract 2. Then separate the terms. X plus 2 by 2 plus x the whole cube minus 2 by 2 plus x the whole cube. Separate the terms. Integral from 0 to 1 x plus 2 divided by 2 plus x the whole cube minus 2 by 2 plus x the whole cube. Correct? Add 2, subtract 2, divide individually, separating the terms. X plus 2 by 2 plus x whole cube. X plus 2 same as 2 plus x. 1, 2 plus x will cancel. This becomes integral from 0 to 1. What you get is 1 by 2 plus x the whole square minus 2 by 2 plus x the whole cube. Correct? Into e power x dx. One of the 2 plus x term will cancel. And derivative of 1 by 2 plus x the whole square is minus 2 by 2 plus x the whole cube. If you take f of x as 1 by 2 plus x the whole square, we know derivative of 1 by x square is minus 2 by x cube. Correct? Derivative of 1 by x square. What is derivative of 1 by x square? Minus 2 by x cube, right? Same way. Derivative of 1 by x square is minus 2 by x cube. Derivative of 1 by 2 plus x the whole square is minus 2 by 2 plus x the whole cube. Minus 2 divided by 2 plus x the whole cube. So if you take this as f of x, this will be f dash of x. This is your f of x. F of x. And this part along with negative sign, this is f dash of x. Integral from 0 to 1, e power x into f of x plus f dash of x will be e power x into f of x. So this is equal to e power x into my f of x is 1 by 2 plus x whole square. Integral from 0 to 1, correct? Limits from 0 to 1. Integral of e power x into f of x plus f dash of x is e power x into f of x. F of x is 1 by 2 plus x the whole square. So evaluate the function in upper limit minus lower limit, get the answer. What we get is equal to e power 1 divided by 2 plus 1 the whole square. Put the value of x upper limit minus put the value of x lower limit e power 0 divided by 2 plus 0 the whole square. E power 1 is e, 2 plus 1 3, 3 square 9, e power 0 is 1, 1 by 2 plus 0, 2 plus 0 is 2, 2 square is 4. So answer is e by 9 minus 1 by 4. 1 by 9 into e minus 1 by 4. Evaluate the function in upper limit x equal to 1. E power 1 by 2 plus 1 the whole square. 2 plus 1 3. 3 square 9. E by 9 minus e power 0 by 2 plus 0 the whole square. E power 0 is 1. 2 plus 0 is 2. 2 square 4. So 1 by 4. E by 9 minus 1 by 4. Option A is the answer. Question asked recently in the year 2022. Must know derivative of 1 by x square is minus 2 by x cube. Derivative of 1 by x power n is minus n by x power n plus 1. Okay. So derivative of 1 by 2 plus x whole square is minus 2 by 2 plus x the whole cube into derivative 2 plus x 1. Correct. So answer is option A. Next we have the properties of definite integral. Integral from a to b f of x dx. Same as integral from a to b f of t dt. Change of variable is allowed. Lower limit is same, upper limit is same, function is same, only variables are different. The value of definite integral is not going to change. Here the variable is x, here the variable is t. Quite important. Questions are there based on this. The first one we have given left hand side k into integral from 0 to 1 x into f of 3x dx. Right hand side is integral from 0 to 3 t into f of t dt. Want to find the value of k, correct? So in the left hand side, I'll make a substitution that put t is equal to 3x or put u is equal to 3x. I'll make a, because the t is already used, put u is equal to 3x in the left hand side. Put u is equal to 3x. What we get? Du by dx is equal to 3. Correct? Change the limits. When x equal to 0, u is equal to how much? When x equal to 0, u is equal to 3 into 0, 0. When x equal to, upper limit is 1 there. When x equal to 1, u is equal to 3 into 1, that is 3. Correct? Limits will change. So left hand side becomes what? Left hand side is k into integral from x is 0 to 1, u is 0 to 3. Correct? integral from 0 to 3 it is. Write everything in terms of u now. What is u from this? Because u is 3x from this, because u is equal to 3x, x is u by 3, correct? X is u divided by 3. X is u by 3 from this. So x I am writing u by 3. F of 3x. 3x is u, correct? X is u by 3. 3x is u. And dx how much? Du by 3 from this. Du divided by 3 is equal to, right hand side we have integral from 0 to 3 t into f of t dt. Correct? dx is du divided by 3. 3 into 3 becomes 9 here. And by property 1, I can write this as integral from 0 to 3. This is u into f of u du is equal to integral from 0 to 3 t into f of t dt. By property 1, correct, variables can be changed as we had here. Property 1 says lower limit same, upper limit same, function is same, only variables are different, value is same, equal, correct? Value of this is same as value of this, correct? Same way I can write value of this integral is same as value of this integral, because lower limit is same, upper limit is same, function is same, correct? Only the variables are different. Left hand side variable is u, right hand side variable is t, both are same, cancels out, correct? So what I get? K by 9 is equal to 1. K by 9 is equal to 1. That means K is equal to 9 by property 1. Value of K is 9. Option B is the answer. Question asked in the year 2007. On to the next one. Integral from 0 to 1 f of x dx is given to be equal to 5. Want to find the value of this. Observe here x into f of x square. Here it is x square into f of x cube. Likewise it goes on x power 9 f of x power 10 is there. You observe the derivative of x square is 2x. Derivative of x cube is 3x square. Derivative of x power 10 is 10x power 9. That is the key thing here. Okay. So what I am going to do is the first integral keep as this. 0 to 1 f of x dx. Okay. For the second one, 4 is there, no? I'll write 2 into integral from 0 to 1 2x into f of x square dx. F of x square into 2x dx. Like this, right? So that 2 into 2 is 4. Next term will be 9. I'll write 3 into 3. 3 into integral from 0 to 1 f of x cube into 3x square dx. So that 3 into 3 is 9, correct? Likewise go on, continue. Last term is 100 into, no? Last term, like this it goes on. 100 is 10 into 10. 10 into integral from 0 to 1 f of x power 10. F of x power 10 into 10 x power 9 dx. So the 10 into 10 is 100 x power 9. And you see the derivative of x power 10 is 10x power 9. Derivative of x square is 2x. Derivative of x cube is 3x square. Correct? So I will integrate this by method of substitution. So what I can write here is the first integral keep as this 0 to 1 f of x dx. For the second integral, what I am going to do is I am going to make a substitution. X square is equal to t. If you put x square is equal to t here, for the first one, put x square is equal to t. So that dt is equal to 2x into dx. Correct? When x is equal to 0, t is equal to 0. When x equal to 1, t is equal to 1. Lower limit, upper limit is same. Even after making the substitution, lower limit, upper limit is same. When x is 0, t is 0. 0 square 0. X is 1, t is 1 square 1. Correct? 0 square 0, 1 square 1. So 2 times it is 0 to 1 f of t dt. For the third one, I am going to substitute u is equal to x cube. Take u is equal to x cube. put u is equal to x cube for the third term. So that derivative of x cube is going to be equal to 3x square. And change the limits. When x is equal to 0, u is equal to 0. When x is equal to 0, u is equal to 0. When x is equal to 1, u is equal to 1. Correct? Lower limit, upper limit is same. 0 cube is 0, 1 cube is 1. So lower limit, upper limit is still same after making substitution. F of u du. Because 3x square into dx is du. This part is du from this. 3x square into dx is du. X cube is u. Like this, it goes on. 10 times. Here, take w as x power 10. So the derivative of x power 10 is 10x power 9. When x is 0, w is 0. Correct? When x is 1, w is 1 only. This becomes f of w dw, where w is x power 10. dw is equal to 10 x power 9 dx. Correct? When x is equal to 0, w is equal to 0 power 10 0. When x is 1, w is 1 power 10 1. Lower limit, upper limit is same. By using property 1, integral from 0 to 1 f of t dt, same as integral from 0 to 1 f of u du, same as integral from 0 to 1 f of w dw, same as integral from 0 to 1 f of x dx. By using property 1, change of variable is allowed. Everything is integral from 0 to 1 f of x dx only. Correct? So this is integral from 0 to 1 f of x dx. Will take common. What is left here? This is 1. This is also integral from 0 to 1 f of x dx only. Kept outside. What it means? 2. Here, this is also same as integral from 0 to 1 f of x dx only. Kept outside. 3. Like this, it goes on. Last term is 10. This is summation of 10 terms inside the bracket. Terms inside the bracket is summation of 10, which is, we know, summation of n formula, n into n plus 1 by 2. Summation of 10, 10 into 10 plus 1 by 2. Value of integral from 0 to 1 f of x dx given to be equal to 5 from this. This value is 5. Correct? 5 into summation of 10. Summation of 10. 5 into summation of 10 is 10 into 10 plus 1 divided by 2. 2 ones are 2 5s are. So 25 into 11 it becomes. 25 into 11 is equal to 275. Answer is 275. Option D. Question asked in the year 2009. Quite interesting question. On to the next one. Property 2 says, if you interchange lower limit, upper limit, the sign of the definite integral is going to change. Integral from a to b f of x dx equal to minus integral from b to a f of x dx. In particular, if lower limit and upper limit is same, then the value of definite integral is going to be equal to 0. Okay, you must know that. Property 3 is quite important. Integral from a to b is a to c plus c to b, where c lies between a and b. This is called as splitting property. Quite useful to evaluate the integrals of modulus function, greatest integer function, piecewise functions, all those things. Okay. So please make a note of property 3 is quite interesting and important also. Integral from minus 1 to 3 tan inverse of x by x square plus 1 plus tan inverse of x square plus 1 by x you want to find out. So there is a relationship between tan inverse x and tan inverse 1 by x, you must know. So note that the terms inside this bracket and this bracket are reciprocals of each other. Here x by x square plus 1 is present. In this x square plus 1 by x is present. The terms inside the bracket are reciprocals of each other. So you must know the property of ITF here. Even though it's deleted, it's better to learn all these properties for competitive exams. The property says that tan inverse x plus tan inverse 1 by x is going to be equal to pi by 2. Tan inverse x plus tan inverse 1 by x is going to be equal to pi by 2 if x is positive. If x is positive. And tan inverse x plus tan inverse 1 by x is going to be equal to minus pi by 2 if x is negative. Tan inverse x plus tan inverse 1 by x is equal to minus pi by 2 if x is negative. You must know this property of ITF. Okay, so property of ITF. From ITF we know this. So in this question, The integral is from minus 1 to 3. So we split this minus 1 to 0 and 0 to 3 using property 3. Using this property, splitting property. A to B is A to C plus C to B, where C lies between A and B. So now between minus 1 and 3 there is 0. I'll split. I'm separating the negative and positive values of x. So minus 1 to 3 is minus 1 to 3 could be written as minus 1 to 0 plus 0 to 3. Minus 1 to 3 is minus 1 to 0 plus 0 to 3. Minus 1 to 0, what we have is negative values, excluding 0. All other values are negative. So in that interval, this integrand becomes tan inverse x plus tan inverse 1 by x. No? These two are reciprocals. I am applying the second case here. Correct? This becomes minus pi by 2. Integral from minus 1 to 0. This becomes minus pi by 2. And in the interval 0 to 3, x value is positive except 0, other values are positive. So in that case, this sum becomes pi by 2 because x is positive means we have this tan inverse x plus tan inverse 1 by x. Tan inverse of this plus tan inverse of reciprocal, correct? This and this are reciprocal. X and 1 by x are reciprocals, like this and this are reciprocals. X by x square plus 1, reciprocal is x square plus 1 by x. So the sum is pi by 2 here. So this is minus pi by 2. Integral of constant is constant into x. Limits from minus 1 to 0. Integral of pi by 2 is pi by 2 into x. Limits from 0 to 3. Evaluate the function at upper limit minus lower limit. Minus pi by 2 into 0 minus minus 1 plus pi by 2 into 3 minus 0. Upper limit minus lower limit. Correct? What we get is minus pi by 2 into minus or minus plus 1 there. Minus into minus into minus, minus there. Minus pi by 2. Here it is 3 pi by 2. 3 pi by 2 minus pi by 2 is 2 pi by 2, which is pi. Answer is pi. Option A is answer. In many of the books, they have made a mistake. They directly taken minus 1 to 3. This sum as pi by 2 and done. That's wrong. And they got the answer as 2 pi, I think. That's wrong answer. Please make a note of this properly. If x is positive only, then tan inverse x plus tan inverse 1 by x is pi by 2. If x is negative, tan inverse x plus tan inverse 1 by x is minus pi by 2. In this interval, minus 1 to 0 is negative. So minus pi by 2. 0 to 3, this sum is positive. That's pi by 2. I mean, this value of x is positive. This sum is pi by 2. In this interval, x is negative. If x is negative, this sum becomes minus pi by 2. Minus pi by 2 is constant. Integral of 1 is x. Limits from minus 1 to 0, minus 1, plus 1. Correct? Minus pi by 2. Here 3 pi by 2 becomes 2 pi by 2. Pi is the answer. Question asked in the year 2000. Please make a note of this. Next, we have evaluating the definite integrals using the modulus function. You know the definition of modulus function. Mod x is equal to x if x is greater than or equal to 0, and minus x if x is less than 0. Using this definition, we need to split the modulus function. Okay, so whenever you want to evaluate a definite integral involving the modulus function, we need to split using this definition. Okay, suppose they give mod x minus 1. You know, mod x minus 1 will be x minus 1 if x minus 1 is greater than or equal to 0. Mod x minus 1 is minus of x minus 1 if x minus 1 less than 0. Okay, using the splitting property, I'm going to use the splitting property of the definite integral. Integral from a to b is a to c plus c to b, where c lies between a and b. Okay, so I use the splitting property and use the definition of modulus function. Moreover, sometimes whenever integrals of these type is given, mod x minus 1, mod x plus 2, x plus 1, mod x minus 5, etc., we can use this formula directly. Integral of mod x is x mod x by 2 plus c. Okay, mechanically we can apply. No need to use the definition of modulus function and no need to use the splitting property also. Okay, directly I can use this. Suppose you want to integrate mod x minus 1, say from 0 to 5. Directly I can apply integral of mod x minus 1 as x minus 1 into mod x minus 1 divided by 2 and apply the limits. That will give the answer. Okay, so it works only for these types of. If they give trigonometric function within the modulus function, then we can't apply. Okay, a trigonometric function is given or logarithmic function is given, then we can't apply this property. Okay, so we'll take the problems based on this, which has appeared in the past years of KCET. Okay, this question asked in the year 1998. Integral from minus a to plus a mod x dx. Of course, a is positive, they should have given, otherwise we can assume that a is positive here. Integral from minus a to plus a mod x dx. We can write directly the formula. Integral of mod x as x mod x by 2 and apply limits. Okay, so integral from minus a to plus a mod x dx is equal to x into mod x divided by 2. X into mod x divided by 2, limits from minus a to plus a. This is equal to, divided by 2 means 1 by 2 keep outside. This is a into mod a minus a into mod a. Mod of minus a. Mod of minus a is a only. Mod of minus a, same as mod a. Of course, a is positive here. Half into, this becomes a into, I assume that a is positive as I told earlier. Okay, I should have given that a is positive. So mod a becomes a, correct? A into a becomes a square. Mod a is a into a becomes a square. Minus of minus becomes plus a into mod of minus a, same as mod a. You know that mod of minus a is equal to mod a. And mod a is equal to a because a is positive. Mod a is equal to a if a is positive. So this becomes minus of minus a plus a. Mod of minus a is mod a. Mod a is a. So this becomes a into a square. Correct? A square plus a square, 2a square. Half into 2a square, which is equal to a square. Answer is a square. Option A is the answer. If you're doing it by the regular method or traditionally if you're doing this problem, you need to split at 0. Between minus a and plus a, the number 0 lies. And that too, modulus of x will become 0 at x equal to 0. So 0 is the critical point for this function modulus of x. So I can do it by another method. Second method, integral from minus a to plus a, integral from minus a to plus a mod x dx is equal to minus a to 0 and 0 to a. Correct? Between minus a to 0 except 0, all of the numbers are negative. So for negative values of x, we know modulus of x is minus x by definition. Minus x dx. And from 0 to a, leaving 0, I can include 0 here, no problem. For x is greater than or equal to 0, correct? All we have positive numbers here, including 0. Okay, so modulus of x becomes x. Here x is greater than or equal to 0, mod x becomes x. And you can integrate this. Integral of minus x is minus x square by 2. Integral of x is x square by 2. This is minus x square divided by 2. Limits from minus a to 0. Integral of x is x square divided by 2. Limits from 0 to a. Evaluate the function upper limit minus lower limit. Minus half into 0 square is 0 minus a square. Minus a square is same as a square. Minus a the whole square. Plus half into what I am getting is evaluate the function at upper limit minus lower limit. A square minus 0 square. Here minus a square is same as a square. So minus half into minus a square becomes half a square. Correct? Half a square plus half a square. Half a square plus half a square is a square. A square is answer. Option A. Second question we have integral from minus 1 to 2 mod x dx. So if you're doing the traditional method minus 1 to 2 mod x dx, we need to split this at x equal to 0. Correct? Minus 1 to 0, x values are negative except 0. 0 to 2, x is greater than or equal to 0. So minus 1 to 0, and for negative values, mod x is minus x. Mod x is minus x. And for positive values, mod x is x. Integrate this and get the answer. Minus x square divided by 2. Correct? Integral of minus x. Minus to keep outside. Integral of x square by 2. Minus 1 to 0. Integral of x is x square divided by 2. Limits from 0 to 2. Is equal to minus half into evaluate the function at upper limit minus lower limit 0 square minus 1 square. Here it is half into 2 square minus 0 square. Correct? Minus 1 square is 1 only. So minus half into minus 1 becomes plus half. Correct? Plus 4 by 2. 4 by 2 plus 1 by 2 which is equal to 5 by 2. 5 by 2 is the answer. Option C. If you're doing it by the time saving result method, integral from minus 1 to 2. Second method, I'm using the time saving result here. Integral from minus 1 to 2 mod x dx. Minus 1 to 2 integral of minus 1 to 2 mod x dx. Integral of mod x is x mod x divided by 2. Limits from minus 1 to 2. Evaluate the function at upper limit minus lower limit. 2 into mod 2 divided by 2 minus 1 into mod of minus 1 is 1 divided by 2. Correct? So this is 4 by 2 plus mod of minus 1 is 1 I wrote. Evaluating the function at lower limit minus 1 into mod of minus 1 is 1. Correct? So minus 1 into 1 by 2. Minus of minus plus 1 by 2. 4 by 2 plus 1 by 2 which is equal to 5 by 2. Option C is the answer. Question asked in the year 1996. Move on to the next one. Integral from 0 to 2. Integral from 0 to 2 mod of 1 minus x dx. Mod of 1 minus x is same as mod of x minus 1. You know mod x is same as mod of minus x. So this is integral from 0 to 2. 0 to 2. Mod of 1 minus x is given. Mod of 1 minus x same as mod of x minus 1. Mod of 1 minus x dx is same as integral from 0 to 2 mod of x minus 1 dx. Mod 1 minus x same as mod x minus 1. Sorry, correct? No? So from this we can integrate. Integral of mod x is x mod x by 2. Integral of mod x minus 1. X minus 1 into mod x minus 1 by 2. This is x minus 1 into mod x minus 1 divided by 2. Evaluate this function at upper limit and lower limit. Evaluate the function upper limit minus evaluate the function at lower limit. Put x equal to upper limit. Upper limit is 2. 2 minus 1. 2 minus 1 is 1. 2 minus 1 is 1. Mod of 1 is 1. Divided by 2. Minus. Put x equal to 0. 0 minus 1 is minus 1. 0 minus 1 is minus 1. Mod of minus 1 is plus 1. Divided by 2. Correct? This becomes 1 by 2 plus 1 by 2. Half plus half which is equal to 1. Answer is option B. Question asked in the year 1995. If you're doing it by actual method, I'll just write one line. where you need to split mod x minus 1 becomes 0 at x equal to 1, where the terms inside the mod becomes 0. That is a critical point. At that point we need to split. So this I'm going to split at x equal to 1. So 0 to 2 mod x minus 1, 0 to 2 mod x minus 1 is going to be equal to 0 to 1 plus 1 to 2. 0 to 1, if you take any value excluding 1, x minus 1 is negative. So mod x minus 1 is minus of x minus 1. Minus is kept outside. Minus of x minus 1 dx. And 1 to 2, mod x minus 1 is x minus 1. Okay. Then we can integrate this and apply limits and get the answer. Okay. So mod 1 minus x same as mod x minus 1. Integral of mod x minus 1 is x minus 1 into mod x minus 1 by 2. Evaluate the function in upper limit minus lower limit. 2 minus 1 into mod of 2 minus 1 by 2. 2 minus 1 is 1. 2 minus 1 is 1. Mod of 1 is 1. Correct? 1 by 2 plus 1 by 2, which is 1. Option B is the answer. Hope it's clear. If you want, you can do it this method. Quite lengthy. Not quite lengthy. It's a little bit lengthy compared to this. Relatively little lengthy. So we can do this method. Okay. So we can save the time. Move on to the next one. Question number 4 we have. Integral from 0 to 2 pi mod of sin x plus mod of sin x dx. 0 to 2 pi sin x plus mod of sin x dx. We know how to integrate sin x, we know. Integral of sin is minus cos. This we can directly integrate using the formula. For this we need to split. Sin function we know it is positive in the first and second quadrant and it is negative in the third and fourth quadrant. So we need to split at x equal to pi to evaluate this. Okay. So integral from 0 to 2 pi. This is integral from 0 to 2 pi sin x dx. 0 to 2 pi sin x dx plus 0 to 2 pi mod of sin x dx. We can separate like this. Okay. Or else directly I can take at x equal to pi, I can split the entire function itself. Take the entire function, split at x equal to pi. That is much easier actually. We'll do that method. Okay. No need to separate the terms. No need to separate the terms like this. What we'll do is 0 to pi will take. 0 to 2 pi will take directly. 0 to 2 pi sin x plus mod of sin x. 0 to 2 pi sin x plus mod of sin x is given, no? Sin x to keep as it is. Apply the definition of modulus function for this mod of sin x. See, mod of sin x will be equal to sin x. Mod of sin x will be equal to sin x if sin x is greater than or equal to 0. Sin x is greater than or equal to 0. And mod of sin x will be equal to minus sin x if sin x is less than 0. If sin x is less than 0. Mod of sin x is sin x if sin x is greater than or equal to 0. Sin x is greater than or equal to 0. This is possible in the first and second quadrant, 0 to pi. And this is pi to 2 pi. Correct? Sin x is less than 0. Means sin x is negative in the third and fourth quadrant. First and second quadrant sin function is positive. Third and fourth quadrant sin function is negative. So this is possible in the first and second quadrant. Is that correct? This is possible for the interval 0 to pi. 0 to pi. And this is possible for the interval pi to 2 pi. If you take the cycle 0 to 2 pi, 0 to pi this happens. Pi to 2 pi this happens. Correct? So now this is equal to, I can split this at x equal to pi. 0 to pi, what happens? Sin x keep as it is. 0 to pi, sin x keep as it is. Mod of sin x becomes sin x. As I explained, sin x is positive in the first and second quadrant. Next, plus pi to 2 pi. Pi to 2 pi, sin x keep as it is. And mod of sin x becomes minus sin x. Because pi to 2 pi will cover the third and fourth quadrant. Third and fourth quadrant sin function is negative. So this part is 0. Correct? Sin x minus sin x is 0. So this becomes sin x plus sin x is 2 sin x. 2 times integral from 0 to pi sin x dx. Correct? Sin x minus sin x is 0. Integral of 0 is 0 there. Correct? So 2 times 0 to pi sin x dx. Integral of sin is minus cos. So minus 2 cos x. Limits from 0 to pi is equal to minus 2 into, evaluate the function at upper limit minus lower limit, cos pi minus cos 0, minus 2 into, cos pi is minus 1, cos 0 is 1, minus 1 is minus 2, minus 2 into minus 2 is plus 4. Plus 4 is answer. Option A is answer. Question asked in the year 2003. Please make a note. How to apply the definition of modulus function, modulus of sin x. Mod of sin x is sin x if sin x is greater than or equal to 0. That happens in the first and second quadrant, 0 to pi. Mod of sin x is minus sin x if sin x is less than 0. That happens in the third and fourth quadrant, which is pi to 2 pi. Okay. Apply the definition of modulus of sin x and divide separately at 0 to pi and pi to 2 pi. This part is 0, here 2 sin x, integral of sin is minus cos, minus kept outside, cos pi minus cos 0. Cos pi is minus 1, cos 0 is 1. Minus 1, minus 2 into minus plus 4. Option A. On to the next one. Question number 5 we have f of x given like this, integral from minus 1 to x mod t dt. Then for any x greater than 0, f of x is how much? So x is positive they mentioned. So I'll split this at t equal to 0. The variable for integration is a t here. You can see mod t dt. That means the variable for integration is t. So I'll split this at t equal to 0. Correct? At t equal to 0 I'll split because 0 lies between minus 1 and x. 0 lies between minus 1 and x because x is positive. X is some positive number. Greater than 0 is mentioned. Clearly we know mod t will become 0 at t equal to 0. Terms inside the mod will become 0 at t equal to 0. So 0 is a critical point. So f of x is given like this. F of x is equal to integral from minus 1 to x mod t dt, which is equal to minus 1 to 0 plus 0 to x. Minus 1 to 0 plus 0 to x. Minus 1 to 0, t value is going to be negative, correct? So mod t becomes minus t. 0 to x, t value is positive, greater than or equal to 0, mod t is t. Integrate this, apply limits, get the answer. Minus t square divided by 2, limits from minus 1 to 0. Integral of t with respect to t square by 2, limits from 0 to x. Evaluate the function at upper limit minus lower limit, minus half into 0 square minus 1 square is 1, upper limit minus lower limit, half into, this will be x square minus 0. Here minus of minus plus, which is half into 1, here half into x square, half common, 1 plus x square. Half into 1 plus x square. Option D is the answer. Question asked in the year 2009. KCET 2009. If you want, I can do the other method. Integral of mod t is t mod t by 2. Second method if you want. The second method. Integral of minus 1 to x. Integral from minus 1 to x mod t dt. Integral of mod t I can write t into mod t divided by 2. Limits from minus 1 to x. Evaluate the function in upper limit minus lower limit. Correct? X into mod x. Mod x is x because x is positive. Correct? X square it becomes. Minus lower limit minus 1. Minus 1 into mod of minus 1 is plus 1. Correct? So we get answer as half into x square plus 1 is equal to half into x square plus 1. Just 2 lines I can finish. Can do even orally. Just use mind calculations and get the answer. Correct? Integral of mod t is t mod t by 2. Limits from minus 1 to x. Evaluate the function in upper limit minus evaluate the function in lower limit. X into mod x by 2. Here minus 1 into mod of minus 1. Mod of minus 1 is plus 1. So half into x square plus 1. Mod to the next one. Question number 6 we have integral from minus 1 to 2 mod x by x dx. Mod x will become 0 at x equal to 0, right? So I'll split this at x equal to 0. Minus 1 to 2 mod x by x. minus 1 to 2. Mod x by x is actually the signum function for x not equal to 0. Correct? Minus 1 to 0, excluding 0 here. Correct? Minus 1 to 0 plus 0 to 2. Minus 1 to 0, leaving 0, all of the numbers are negative. Mod x will be, all of the numbers are negative. For negative values, mod x becomes minus x. So this is minus x divided by x. For x greater than 0, modulus of x becomes x. Mod x becomes x for x greater than 0. Here x value is greater than 0. So mod x is x. In the interval 0 to 2, mod x becomes x. In the interval minus 1 to 0, mod x is minus x. X cancels, we get minus 1 to 0. This is minus 1 dx. 0 to 2, 1 dx. Correct? Integral of minus 1 is minus x. Minus 1 to 0. Integral of 1 is x. 0 to 2. Evaluate the function at upper limit minus lower limit. Minus of 0 minus minus 1. Here it is 2 minus 0. Minus of upper limit minus lower limit. Correct? No? Integral of minus 1 is minus x. Integral of 1 is x. Evaluate the function at upper limit minus lower limit. Minus of minus plus 1. Plus 1 into minus becomes minus 1. Plus 2, which is equal to 1. Which is option B. Question has been there, 2012. On to the next one. Question number 7 we have integral from minus 5 to plus 5 mod of x plus 2 dx. Directly I use the formula integral of mod x plus 2 as x plus 2 into mod x plus 2 divided by 2. Integral from minus 5 to plus 5 mod of x plus 2 dx, which is equal to x plus 2 into mod x plus 2 divided by 2. X plus 2 into mod x plus 2 divided by 2. Limits from minus 5 to plus 5. Lower limit is minus 5. Upper limit is 5. Evaluate the function at upper limit minus evaluate the function at lower limit. Putting x equal to upper limit, x equal to 5. 5 plus 2 is 7. 5 plus 2 is 7. Mod of 7 is 7 itself. Divided by 2. Minus lower limit, x equal to minus 5. X equal to minus 5. But minus 5 plus 2 is minus 3. Minus 5 plus 2 is minus 3. Mod of minus 3 becomes 3. Divided by 2. Correct? This is 49 divided by 2. Minus into minus plus 3 into 3, 9 by 2. Which is 58 divided by 2. Which is 29. 29 is answer. Option C. Is that clear? Question asked in the year 2017. If we are splitting this using the splitting property, we need to split at x equal to minus 2. When terms inside the mod become 0. X plus 2 0 means x equal to minus 2. Split this at x equal to minus 2. Minus 5 to minus 2 and minus 2 to 5. Minus 5 to minus 2 mod x plus 2 becomes minus of x plus 2. Minus 2 to 5 mod x plus 2 becomes x plus 2. In the interval minus 5 to minus 2, x plus 2 will be negative. Minus 2 to 5, x plus 2 will be positive. Correct? So, using that, we can split and integrate using the splitting property. Is that clear? Move on to the next one. Question number 8 we have on this. Integral from 1 to 5 mod x minus 3 plus mod of 1 plus x dx. Now, to integrate this, I'll use mod x minus 3 integral as x minus 3 into mod x minus 3 by 2. Okay. Integral from 1 to 5 mod x minus 3 I think there is some mistake in the question. I'm not sure. I'll work out. Let me see. I think it should be 1 minus x mod x minus 3 dx plus, I think there is a mistake in the question, it should be 1 minus x, okay. Just a minute, I'll check the question whether it's correct or not. Yeah, there's a mistake in this question actually. This is 1 minus x. 1 minus x. Okay. Please make a correction in this. Integral from 1 to 5 mod x minus 3 plus mod 1 minus x it is. 1 minus x. Okay. So 1 to 5 mod x minus 3 plus 1 to 5 mod 1 minus x. And mod 1 minus x is same as mod x minus 1. Correct? This is integral from 1 to 5 mod x minus 3 dx plus 1 to 5 mod 1 minus x, same as mod x minus 1. Please make a correction in the question. It should be mod 1 minus x, not 1 plus x, asked in the year 2024. A typing error has happened here. Integral of mod x minus 3 is x minus 3 into mod x minus 3 by 2. Limits from 1 to 5. Integral of mod x minus 1 is x minus 1 into mod x minus 1 divided by 2. Limits from 1 to 5. Correct? Evaluate the function at upper limit minus lower limit. Mod 1 minus x same as mod x minus 1. Correct? This will be easier. If you're doing the actual method, I have to split this at x equal to 3. I have to split this at x equal to 1. Correct? Anyway, 1 is the end point there. Directly, 1 to 5, x minus 1 is positive only. So, mod x minus 1, no need to split. I mean, 1 to 5, mod x minus 1 becomes x minus 1 only. But I am doing this formula method. I mean, integral of mod x is x mod x by 2. Integral of mod x minus 3 is x minus 3 into mod x minus 3 by 2. Integral of mod x minus 1 is x minus 1 into mod x minus 1 by 2. Evaluate the function at upper limit minus lower limit. 5 minus 3 is 2. 5 minus 3 is 2. 5 minus 3 is 2. Mod of 2 is 2. Divided by 2. Minus x equal to 1. 1 minus 3 is minus 2. X equal to 1 you put. 1 minus 3 is minus 2. 1 minus 3 is minus 2. Mod of minus 2 is 2. Divided by 2. Plus x equal to 5. 5 minus 1 is 4. 5 minus 1 is 4. Mod of 4 is 4. Divided by 2. X equal to 1 you put. 1 minus 1 is 0. Correct? This part is 0. Lower limit x equal to 1 you put, it becomes 0. Correct? X equal to 5 you put. 5 minus 3 is 2. 5 minus 3 is 2. Mod of 2 is 2. Correct? When you put x equal to 1, 1 minus 3 is minus 2. 1 minus 3 is minus 2. Mod of minus 2 is plus 2. This becomes 4 by 2. 4 by 2 is 2. Plus 2 cancels. Plus 2. Plus 4 into 4. 16 by 2 which is 8. 8 plus 2 plus 2 which is 12. Option A is the answer. Typing error has happened here. Please correct it. Mod x minus 3 plus mod of 1 minus x. Hope it's clear. 1, 2 will cancel. 2 minus of minus plus 2 cancels. 2 plus 2, 4. 4 into 4, 16 by 2 is 8. 8 plus 2 plus 2. Answer is 12. Option A. Move on to the next one. Question number 9 we have on this. Integral from minus 1 to plus 1. Mod of 1 minus x. Mod of 1 minus x same as mod of x minus 1. Integral from minus 1 to plus 1. mod of 1 minus x dx. This is equal to integral from minus 1 to plus 1 mod of x minus 1. Mod 1 minus x same as mod x minus 1. Integral of mod x minus 1 is x minus 1 into mod x minus 1 divided by 2. Limits from minus 1 to plus 1. Integral of mod x minus 1 is x minus 1 into mod x minus 1 divided by 2. Mod 1 minus x is same as mod x minus 1 because we know mod x is equal to minus x. Mod x is equal to mod of minus x. Correct? Evaluate the function. Upper limit minus lower limit. 1 minus 1, 0. Correct? 1 minus 1 is 0. Upper limit when you put x equal to 1 it becomes 0. 0 by 2 is 0. Lower limit we put x equal to minus 1. Minus 1 minus 1 minus 2. Minus 1 is minus 2. Mod of minus 2 is plus 2. Divided by 2. 1, 2 will cancel. Minus of minus 2 plus 2 is the answer. Option C. Upper limit it becomes 0. Lower limit you put x equal to minus 1. Minus 1 is minus 2. Minus 1 is minus 2. Mod of minus 2 is plus 2. 2 minus of minus plus 1, 2 will cancel. 2 is the answer. Question asked in the year 2004. Move on to the next one. 2011 question. This is integral from 0 to 4 mod x minus 1. Integral from 0 to 4 mod of x minus 1 dx. This is equal to x minus 1 into mod x minus 1 divided by 2. Limits from 0 to 4. Evaluate the function. Upper limit minus lower limit. 4 minus 1 is 3. 4 minus 1 is 3. 4 minus 1 is 3. Mod of 3 is 3. Divided by 2. Put x equal to 0. 0 minus 1 is minus 1. 0 minus 1 is minus 1. Mod of minus 1 is 1. Divided by 2. X equal to 0. Put 0 minus 1 is minus 1. 0 minus 1 is minus 1. Mod of minus 1 is 1. Correct? 4 minus 1 is 3. So this is 9 by 2 minus of minus plus 1 by 2 which is 10 by 2 equal to 5. Option B is the answer. All these questions were done on modulus function. Correct? Next we have evaluating the definite integral which involves the greatest integer function. We know that greatest integer function is discontinuous at every integral points. So we need to split at the points where the given function becomes integer. Because if the function is discontinuous, it's not integrable. For a function to be integrable, it should be continuous in the closed interval AB. Integral from A to B f of x dx is given to you. The function should be continuous in the closed interval AB. Then only it's possible to integrate. Because integration is area under the curve. Correct? So to make it continuous, we need to split at the points where the function is discontinuous. So if the interval is given like 0 to 2, we need to split at x equal to 1 because at x equal to 1 the greatest integer function is discontinuous. Where it becomes integer, at such points we split using splitting property. Integral from A to B is A to C plus C to B, where C lies between A and B. So we use the splitting property whenever they give to integrate an greatest integer function. Okay, so we'll work out the problems based on this. 3 or 4 questions are there based on this also. We have first question on this integral from 0 to 11 greatest integer function x asked in the year 2012. We know that greatest integer function is discontinuous at every integral points. Between 0 and 11 integers are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. At all those points I need to split. Okay, so I need to split at those points where it becomes integer. Integral from 0 to 11 greatest integer value of x dx is equal to 0 to 1 plus 1 to 2 plus 2 to 3, like this it goes on. Last we have 10 to 11. Correct? In the interval 0 to 1. 0 to 1 means 0 less than or equal to x less than 1. 1 is excluded there. In this interval, greatest integer function becomes equal to 0. 1 to 2. 1 less than or equal to x less than 2. Your greatest integer function becomes equal to 1. Like this. 2 less than or equal to x less than 3. In this interval, you take any value. Greatest integer function becomes equal to 2. Like this goes on. In the interval 10 to 11, including 10, excluding 11, the greatest integer function becomes 10. 10 less than or equal to x less than 11. In this interval, greatest integer function becomes equal to 10. Like this, go on, split this. Okay, 0 to 1, including 0, excluding 1. This becomes 0. Greatest integer value becomes 0. 1 to 2, it becomes 1. 2 to 3, it becomes 2. Continue like this, and so on. 10 to 11, it becomes 10. Integral of 0 is 0. Correct? This is equal to 0. Plus integral of 1 with respect to x is x. Limits from 1 to 2. Integral of 2 is 2x. Limits from 2 to 3. Like this it goes on. Integral of 10 is 10x. Limits from 10 to 11. Is equal to 2 minus 1 is 1 here. Plus 2 into 3 minus 2 is 1. Like this it goes on. 10 into what we have? Upper limit minus lower limit. 11 minus 10, 1. This is nothing but 1 plus 2 plus 3 plus etc. 10. Summation of 10. Summation of n is n into n plus 1 by 2. Summation of 10, this is 10 into 10 plus 1 divided by 2. This is 55. Option D is the answer. Or else I can give a shortcut method for this, a time saving result I can call. Integral from 0 to n, greatest integer function x is n into n minus 1 by 2. Just remember this. Integral from 0 to n should be natural number, okay? N should be natural number. The answer is n into n minus 1 divided by 2. N into n minus 1 divided by 2. This is true for all n belongs to natural numbers. For all n belongs to natural numbers. 0 to 11, if they give 11 into 11 minus 1 by 2, directly put n is equal to 10, you'll get the answer. 11 into 10 by 2, which is 55. Is that clear? Quite easy if you learn this. This is applicable for all n belongs to natural number. Lower limit is 0, upper limit should be a natural number, then only it's applicable of the greatest integer function. Question asked in the year 2012. Split at the points. If you're doing the actual method, if you want to learn the concept properly, then you need to split at the points where x becomes integer. Okay, 0 to 1, 1 to 2, 2 to 3. In each interval, you have to find out the greatest integer function and evaluate it. Because they can give x square. Suppose instead of giving x, they give x square. Then you have to learn the concept. The shortcut method doesn't work always. Correct? So learning the concept is more important. So even such kind of questions are asked. And see the next question. Here see, integral from 0 to 2, greatest integer value of x square is given. Question asked in the year 2019. For this, see x belongs to the interval 0 to 2. X belongs to the interval 0 to 2. X square belongs to which interval? X square belongs to the interval 0 to 4. Correct? So, integral from 0 to 2 of greatest integer value of x square. 0 to 2. Greatest integer value of x square dx. X is 0 to 2. So x square is 0 to 4. In the interval 0 to 4, where x square becomes integer at x equal to 1, x square equal to 1, x square equal to x square equal to 3. These are the integer values present in the interval 0 to 4. 0 to 4, in that interval, integers present are 1, 2, 3. X square is 1 means x is equal to plus or minus 1, but minus 1 is not there in this interval, so I'll take only the positive values. X square is 2 means x is plus or minus root 2, but minus root 2 is not there, so root 2. Here root 3, correct? So 1, root 2, root 3. These 3 points I need to split. So 0 to 2, I need to split at 1, root 2 and root 3. So 0 to 1, this is 0 to 1 plus 1 to root 2 plus root 2 to root 3. Finally, we have root 3 to 2. Okay. 0 to 1, x belongs to the interval 0 to 1, x square also belongs to 0 to 1 only. In the interval 0 to 1, excluding 1, of course, greatest integer function becomes 0. Correct? This is 0. X belongs to 1 to root 2, x lies between 1 and root 2, x square lies between 1 and 2, 1 and 2 greatest integer function is 1. X lies between root 2 and root 3, x square lies between 2 and 3, 2 and 3 greatest integer function is 2. X lies between root 3 and 2, that is for x. X square lies between 3 and 4, 3 and 4 it becomes 3. So this is integral of 0 is 0, integral of 1 is x, limits from 1 to root 2, integral of 2 is 2x, limits from root 2 to root 3, integral of 3 is 3x, limits from root 3 to 2. Correct? Evaluate the function. Integral of 1 is x, integral of 2 is 2x, integral of 3 is 3x. Evaluate the function in upper limit minus lower limit. This is root 2 minus 1 plus 2 times root 3 minus root 2 plus 3 times 2 minus root 3. What we get? This is equal to root 2 minus 1. This is 2 root 3 minus 2 root 2. 3 into 2, 6 minus 3 root 3. 6 minus 1 is 5. Correct? 6 minus 1 is 5. Root 2 minus 2 root 2 is minus root 2. 2 root 3 minus 3 root 3 is minus root 3. So I am getting 5 minus root 2 minus root 3, which is option D. 5 minus root 2 minus root 3. It's a very standard question. Even in JEE exam also this type of question was asked in 2025. That too. 2024 I guess. 2025 one question was asked. Same question, but they gave instead of 2, b minus a. And a and b should be got by using the domain of the function. Some question was asked. Mixing type of question. They asked integral from 0 to b minus a of this function. Same function. Okay. But b minus a, b and a should be got from the domain of the function f of x to log of. The domain of that function was the interval ab. From there you have to find out. Okay. So answer is 5 minus root 2 minus root 3. Option D. 2019 question. On to the next one. Here it's given integral from 0.2 to 3.5 greatest integer function. In the interval 0.2 to 3.5, x belongs to the interval 0.2 to 3.5. In this interval, which are the integers present? The integers present are 1, 2 and 3, correct? Between 0.2 and 3.5, integers present are 1, 2, 3. At those points, I need to split. So now, integral from 0.2 to 3.5, 0.2 to 3.5 of greatest integer function. This is equal to 0.2 to 1 plus 1 to 2 plus 2 to 3 plus 3 to 3.5. Correct? In the interval 0.2 to 1 excluding 1, any value you take, greatest integer function becomes 0. 1 to 2, any value of x you take, greatest integer function becomes 1. 2 to 3, any value of x you take, greatest integer function is 2. 3 to 3.5, greatest integer function becomes 3. Correct? Integral of 0 is 0. This part is 0 here. Integral of 1 is x. Limits from 1 to 2. Integral of 2 is 2x. Limits from 2 to 3. Integral of 3 is 3x. Limits from 3 to 3.5. Why we do like this? Because we are making the function continuous in each of the intervals so that the function is integrable. Correct? So in the interval 1 to 2, we are excluding 2. Correct? So 1 to 2 means the function is continuous. We know greatest integer function. One left hand point is included, right hand point is excluded. Like that we do. Okay? So that in each of the interval we are making it the function continuous so that it is integrable. So this is how much? 2 minus 1 is 1 plus 2 into 3 minus 2 is 1 plus 3 into this is 3.5 minus 3 which is 0.5. 3.5 minus 3 is 0.5. 2 into 1 to 2 plus 1 is 3. 3 plus 3 into 0.5 which is 1.5. So answer is 4.5. 4.5 is the answer, option C. Question asked in the year 2017. Please make a note. Move on to the next one. Next question. Integral from 0 to 8 of greatest integer function. Given the greatest integer function. Okay. Question answer there. 2022. Directly I can use the shortcut method. Time saving result I gave you. Correct? When I did the first question. Integral from 0 to n of greatest integer function x is equal to n into n minus 1 by 2. N into n minus 1 divided by 2. This is true for all n belongs to natural numbers. For all n belongs to natural numbers. Correct? So I can apply this formula. For all natural numbers, this is true. Integral from 0 to 8. Integral from 0 to 8 of greatest integer function x. 8 into 8 minus 1 divided by 2. This is 2 ones are 2 fours are 4 into 7 is 28. Correct? 8 into 7, 56 by 2. 28 is the answer. Option A. Directly using the time saving result. Because 8 is a natural number, I can apply it. 8 into 8 minus 1 by 2. 8 into 7. 2 ones are 2 fours are 4 into 7 is 28. Option A. 2022 question. Move on to the next one. Next we have property 4. Integral from a to b f of x dx same as integral from a to b f of a plus b minus x. This is called as King's rule. Replace x by lower limit plus upper limit minus x. Property 4 says that replace x by lower limit plus upper limit minus x. The value of the definite integral is not going to change. Replace x by lower limit plus upper limit minus x. We have one question of this type. Given f of x is equal to f of pi plus e minus x and integral from e to pi f of x dx given as 2 by e plus pi. Want to find the value of this integral from e to pi x into f of x dx. Start from this. Take this integral as I. I is equal to integral from e to pi x into f of x dx. Call this equation 1. Replace x by lower limit plus upper limit minus x using property 4. Using this property. Okay. X can be replaced by a plus b minus x. A plus b is lower limit plus upper limit. Correct? So replace x by e plus pi minus x. Replace x by e plus pi minus x. Therefore, integral I becomes equal to e to pi x becomes e plus pi minus x. F of e plus pi minus x dx. And according to the question, it's given that f of x is same as f of pi plus e minus x using this condition. F of x is equal to f of pi plus e minus x. This becomes what? Integral from e to pi e plus pi minus x f of e plus pi minus x same as f of x according to the given question. That becomes f of x. It is equal to integral from e to pi multiply this e plus pi into f of x e plus pi into f of x dx minus integral from e to pi x into f of x dx. Call this equation 2. Add equations 1 and 2. Equation 1 plus equation 2 gives what? 2i is equal to This will cancel, right? Integral from e to pi x into f of x dx. This and this will cancel. So e plus pi you can keep outside. E plus pi integral from e to pi f of x dx. And the second condition is given that integral from e to pi f of x dx is 2 by e plus pi, correct? So this is e plus pi into integral from e to pi f of x dx is 2 by e plus pi. 2 by e plus pi. E plus pi cancels, correct? E plus pi is going to cancel. What we get is 2i is equal to 2. 2i is equal to 2 means I is equal to 1. Value of this integral is 1. Option C is answer. Question asked in the year 2014. Please make a note. Similar type of question is found in NCERT exercise as well as NCERT exam, that book also. Move on to the next one. Next we have property 5. Integral from 0 to a f of x dx equal to integral from 0 to a f of a minus x. Because lower limit is 0 here, one can replace x by upper limit minus x. This is the particular case of property 4. Property 4 is more general, this is more particular because lower limit is 0. If you replace x by upper limit minus x, the value of definite integral is not going to change. It's not going to change. That is what the property 5 says. We'll work out the problems based on this, which is asked in the previous years. The first one we have integral from 0 to pi by 2 sin po 100x minus cos po 100x. Take the integral as I, already given as I here, correct? We can replace x by upper limit minus x because lower limit is 0. 0 to pi by 2 sin power 100x minus cos power 100x. Call this equation 1. Replace x by upper limit minus x. Replace x by pi by 2 minus x. Replace x by pi by 2 minus x. Therefore, I is equal to integral from 0 to pi by 2. X becomes pi by 2 minus x. Sin of pi by 2 minus x will be cos x, correct? Sin of pi by 2 minus x becomes cos x, becomes cos power 100x minus cos of pi by 2 minus x will become sin x. This becomes sin power 100x. Call this equation 2. Add equations 1 and 2 because you know that sin of pi by 2 minus x is cos x. Sin of pi by 2 minus x is equal to cos x. Cos of pi by 2 minus x is equal to sin x. Adding equations 1 and 2. Equation 1 plus equation 2 gives equation 1 plus equation 2. I plus I becomes 2i is equal to, if I add these two equations, sin per 100x is going to cancel, cos per 100x cancels, becomes 0. 2i is equal to 0. Therefore, I is equal to 0. The value of the integral is 0. Option C. Sin of pi by 2 minus x is cos x and cos of pi by 2 minus x sin x, using the concept of allied angles. Correct? Very simple question. All these things no need to work out. Directly you can crack. Looking at the question itself, instantly you can give the answer. So silly questions, all these things. Question asked in the year 2007. Move on to the next one. Question number 2 we have integral from 0 to pi by 2 cos x minus sin x by 1 plus cos x into sin x. Here also answer is 0. Because if we replace x by upper limit minus x, cos will become sin becomes cos becomes sin becomes cos. Denominator is same. 1 plus cos x into sin x is same as 1 plus sin x into cos x. Denominator is same. So if I add equations 1 and 2, 2i becomes 0 because numerator will cancel, will add up to 0. So 2i equal to 0, I equal to 0. If you want to show the steps, I is equal to integral from 0 to pi by 2. 0 to pi by 2 cos x minus sin x, cos x minus sin x divided by 1 plus cos x into sin x. Replace x by pi by 2 minus x using property phi. Because lower limit is 0, replace x by upper limit minus x. Call this equation 1. What we get? When we replace x by upper limit minus x, cos of pi by 2 minus x, which is sin x. Sin of pi by 2 minus x, which is cos x, divided by 1 plus cos of pi by 2 minus x, that is sin x. Sin of pi by 2 minus x, which is cos x. Equation 1 plus equation 2 we do. Equation 1 plus equation 2 gives I plus I. Left hand side becomes 2I. Denominator is same, right? 1 plus sin x into cos x is same as 1 plus cos x into sin x. If denominator is same, you can add the numerators. Denominator is 1 plus sin x into cos x. Denominator is same, so we add the numerators. When you add the numerator, the sum becomes 0. Cos x minus sin x plus sin x minus cos x. If you add the numerator, sin x will cancel, cos x will cancel, you get 0. 0 by some non-zero number is going to be 0. Integral of 0 is 0. 2i is equal to 0. Therefore, I is equal to 0. 2i is equal to 0. So, I is equal to 0. Option B. Question asked in there, 2004. What is the next one? Third question. Question asked this year, 2025 question. Integral from 0 to 1, log of 1 by x minus 1 dx. 0 to 1. Integral from 0 to 1, log of, I can take LCM and simplify this. 1 by x minus 1 could be written as 1 minus x by x. 1 minus x divided by x. Taking LCM inside the bracket, 1 by x minus 1 is 1 minus x by x. Take this as I. Equation 1. Replace x by upper limit minus x. Replace x by upper limit minus x because lower limit is 0. Correct? Replace x by upper limit minus x. Replace x by upper limit minus x. 1 minus x. What we get? So for I is equal to integral from 0 to 1 log of x becomes 1 minus x. Correct? 1 minus 1 minus x. 1 minus of 1 minus x divided by 1 minus x. This is equal to integral from 0 to 1 log of 1 minus of 1 minus x is x. X by 1 minus x. This is called equation 2. Because the lower limit is 0, replace x by upper limit minus x. Upper limit is 1. Correct? Using property phi. Integral from 0 to a f of x dx is same as integral from 0 to a f of a minus x. So replace x by upper limit minus x. Add equations 1 and 2. Equation 1 plus equation 2 gives. Equation 1 plus equation 2. 2i is equal to integral from 0 to 1 log of 1 minus x by x plus log of x by 1 minus x. Add this. Log of 1 minus x by x plus log of x by 1 minus x. So this is equal to integral from 0 to 1 log a plus log b, log of ab. Correct? This becomes log of, what we get? 1 minus x by x into x by 1 minus x. Correct? Because sum of the log is log of the product. Log a plus log b is log of ab. We know this property, correct? Log a plus log b is equal to log of ab. Sum of the log is log of the product. Log of ab we get. So x cancels. 1 minus x cancels, correct? So we get integral from 0 to 1 log 1 dx. Log 1 itself is 0, correct? Log 1 is 0, integral of 0 is 0 here. So 2i is equal to 0. What I got is 2i is equal to 0 implies I is equal to 0. The value of integral is 0. Option C is answer. 2025 question. Replace x by upper limit minus x. Upper limit is 1. First you take LCM and simplify this bracket. 1 by x minus 1 is 1 minus x by x. Replace x by upper limit minus x. 1 minus x will become x. X becomes 1 minus x. Add the two equations. Log a plus log b is log of ab. Merge it. Log a plus log b. Sum of the log is log of the product using this property. Correct? So then it becomes log 1. Log 1 is 0. Remember the value is very standard. Log 1 is 0. Integral of 0 is 0. So we got 2i is equal to 0. Therefore, I is equal to 0. Option C is answer. Next we have, this question is similar to question number 2. Correct? We had this question. Here we got integral from 0 to pi by 2 cos minus sine by 1 plus sine into cos. Correct? Now it is 0 to pi by 2 sine minus cos by 1 plus sine into cos. Answer is 0. Correct? Sine will become cos, cos will become sine. Sine minus cos plus cos minus sine. Denominator will be same. So answer is 0. Correct? So if you want to write the steps, 2 or 3 steps, I'll write integral from 0 to pi by 2 sin x minus cos x by 1 plus sin x cos x is given. Sin x minus cos x divided by 1 plus sin x into cos x. Equation 1. Replace x by pi by 2 minus x. I is equal to integral from 0 to pi by 2. Sine of pi by 2 minus x is cos x. Cos of pi by 2 minus x is sin x. Sine becomes cos and cos becomes sine. Divided by 1 plus sine of pi by 2 minus x is cos x and cos of pi by 2 minus x is sin x. Equation 2. Adding equations 1 and 2. Equation 1 plus equation 2 gives I plus I is 2i. Denominator is same. 1 plus sine into cos is same as 1 plus cos into sine. Denominator is same, means you can add the numerator. If you add the numerator, sine minus cos plus cos minus sine. Sin x will cancel, they are of opposite sign. Cos x will cancel. I get integral from 0 to pi by 2. 0 by 1 plus cos x into sin x. 0 by some non-zero number is 0. 2i equal to 0. Therefore, I is equal to 0. Value of this definite integral is going to be equal to 0. Option A is answer. Question asked in the year 1996. Move on to the next one. Integral from 0 to pi by 2 sine square x dx. Take the integral as I. It's all board exam level question. Already it's found in the NCERT book as well. 0 to pi by 2 sine square x dx. Equation 1. Replace x by upper limit minus x. Replace x by upper limit minus x. Pi by 2 minus x. I becomes integral from 0 to pi by 2 sine square of pi by 2 minus x. Sine square of pi by 2 minus x is cos square x. Because we know sine of pi by 2 minus x is cos x. Adding equations 1 and 2. I plus I becomes 2i. Equation 1 plus equation 2 gives 2i is equal to integral from 0 to pi by 2 sine square x plus cos square x is 1. Integral of 1 with respect to x is x. Limits from 0 to pi by 2. Correct? Evaluate the function at upper limit minus lower limit. Pi by 2 minus 0. This is 2i. 2i is equal to pi by 2. So I is equal to pi by 4. 2i is equal to pi by 2. Therefore, the value of this integral becomes equal to pi by 4. This is option D. Question asked in the year 1987. On to the next one. Integral from 0 to pi by 2 a sin x plus b cos x divided by sin x plus cos x dx. Take the integral as I, replace x by upper limit minus x. Take the integral as I, start with I is equal to integral from 0 to pi by 2. What we have is a sin x plus b cos x a sin x plus b cos x divided by sin x plus cos x. Equation 1. Replace x by pi by 2 minus x. Replace x by pi by 2 minus x. Replace x by pi by 2 minus x. This becomes I is equal to integral from 0 to pi by 2 a into sine of pi by 2 minus x is cos x. Sine and cos are co-functions. The complementary angle is at pi by 2 minus x. B into cos of pi by 2 minus x is sin x divided by sine of pi by 2 minus x is cos x. Cos of pi by 2 minus x is sin x. Equation 2. Correct? Replace x by pi by 2 minus x. Sine of pi by 2 minus x is cos x and cos of pi by 2 minus x is sin x. Sine and cos are co-functions. Denominator is same. Sine plus cos is same as cos plus sine. So adding equations 1 and 2, you get equation 1 plus equation 2 gives 2i is equal to integral from 0 to pi by 2. Denominator is same. Sin x plus cos x. Correct? Add the numerators. A sin x plus a sin x plus a sin x, a cos x. We can add these two. A is common here, correct? A sin x plus a cos x plus b cos x plus b sin x. From these two, a is common, correct? A into sin x plus cos x, second right. A into sin x plus cos x. Taking a common from these two. We are adding the numerators. A sin x plus a cos x. A is common, so sin plus cos. B cos x plus b sin x. B is common. B into sin x plus cos x. Correct? So that again sin x plus cos x is common from the numerator. This becomes integral from 0 to pi by 2. Sin x plus cos x is common. What we get is a plus b divided by sin x plus cos x. Sin x plus cos x dx. Sin x plus cos x is common. A plus b. Correct? Sin x plus cos x will cancel. What we get is integral from 0 to pi by 2. Sin x plus cos x will cancel. What remains is a plus b into dx. Correct? Taking sin x plus cos x common from the numerator and cancelling the denominator. Integral of constant is constant into x. If I am integrating with respect to x, this is a plus b into x. Integral of a plus b with respect to x, a plus b into x. Limits from 0 to pi by 2. Evaluate the function at upper limit minus lower limit. A plus b into pi by 2 minus 0, pi by 2. This is 2i, correct? 2i is equal to, I am getting a plus b into pi by 2. Therefore, I is equal to how much? Therefore, value of the integral becomes a plus b into pi by 4. This 2 comes down, correct? So, 2i is equal to a plus b into pi by 2. So, I is equal to a plus b into pi by 4. 2 comes to denominator. So, a plus b into pi by 4 is the answer. Option D. Just replace x by upper limit minus x because lower limit is 0. So, add equations 1 and 2. Correct? Sin of pi by 2 minus x is cos x and cos of pi by 2 minus x is sin x. Sin becomes cos, cos becomes sin. When you replace x by pi by 2 minus x, add equations 1 and 2 and go on simplify, integrate it and apply limits, get the answer. 2i is equal to a plus b into pi by 2. So, I is equal to a plus b into pi by 4. Option D. Move on to the next one. We have integral from 0 to a f of x dx equal to integral from 0 to a f of a minus x dx. This is given to us. It's a property. Basically, we know property phi. Want to find integral from 0 to pi x into f of sin x dx equal to what? Okay. Take this integral as I to begin with. I is equal to integral from 0 to pi x into f of sin x dx. Equation 1. Replace x by upper limit minus x. Replace x by pi minus x. Replace x by pi minus x. This becomes integral from 0 to pi minus x into f of sine of pi minus x. And we know sine of pi minus x is sine x. This is integral from 0 to pi minus x, f of sine of pi minus x is same as sine x. Pi minus x is second quadrant angle, correct? We'll call this as equation 2. There's a multiply right? One more step. Correct? Sine of pi minus x is sine x. Pi minus x is being a second quadrant angle. Second quadrant sine function is positive. So pi means 180 degree. Pi radians is 180. 180 means write the same function using the rules of allied angles. I get sine of pi minus x as sine x. Multiply this. Then add equations 1 and 2. Integral from 0 to pi into f of sine x, pi into f of sine x dx, minus integral from 0 to pi x into f of sine x dx. Call this as equation 2. Correct? Add equations 1 and 2. This will cancel. Correct? Integral from 0 to pi x into f of sine x will cancel. Adding equations 1 and 2. Equation 1 plus equation 2 gives 2i is equal to integral from 0 to pi into f of sine x dx. Correct? Add equations 1 and 2. This will cancel. Integral from 0 to pi x into f of sine x will cancel. Adding equations 1 and 2. So pi you can keep outside. So this given as, I can write this as I is equal to, pi is kept outside the integral. I is equal to pi by 2 integral from 0 to pi f of sine x dx. Like this we get. So the given integral 0 to pi x into f of sine x dx is also equal to pi by 2 into integral from 0 to pi by 2 f of sine x dx, which is option B. Correct? Pi by 2 into integral from 0 to pi by 2 f of sine x dx. And fourth option they given x into, that's not true. Even third option is not true. Correct? 0 to pi they given, 0 to pi by 2, 0 to pi, no, sorry. This should be pi, third option, not second option. It should be third option. 0 to pi, correct? So this is option C's answer. Pi by 2 into integral from 0 to pi f of sine x dx. Option C is answer, not option B. Upper limit is pi by 2 there in option B. Here we have upper limit as pi. So answer is option C. Just replace x by upper limit minus x, add equations 1 and 2 and simplify. We get I is equal to pi by 2 into integral from 0 to pi f of sine x dx. Option C is answer. Question asked from there 1998. Move on to the next one. We have some of the important time saving results here. Integral from 0 to pi by 2, function of sine by function of sine plus function of cos. Answer is pi by 4. Quite important. Even it works for cos by sine plus cos, sine by sine plus cos, or cos by sine plus cos. Integration from 0 to pi by 2 is given. Answer is pi by 4. Because sine and cos are co-functions, correct? So that's why it works. Sine of pi by 2 minus x is cos x, and cos of pi by 2 minus x sin x. Here second one we have tan by tan plus cot. Function of tan by function of tan plus function of cot, or cot by tan plus cot. Integration from 0 to pi by 2 is given. Answer is pi by 4. Integration from 0 to pi by 2 sec by sec plus cosec, or integral from 0 to pi by 2 cosec by sec plus cosec. In both the case answer is pi by 4. Because here tan and cot are co-functions, here sec and cosec are co-functions. Also we have integral from 0 to a f of x by f of x plus f of a minus x, a by 2, upper limit by 2, because lower limit is 0. This is more general. Integral from a to b f of x by f of x plus f of a plus b minus x is upper limit minus lower limit divided by 2, b minus a by 2. Okay, even it works for this 0 to a f of a minus x by f of x plus f of a minus x. Answer is a by 2 only. Your numerator can be f of x or it can be f of a plus b minus x. In both the case, answer is upper limit minus lower limit divided by 2. Please learn all these things. Time saving results. Useful to work out the problems easily. Within seconds you can answer. Within very few seconds you can answer. Here, integral from a to b sine by sine plus cos, or integral from a to b cos by sine plus cos. Answer is b minus a by 2. Upper limit minus lower limit by 2. Correct? Even it works for tan. Tan by tan plus cot, or cot by tan plus cot. Answer is b minus a by 2 if lower limit plus upper limit is pi by 2. Same thing works even for sec and cosec. Okay, a plus b should be pi by 2 here. And integral from 0 to a dx by x plus root of a square minus x square is pi by 4. This is one of the important results here. Put x equal to a sine theta, it becomes sine by sine plus cos. 0 to pi by 2, sine by sine plus cos is pi by 4. Using that we get the answer. Okay. So please learn all these things, quite important. Okay. So 0 to pi by 2, sine by sine plus cos, or cos by sine plus cos, tan by tan plus cot, or cot by tan plus cot, sec by sec plus cosec, or cosec by sec plus cosec. In all these cases, answer is pi by 4. And integral from 0 to a f of x by f of x plus f of a minus x. Integral from 0 to a f of a minus x by f of x plus f of a minus x. A by 2 is the answer. Integral from a to b f of x by f of x plus f of a plus b minus x. Same as integral from a to b f of a plus b minus x by f of x plus f of a plus b minus x. B minus a by 2. Upper limit minus lower limit by 2. Even in JEE exams also these kind of questions are asked based on this results. Okay. And we have here sine by sine plus cos, or cos by sine plus cos. Integral of tan by tan plus cot, or cot by tan plus cot. Integral of sec by sec plus cosec, or cosec by sec plus cosec. If integration from a to b is given, answer is b minus a by 2 if lower limit plus upper limit is pi by 2. Lower limit plus upper limit should be pi by 2 in all these cases. Okay, there are a few questions based on this. We'll take one by one all these things. Orally we can answer. Integral from 0 to pi by 4, cos by cos plus sine. Answer is pi by 4. Directly we can answer. Option D, using the time saving result. Correct? Using this. Integral from 0 to pi by 2, function of cos by function of sine plus function of cos. Correct? Answer is pi by 4. Directly we can answer. Answer is pi by 4. The question asked from there, 1985. Move on to the next one. Here, integral from 0 to pi by 2, sine cube x by sine cube x plus cos cube x. Answer is pi by 4, because function of sine by function of sine plus function of cos. Integral from 0 to pi by 2 is given. Answer is pi by 4. Close the eyes and write the answer. 1987 asked in the year. 1987. Move on to the next one. Here also, integral from 0 to pi by 2, function of cos by function of cos plus function of sine. Answer is pi by 4. Direct. Question asked in the year 1988. Move on to the next one. Question number 4. Integral from 0 to pi by 2, sine power 3 by 2x by sine power 3 by 2x plus cos power 3 by 2x. Answer is pi by 4. Question asked in the year 1991. Clear? Directly we can answer. Integral from 0 to pi by 2, 1 by 1 plus tan x. We write tan as sine by cos. Okay. Integral from 0 to pi by 2. What we get? 1 by 1 plus tan x, right? Sin x by cos x. Sin x divided by cos x. Then take LCM as cos x. This becomes integral from 0 to pi by 2. What you get is cos x divided by cos x plus sin x. Taking common denominator in the denominator, that will go to numerator. Denominator is denominator, goes to numerator. This takes the form integral from 0 to pi by 2, cos by cos plus sin. Answer is pi by 4. Directly we can answer. Answer is pi by 4. Option D. Okay. Question asked in the year 1993. Move on to the next one. Integral 0 to pi by 2 dx by 1 plus cot x. Cot, right? Cos by sin. Here we had tan, no? Tan we wrote sin by cos. Cot is cos by sine. Take the integral as I. Here also answer is pi by 4. So many times questions are asked based on this. Integral from 0 to pi by 2. 1 by 1 plus cot x, right? Cos x divided by sin x. Cos x divided by sin x. Take LCM as sin x. That sin x will go to numerator. correct? Integral from 0 to pi by 2. We'll get sin x divided by sin x plus cos x. Answer is pi by 4. Sin by sin plus cos. Integral from 0 to pi by 2. Answer is pi by 4. Option C. Very simple question. Asked in there. 1996. Next one. Same way here also. Cot write cos by sin. Correct? If you write cot as cos by sin, it becomes integral from 0 to pi by 2. 0 to pi by 2. Sin power 101x. Correct? Sin x to the power 101 divided by sin x power 101 plus cos x power 101. Cot is cos by sin. Take LCM. Sin goes up. Sin x power 101 by sin x power 101 plus cos x power 101. Answer is pi by 4. Function of sin by function of sin plus function of cos. Integral from 0 to pi by 2 is given. Answer is pi by 4. Option E. Question asked in there 1997. Move on to the next one. Here we have integral from 0 to pi by 2. 2 power sin x by 2 power sin x plus 2 power cos x. Answer is pi by 4. Function of sin by function of sin plus function of cos. Integral from 0 to pi by 2 is given. Pi by 4. Question asked in there 1999. Move on to the next one. Ninth one, integral from 0 to 2a, f of x by f of x plus f of 2a minus x. Answer is a, upper limit divided by 2. If you want to show the steps, I is equal to, take the integral as I, integral from 0 to 2a, what we have is f of x by f of x plus f of 2a minus x. F of x by f of x plus f of 2a minus x. Call this equation 1. Replace x by upper limit minus x. Upper limit is 2a. Replace x by 2a minus x. Correct? I is equal to, what we have, integral from 0 to 2a. X becomes 2a minus x. X becomes 2a minus x. Plus f of 2a minus x, that will be x. Equation 2. Correct? Replace x by 2a minus x. X becomes 2a minus x. 2a minus of 2a minus x becomes x. Add equations 1 and 2. You get the answer. Equation 1 plus equation 2 gives 2i is equal to integral from 0 to 2a. Denominator is same, so we can add the numerators. F of x plus f of 2a minus x. Denominator is same, so add the numerators. We get f of x plus f of 2a minus x. Cancels, becomes 1. Integral from 0 to 2a, 1 dx. Integral of 1 is x. Limits from 0 to 2a. This is 2a minus 0, which is 2a. This is 2i. 2i is equal to 2a, implies I is equal to a. I is equal to a. Option A is answer. Move on to the next one. Integral from 0 to infinity, x by 1 plus x into 1 plus x square. Whenever there is 1 plus x square, we make a substitution x equal to tan theta. You can see 1 plus x square here. So put x equal to tan theta. Make a substitution. X equal to tan theta. Also you see the derivative of tan theta is secant square theta. Dx is equal to secant square theta d theta. When x is equal to 0, when x is equal to 0, what we have? Tan theta 0, so theta is 0. When x is equal to infinity, theta is equal to how much? Tan theta is infinity. So theta is pi by 2. So limits will change when x tends to infinity actually. So the given integral becomes I is equal to 0 to infinity x divided by 1 plus x into 1 plus x square. This will become x is from 0 to infinity, theta is from 0 to pi by 2. 0 to pi by 2. 0 to pi by 2. X is tan theta divided by 1 plus tan theta into 1 plus tan square theta, and derivative of tan theta secant square theta, dx is secant square theta d theta. 1 plus tan square is secant square, correct? This and this same. 1 plus tan square is same as secant square. Secant square theta is going to cancel. 1 plus tan square theta is secant square theta. Therefore, this becomes integral from 0 to pi by 2. What we get is tan theta divided by 1 plus tan theta. Secant square theta is going to cancel. Tan you write sine by cos and simplify it. Integral from 0 to pi by 2. Tan theta is sine theta divided by cos theta divided by 1 plus tan theta, right? Sine theta divided by cos theta. So this is integral from 0 to pi by 2. Correct? Take LCM here. Cos theta, LCM, cos plus sine by cos. So we get 0 to pi by 2. Sine theta divided by cos theta plus sine theta. Answer is pi by 4. Integral from 0 to pi by 2. Sine by cos plus sine. Answer is pi by 4. Just go and simplify it and get the answer. Because there is 1 plus x square, we put x equal tan theta. 1 plus tan square is secant square. Derivative of tan also secant square. Question asked in there 2003. Next one. Integral from 0 to pi by 2. Tan power 7x by tan power 7x plus cot power 7x. Answer is pi by 4. Tan by tan plus cot, because tan and cot are co-functions, correct? Answer is pi by 4. Question asked in there 2017. Next one we have integral from 0 to 4042 root x by root x plus root of 4042 minus x. Answer is 2021. Correct? We have this result. Integral from 0 to a f of x by f of x plus f of a minus x. Answer is a by 2. A minus 0 divided by 2. Here it's given integral from 0 to 4042. 0 to 4042. F of x is root x. Correct? Root x divided by root x plus root of 4042 minus x. How much is the answer? Upper limit divided by 2. F of x is root x. Compare. F of x is root x. Root x by root x plus root of 4042 minus x. X has become 4042 minus x. X becomes a minus x according to the result. Correct? According to this result, x has become a minus x. Replacing x by upper limit minus x. This x has become 4042 minus x. 4042 is the upper limit. So answer is 4042 divided by 2. Which is equal to 2021. Answer 2021, asked in the year 2021. So beautiful, it is coinciding with the year. Answer is coinciding with the year in which year they asked. Correct. Next one, integral from 0 to pi by 2 sine power 1000x by sine power 1000x plus cos power 1000x. Answer is pi by 4. Sine by sine plus cos. Integral from 0 to pi by 2. Answer is pi by 4. Question asked in the year 2016. Next one, integral from 2 to 8 root of 10 minus x by root x plus root of 10 minus x. Integral from 2 to 10, 2 to 8 is given as 2 to 8 root of 10 minus x divided by root x plus root of 10 minus x. This is equal to upper limit minus lower limit divided by 2, which is 6 by 2 is equal to 3. Answer is 3, option C. Because we have the result integral from a to b, f of a plus b minus x, f of a plus b minus x divided by f of x plus f of a plus b minus x. Answer is upper limit minus lower limit divided by 2. Here f of x is root x. So that f of a plus b minus x root of 10 minus x. If we compare, f of x is root x. Here f of x is root x. What is lower limit plus upper limit? 2 plus 8 is 10, correct? So f of 2 plus 8 minus x, which is f of 10 minus x. F of 10 minus x, which is root of 10 minus x. Correct? Root of 10 minus x. F of a plus b minus x by f of x plus f of a plus b minus x is b minus a by 2. 8 minus 2 by 2. 6 by 2, 3. Option C. Question asked in the year 2016. Move on to the next one. Here also same type of question, similar to the previous one. Integral from 1 to 3 root of 4 minus x by root x plus root of 4 minus x. Answer is upper limit minus lower limit by 2. 3 minus 1, 2. 2 by 2. Answer is 1. Question asked in the year 2009. Correct? Integral from 1 to 3. 1 to 3 root of 4 minus x divided by root x plus root of 4 minus x. Answer is upper limit minus lower limit divided by 2. 2 by 2 is 1. Using the same result we had in the previous. Same result is used. Integral from a to b, f of a plus b minus x by f of x plus f of a plus b minus x. Upper limit minus lower limit divided by 2, where f of x is root x. Integral from a to b, f of a plus b minus x divided by f of x plus f of a plus b minus x. Answer is upper limit minus lower limit divided by 2. Correct? Where f of x is root x. Lower limit plus upper limit is 4. So f of 4 minus x will be root of 4 minus x. F of x is root x. F of 4 minus x will be root of 4 minus x. Move on to the next one. Question number 16. Integral from 2 to 8, 5 power root of 10 minus x by 5 power root x plus 5 power root of 10 minus x. Answer is upper limit minus lower limit by 2. 8 minus 2 by 2. 6 by 2. 3 is answer. Question asked in the year 2023. Correct? Integral from 2 to 8. 5 to the power root of 10 minus x divided by 5 power root x plus 5 power root of 10 minus x. Upper limit minus lower limit divided by 2. 6 by 2 equal to 3. Correct? F of a plus b minus x by f of x plus f of a plus b minus x. Upper limit minus lower limit by 2. Move on to the next one. Integral from pi by 6 to pi by 3. See, lower limit plus upper limit is pi by 2 here. Correct? Sine by sine plus cos. Answer is upper limit minus lower limit divided by 2. Similar type of question is found even in the NCERT book. Integral from pi by 6 to pi by 3. Sine cube x divided by sin cube x plus cos cube x. Note that lower limit plus upper limit is pi by 2. Note that pi by 6 plus pi by 3 is pi by 2. Pi by 6 plus pi by 3. Sum of these two is equal to pi by 2. Correct? Pi by 6 is 30 degree. Pi by 3 is 60 degree. 60 plus 30 is 90. 90 degrees pi by 2. So I can write the answer as upper limit minus lower limit divided by 2. Upper limit minus lower limit by 2. Pi by 3 minus pi by 6 is pi by 6. Pi by 6 divided by 2. Answer is pi by 12. Because we have integral from a to b, f of sin x by f of sin x plus f of cos x. Because sin and cos are co-functions, right? Because of that we have this result. Answer is going to be equal to b minus a divided by 2 if whenever a plus b is pi by 2. Whenever a plus b, sum of the lower limit and upper limit is pi by 2. Or else you can do the actual method also. That doesn't take much time. So you replace x by lower limit plus upper limit minus x. Lower limit plus upper limit is pi by 2. Replace x by pi by 2 minus x. Sin becomes cos and cos becomes sin. Add the two equations, you'll get the answer. That's it. Over. Get the answer as pi by 12. Option C is the answer. Question asked in the year 2012. Next one, we have this result. Many times questions are asked even in many competitive exams, not only CET, many other exams like NDA or any other competitive exams in India. Okay, state level questions or even JEE exams also questions can be asked based on this. Once it was asked on this cot power nx, okay, in JEE exam. In is defined like this, integral from 0 to pi by 4 tan power nx dx. N is not equal to 1. In that case, I can apply this formula. In plus in minus 2 is 1 by n minus 1. Quite important. Okay. And same result we have. In plus in minus 2 is 1 by n minus 1 for n not equal to 1. This formula works for n not equal to 1. Of course, n equal to 1 also we can take and integrate this and get the answer. But this formula is true for n not equal to 1. Okay. So that's why given the condition like that. So it also works for in is equal to integral from pi by 4 to pi by 2 cot power nx dx. In both the case it works. Okay. So I'll prove this if you want. One of them I'll prove. In is in plus in minus 2. Correct? In plus in minus 2 is equal to what? Integral from 0 to pi by 4 tan power nx plus integral from 0 to pi by 4 tan power n minus 2x dx. Correct? This is integral from 0 to pi by 4 tan power n minus 2x is common. Correct? What you can write inside the bracket is tan square x plus 1. Tan power n minus 2x is common. Tan square x plus 1. Tan square x plus 1 is secant square x. Integral from 0 to pi by 4 tan power n minus 2x into secant square x dx. To integrate this, we put t is equal to tan x. Put t is equal to tan x. Derivative of tan x is secant square x. Limits will change. When x is 0, t is equal to how much? Find out. When x is equal to 0, t is equal to tan 0. Tan 0 is 0. When x is equal to pi by 4, when x is equal to pi by 4, t is equal to tan pi by 4, which is 1. So limits will change. X is 0 to pi by 4, t is 0 to 1. Tan x is t, correct? So this becomes t power n minus 2. Secant square x into dx is dt. Integral of t power n minus 2 is t power n minus 1 divided by n minus 1. Integral from limits from 0 to 1. Evaluate the function in upper limit minus lower limit. We'll get the answer. 1 by n minus 1. Evaluate the function at upper limit. Upper limit is 1. 1 to the power n minus 1 is 1. Minus 0 power n minus 1, 0. So we get the answer is 1 by n minus 1. Similarly, we can prove the second one. Integral from pi by 4 to pi by 2 cot power nx dx. In plus in minus 2 is 1 by n minus 1. Same way you can prove. Tan power n minus 2x is common. So what remains is tan square plus 1. Combine the two integrals. Correct? Because lower limit is same, upper limit is same. Combining the two integrals, adding these two, tan power n minus 2x is common. What remains is tan square plus 1. 1 plus tan square x secant square x. Derivative of tan is secant square. So integrate by method of substitution. And whenever you make a substitution, you need to differentiate and change the limits. Put t equal to tan x. Derivative of tan x secant square x. Limits is changed because these limits are valid only for x. X varies from 0 to pi by 4. T is from 0 to 1. Tan x is t, so t power n minus 2 secant square x into dx dt. Integral of x power n formula, x power n plus 1 by n plus 1. Integral of t power n minus 2 is t power n minus 1 by n minus 1. Limits from 0 to 1. 1 by n minus 1 keep outside. Value of t. Evaluate the function in upper limit minus lower limit, get the answer. 1 by n minus 1. It's better to remember this. Very important. Move on to the next. The questions on this. In is defined like this. Integral from 0 to pi by 4 tan power nx. Question asked two times, once in the 2011 and 2021. Want to find I10 plus I8. If In is equal to integral from 0 to pi by 4 tan power nx, we have the result that In plus In minus 2 is 1 by n minus 1. Correct? In plus In minus 2. In plus In minus 2 is equal to 1 by n minus 1. Correct? So I10 plus I8. Just put n is equal to 10. I10 plus I8 is equal to 1 by 10 minus 1, which is 1 by 9. Put n is equal to 10. I10 plus I8 is 1 by 10 minus 1, 1 by 9. Answer is option T. Quite simple one. Correct, based on the result. Move on to the next one. Here also, integral from 0 to pi by 4 tan power n theta d theta is defined as In. Want to find this. N into In minus 1 plus In plus 2. What we have? We have if In is equal to integral from 0 to pi by 4 tan power n theta d theta. What we have from this? In plus In minus 2 is 1 by n minus 1. In plus In minus 2 is 1 by n minus 1. Here we want to find In minus 1 plus In plus 1. So replace n by n plus 1 in this. Replace n by n plus 1. Replace n by n plus 1. What we get? This is In plus 1 plus I suffix n plus 1 minus 2, which is n minus 1. Correct? Replace n by n plus 1. In plus 1 plus I suffix n plus 1 minus 2, n minus 1. Replace n by n plus 1. What do we get? Here also replace n by n plus 1. N plus 1 minus 1 becomes n. N plus 1 minus 1, which is 1 by n. Correct? Then you cross multiply this. This is n into In plus 1 plus In minus 1. Cross multiply n into is equal to 1. Answer is 1. Option C. Just replace n by n plus 1. We get this result. In plus 1 plus I suffix n plus 1 minus 2. That is n minus 1. Replace n by n plus 1. N plus 1 minus 1. Correct? Here you are replacing n by n plus 1. Correct? So 1 by n plus 1 minus 1, that is 1 by n, cross multiply and we get the required expression as 1. Question asked in the year 2000. Please make a note. Move on to the next one. Next result we have, this is also quite important. Integral from 0 to 1 x into 1 minus x whole power n dx is 1 by n plus 1 n plus 2 for n not equal to minus 1 not equal to minus 2. Similar type of question result we have, integral from 0 to a x into a minus x to the power n is equal to a power n plus 2 by n plus 1 n plus 2 for n not equal to minus 1 n not equal to minus 2. This also you can remember. Okay, this is a to b actually, not 0 to b, a to b. Okay, integral from a to b mod x dx is b mod b minus a mod a by 2, because integral of mod x is x mod x by 2. A to b it is, okay, not 0 to b, a to b, a to b mod x dx. Integral of mod x is x mod x by 2, correct? Limits from a to b, so we get b mod b minus a mod a by 2, b mod b minus a mod a divided by 2. Integration is from a to b mod x dx. Answer is b mod b minus a mod a by 2. There is one question based on this asked. Integral from 0 to 1 x into 1 minus x power 3 by 2 dx. We have integral from 0 to 1 x into 1 minus x power n as what we have, 1 by n plus 1 n plus 2. 1 by n plus 1 into n plus 2. Correct? Integral from 0 to 1 x into 1 minus x to the power n, n is 3 by 2. This is equal to 1 by 3 by 2 plus 1 into 3 by 2 plus 2. Just put n is equal to 3 by 2. 3 by 2 plus 1 is 5 by 2. Correct? 3 by 2 plus 1 is 5 by 2. 3 by 2 plus 2 is 7 by 2. This 2 into 2, 4 goes to numerator. Denominator goes to numerator. We get the answer as 4 by 35. 4 by 35 is the answer. Option D. Question asked in the year 2010. Okay. Move on to the next one. Two more important results we have. Integral from 0 to pi by 4 log of 1 plus tan x dx is pi by 8 log 2. So important result. It's found in your NCERT book itself. And also equivalent to that we have integral from 0 to 1 log of 1 plus x by 1 plus x square dx pi by 8 log 2. Both of them are pi by 8 log 2 only. Here second one can be got by putting x equal tan theta. When you put x equal tan theta, this becomes log of 1 plus tan theta. Correct? Because you put x equal tan theta, limits will change. X is tan theta, no? So when x is 0, theta is 0. When x is 1, theta is pi by 4. And 1 plus tan square theta is same as secant square theta. Derivative of tan is secant square. In this, no? In this you put x equal tan theta, it becomes the first one only. First and second both are same. Correct? Pi by 8 log 2. If you want to show, put x equal to tan theta. So that derivative of tan theta is secant square theta. Dx is equal to secant square theta d theta. Correct? When x is equal to 0, when x is equal to 0, what do you get? Tan theta 0. Tan theta 0 means theta is equal to 0. When x is equal to pi by, when x is equal to 1, theta is equal to pi by 4. When x is 1, tan theta is 1. Tan theta is 1 means theta is pi by 4. Correct? When x is 0, theta is 0. When x is 1, theta is pi by 4. Lower limit 0 corresponds to theta equal to 0. Upper limit 1 corresponds to theta equal to pi by 4. So lower limit and upper limit will change. X is 0 to 1, theta is 0 to pi by 4. Log of 1 plus tan theta divided by 1 plus tan square is secant square. Derivative of tan also secant square will cancel. Will get same as this. And by using property 1, I can tell both are same. Correct? So if you want, I can add one page here. I is equal to integral from 0 to 1 log of 1 plus x by 1 plus x square dx. Log of 1 plus x divided by 1 plus x square dx. Because you put x equal tan theta, this becomes 0 to pi by 4 log of 1 plus tan theta. And this is 1 plus tan square theta. Derivative of tan is secant square theta d theta. 1 plus tan square will cancel. Correct? Integral from 0 to pi by 4 log of 1 plus tan theta d theta. This is same as integral from 0 to pi by 4 log of 1 plus tan x dx, which is pi by 8 log 2. Learn this result, quite important. Integral from 0 to pi by 4 log of 1 plus tan x is pi by 8 log 2. Same as integral from 0 to 1 log of 1 plus x by 1 plus x square dx. Please learn this. Integral from 0 to 1 log of 1 plus x by 1 plus x square dx is pi by 8 log 2. Also 0 to pi by 4 log of 1 plus tan x dx. I can use property 1, variables can be changed. The value of definite integral is not going to change if the function is same and the lower limit and upper limit is same. Clear? So please learn this. Two important results. Even in JEE exam also the questions were asked based on this earlier in PYQ if you see. There is one such question here. Integral from 0 to pi by 4 log of 1 plus tan x dx. Directly we can answer pi by 8 log 2. Quite very important. Standard one. They already found in the NCERT book. Correct? Can be asked for 6 marks along with the property proof and problem they'll ask for 6 marks. Correct? Board exams. So quite important. Okay. So please learn it, memorize it for competitive exam as a standard result. Answer also to remember. Question asked in the year 2000 and 2005. 2 times. Pi by 8 log 2. Okay. Next one we have integral from 0 to pi by 4 log of sine plus cos by cos. Here you can separate the terms. Sine by cos plus cos by cos. Sine by cos is tan, cos by cos is 1. Integral from 0 to pi by 4 log of, here sin x by cos x is tan x, correct, plus cos x by cos x is 1. Integral from 0 to pi by 4 log of 1 plus tan x. Answer is pi by 8 log 2. Pi by 8 log 2 is answer. Option C. Question asked in the 2015. Just separate the terms. Sin by cos plus cos by cos. Instead of asking 0 to pi by 4 log of 1 plus tan x, they give like this. Integral from 0 to pi by 4 log of sin plus cos by cos. Log of 1 plus tan x. Pi by 8 log 2. Option C is answer. Next one we have integral from 0 to 1 log of 1 plus x by 1 plus x square dx. Answer is pi by 8 log 2. Just proved this now. Correct? This is equivalent to, this is same as integral from 0 to pi by 4 log of 1 plus tan x dx. Answer is pi by 8 log 2. Question asked in the year 2020. Next one. We have property 6 and property 7. Property 6 says integral from 0 to 2a f of x dx equal to integral from 0 to a f of x dx plus integral from 0 to a f of 2a minus x dx. Property 6. And property 7, there are two cases. Integral from 0 to 2a f of x dx is 2 times integral from 0 to a f of x dx if it satisfies the condition f of 2a minus x equal to f of x, and it is 0 if it satisfies the condition f of 2a minus x equal to minus f of x. Integral from 0 to 2a f of x dx is 2 times integral from 0 to a f of x dx if f of 2a minus x equal to f of x. If it satisfies the condition f of 2a minus x equal to minus f of x, then answer is 0. Okay. So we have one question here. There are many questions, but one question is found in the PYQ. Okay. Integral from 0 to pi is given. Cos power 4x by integral from 0 to pi cos power 4x divided by cos power 4x plus sin power 4x. Here this integrand, the given function, is going to satisfy that condition f of 2a minus x equal to f of x. See, upper limit is pi, correct? Lower limit is 0. So my upper limit is pi means the 2a value is pi, correct? If we're comparing with this, upper limit is 2a. I need to find f of 2a minus x. So my function f of x is cos power 4x by cos power 4x plus sin power 4x. Cos power 4x by cos power 4x plus sin power 4x. Find out f of pi minus x. Find out f of pi minus x. Upper limit is pi. Correct? So this becomes cos power 4 pi minus x. Cos power 4 pi minus x divided by cos power 4 pi minus x plus sin power 4 pi minus x. Replacing x by upper limit minus x. Upper limit is pi. Replace x by pi minus x. Cos of pi minus x is minus cos x. Minus cos x power 4 is cos power 4x. Sin of pi minus x is sin x. So sin power 4 pi minus x same as sin x. Sin power 4x. Correct? Sin power 4 pi minus x same as sin power 4x. So this will be same as f of x. This becomes cos power 4x divided by cos power 4x plus sin power 4x. Same as f of x. So that means f of pi minus x equal to f of x. That means f of 2a minus x equal to f of x is satisfied. Here f of 2a minus x equal to f of x is satisfied. So what we can write? Use case 1 of property 7. So this becomes I is equal to integral from 0 to pi becomes 2 times 0 to pi by 2. What we get is cos power 4x divided by cos power 4x plus sin power 4x. Because property 7 first case is satisfied, f of 2a minus x equal to f of x. Because of that, integral from 0 to pi becomes 2 times 0 to pi by 2. And we know the standard value for this, pi by 4 is the answer, correct? 0 to pi by 2, cos by cos plus sin is pi by 4 for this, correct? Value of this integral is pi by 4. 2 times pi by 4, which is equal to pi by 2. Correct? Integral from 0 to pi by 2, cos by cos plus sin is pi by 4. 2 into pi by 4 is pi by 2. Option B is the answer. 0 to pi is split 2 times 0 to pi by 2. Because of this condition, f of 2a minus x equal to f of x. F of 2a minus x equal to f of x means integral from 0 to 2a becomes 2 times 0 to a. Correct? 2 times integral from 0 to a f of x dx. Because f of 2a minus x equal to f of x. 2 times pi by 4, which is pi by 2. Option B is the answer. Move on to the next one. There are some results here. Okay, please learn all these results, quite important. Integral from 0 to pi by 2 log of sin x is very important. It's minus pi by 2 log 2 or pi by 2 log half. Same is the story for integral from 0 to pi by 2 log of cos x. This is found in the NCERT book itself. Integral from 0 to pi by 2 log of sin x minus pi by 2 log 2 or pi by 2 log half, because minus log is log 1 by e. And integral from 0 to pi by 2 log of secant x is pi by 2 log 2, because sec is reciprocal of cos. Correct? Sec is reciprocal of cos. Log 1 by e is minus log e. Using that I get this. Integral from 0 to pi by 2 log of secant x. Log of secant x is going to be equal to integral from 0 to pi by 2 log of 1 by cos x. Secant x is 1 by cos x. Correct? Secant x is 1 by cos x. So this becomes log a by b. Log a by b is log a minus log b. Log a by b is log a minus log b. Log 1 is 0. Correct? This becomes integral from 0 to pi by 2 log 1 minus log cos x. Log 1 minus log cos x. Log 1 is 0. Correct? Log 1 itself is 0. Correct? Minus you can keep outside. So integral from 0 to pi by 2. Minus is kept outside. Log of cos x. Correct? So integral from 0 to pi by 2 log of secant x is minus integral from 0 to pi by 2 log of cos x. Integral from 0 to pi by 2 log of cos x is minus pi by 2 log 2. Minus of minus becomes plus pi by 2 log 2. Correct? So this is equal to pi by 2 log 2. Minus of minus plus pi by 2 log 2 again. Hence we get minus of minus becomes plus pi by 2 log 2. Same way you can prove this. Integral from 0 to pi by 2 log of cosec x also pi by 2 log 2 because cosec is reciprocal of sine. And integral from 0 to pi by 2 log of tan x and log of cot x both are 0. That also you can prove. You can write tan as sine by cos and prove it. So integral from 0 to pi by 2 log of tan x is there, no? Tan x we can write sin x by cos x. Sin x divided by cos x. And you can use the property here. Log of a by b is log a minus log b. This becomes 0 to pi by 2 log of sin x minus log of cos x. Log of sin x minus log of cos x. Take this integral as I. I is equal to this. Replace x by upper limit minus x. Sin becomes cos. Cos becomes sin. Add the two equations. 2i becomes 0. So I equal to 0. So value of integral from 0 to pi by 2 log of tan x is 0. Correct? Replace x by pi by 2 minus x. I is equal to integral from 0 to pi by 2 log of, here sine of pi by 2 minus x is cos x minus log of cos of pi by 2 minus x is sin x. Add the two equations. Equation 1, equation 2. If I add the two equations, I get 2i is equal to 0. Hence, we get the value of the integral is 0. Is that clear? Add this and this. Log of sin x will cancel. They are of opposite sign. Log of cos x will cancel. So it becomes 0. Integral from 0 to pi by 2 log of tan x with respect to x is 0. Integral from 0 to pi by 2 log of cot x also 0. Same way can prove. And integral from 0 to pi by 2 log of sin x is minus pi by 2 log 2. Integral from 0 to pi by 2 log of cos x also same. Minus pi by 2 log 2. Please learn this. And integral from 0 to pi by 2 log of secant x pi by 2 log 2. 0 to pi by 2 log of cosec x also pi by 2 log 2. Integral from 0 to pi x by 1 plus sin x is pi given here. And integral from 0 to pi log of sin x is 2 times integral from 0 to pi by log of sin x. So this is minus pi by 2 log 2. Double of that is this minus pi log 2, which is pi log half, because minus log 2 is log 1 by 2. Correct? Minus log 2 is log 1 by 2. All these things you should remember. Correct, the important results. And integral from 0 to pi log of 1 plus cos x also minus pi log 2. Even this question is found in the NCERT book. Correct? 0 to pi log of 1 plus cos x and 0 to pi log of 1 minus cos x. Both are same. Minus pi log 2 only. If you want, I can add one page and show you the proof of this. 0 to pi log of sin x is 2 times integral from 0 to pi by 2 log of sin x. See, integral from 0 to pi log of sin x if you take 0 to pi log of sin x. This we can write it as 2 times 0 to pi by 2. This we can write it as 2 times integral from 0 to pi by 2 log of sin x dx. Because log of sin x will satisfy the condition f of 2a minus x equal to f of x. If you take f of x as log of sin x, f of x as log of sin x, you find out f of upper limit minus x. What is f of pi minus x? F of pi minus x is log of sine of pi minus x. F of, I am finding f of upper limit minus x, f of 2a minus x. This is actually f of 2a minus x. This is log of sine of pi minus x is sin x. F of 2a minus x same as f of x. So I can split this because we have this property integral from 0 to 2a f of x dx is equal to 2 times integral from 0 to a f of x dx. If it satisfies f of 2a minus x equal to f of x. F of 2a minus x equal to f of x. Integral from 0 to pi becomes 2 times 0 to pi by 2 log of sin x. And integral from 0 to pi by 2 log of sin x is very standard. minus pi by 2 log 2. 2 into, this is minus pi by 2 log 2. So 2 cancels, we get minus pi log 2. And one more we had integral from 0 to pi log of 1 plus cos x. That also I can show. Integral from 0 to pi log of 1 plus cos x. Here what you do is replace x by upper limit minus x. If you replace x by upper limit minus x, becomes cos of pi minus x. Cos of pi minus x is minus cos x. Replace x by pi minus x. Replace x by upper limit minus x. I is equal to integral from 0 to pi log of 1 minus cos x. Cos of pi minus x is minus cos x. Add equations 1 and 2. 2i is equal to integral from 0 to pi log 1 plus x plus log 1 minus x. Log e plus log b. Log of ab. Log of 1 plus cos x plus 1 minus cos x. Log of 1 plus cos x into 1 minus cos x. Correct? Log AB is log A plus log B. Log A plus log B. Log of A into B. Correct? Multiply the two terms inside the bracket. Log A plus log B. Sum of the log is log of the product. 1 plus cos x into 1 minus cos x is 1 minus cos square x. 1 minus cos square x. 1 minus cos square x is sin square x. Correct? So this becomes integral from 0 to pi log of sin square x. You know 1 minus cos square x is sin square x. So this becomes 2 times integral from 0 to pi log of sin x. Log m power n we know, n log n. The power 2 is brought down using the property of log. Log a power b is b log e. So 2 comes down. 2i is equal to 2 times integral from 0 to pi log of sin x. 2 cancels. Correct? So we get I is equal to integral from 0 to pi log of sin x. 2 is going to cancel. So I am getting I is equal to integral from 0 to pi log of sin x dx. Same as minus pi by 2 log 2. Minus pi by 2 log 2. Correct? Sorry, minus pi log 2. Minus pi log 2. Correct? This is 2 times 0 to pi by 2. So minus pi log 2. Minus pi log 2. Zero to pi log of sin x is minus pi log 2. Also I can remember integral from 0 to pi x into log of sin x. I'll give you that also. So it's better to remember even that. Integral from 0 to pi, take the integral as I is equal to integral from 0 to pi x into log of sin x. Even this is standard actually. They can ask in the exams. Take this as equation 1. Replace x by pi minus x. Replace x by pi minus x. What we get? I is equal to integral from 0 to pi x becomes pi minus x log of sine of pi minus x. This is integral from 0 to pi minus x into sine of pi minus x is sine x. Correct? We know using the allied angles concept. This is integral from 0 to pi log sine x, pi log sine x minus x log sine x. Add equations 1 and 2. X log sin x will cancel. Adding 1 and 2, we get 2i is equal to integral from 0 to pi log sin x. X log sin x will cancel. Adding the two equations. Pi you can keep outside. Pi log sin x. Correct? This is equal to pi into, we know integral from 0 to pi log of sin x is minus pi log 2. This is minus pi log 2. Correct? 0 to pi log of sin x. This now we got. Integral from 0 to pi log of sin x is minus pi log 2. I'm using that. So I is equal to how much? Minus pi square by 2 into log 2. Adding equations 1 and 2, we got 2i. So I will be equal to, I is the given integral. I is equal to minus pi square by 2 into log 2. 2 comes to denominator. 0 to pi log of sin x is minus pi log 2. So learn all these things. Integral from 0 to pi by 2 log of sin x is minus pi by 2 log 2. Correct? Integral from 0 to pi by 2 log of sin x is minus pi by 2 log 2. Integral from 0 to pi log of sin x is going to be equal to minus pi log 2 minus pi log 2, and integral from 0 to pi x into log of sin x is going to be equal to minus pi square by 2 log 2. Correct? One by one we can remember all these things. They are all connected to each other. 0 to pi by 2 log of sin x, 0 to pi log of sin x, 0 to pi x into log of sin x minus pi square by 2 log 2. And integral from 0 to pi log of 1 plus cos x, same as 0 to pi log of 1 minus cos x. Both of them are minus pi log 2. Okay, and also you can remember. 0 to pi log of 1 plus cos x, same as integral from 0 to pi log of 1 minus cos x. Both of them are minus pi log 2, and minus pi log 2 is pi into log half, because minus log 2 is log 1 by 2, shown here. Minus log is log 1 by. All these things better to learn. Remember this. Okay. There are a few questions here. Integral from 0 to pi by 2 log of tan x dx. Answer is 0. So many times asked. I think it's a favorite question for all the examiners. Whenever they set the question paper, KCET question papers, it's a favorite question. KEA's favorite question. This is because CET exam is conducted by KEA, Karnataka Examination Authority. So I can tell this is KEA's favorite question. Asked in the year 2002, 2001, 2000, 1999, 1998, 1995, 1994, 1993, 1986. Answer is 0. Integral from 0 to pi by 2 log of tan x is 0. Okay. Already proved earlier. Correct. I've shown the steps here. I've shown the steps. 0 to pi log of tan x. Tan is sine by cos. Log of sin x minus log of cos x. Replace x by pi by 2 minus x. Sin becomes cos and cos becomes sin. Add the two equations. Log of cos x will cancel. Log of sin x will cancel. 2i equal to 0, I equal to 0. So remember, integral from 0 to pi by 2 log of tan x is 0. Even integral from 0 to pi by 2 log of cot x is 0. Log of tan x is 0. So many times appeared already. Integral from 0 to pi by 2 log of sin x dx minus pi by 2 log 2. Already shown that you remember. Minus pi by 2 log 2 or pi by 2 log half. So question found in your NCERT book. Please remember this. Okay. Minus pi by 2 log 2 or it is pi by 2 log half. Answer option E. Question asked in the year 1992. Some more results we have. Integral from 0 to pi x dx by a square cos square x plus b square sin square x pi square by 2ab. Integral from 0 to pi by 2 it is, not pi. This is pi by 2, okay. Sorry, mistake is there. 0 to pi by 2 dx by a square cos square x plus b square sin square x pi by 2ab. This is pi by 2, make a correction. Integral from 0 to pi x tan x by secant x plus cos x. Same as 0 to pi x into sin x by 1 plus cos square x. That is going to be equal to pi square by 4. Okay. And 0 to pi x tan x by secant x plus tan x. That is pi into pi minus 2 by 2. Secant x plus tan x it should be here. So mistake in this. This is tan x. X tan x by secant x plus cos x is pi square by 4. 0 to pi x tan x by secant x plus tan x is pi into pi minus 2 by 2. And even this is also same. And integral from 0 to pi by 2 1 by sine plus cos x root 2 into log of root 2 plus 1. 0 to pi by 2 log of sin x minus log of sin 2x is minus pi by 2 log 2. All these things wanted to learn. Make a correction here, small correction here. 0 to pi by 2, the second point, okay? It should be 0 to pi by 2, 1 by a square cos square x plus b square sin square x, pi by 2ab. Both are important actually. Even one question appeared on this, okay, in KCET in JE exam this year, based on this result, first one. The second one is 0 to pi by 2, please make a correction. And the fourth one is denominator is secant x plus tan x. Questions are asked based on this. Integral from 0 to pi x dx by a square cos square plus b square sin square. Answer is pi square by 2ab. Option C. And this is pi by 2ab, very standard. 0 to pi by 2, 1 by a square cos square x plus b square sin square x. Answer is pi by 2ab. Before I can prove it, we divide numerator and denominator by cos square x. For this, we can divide numerator and denominator by cos square x. 0 to pi by 2, 1 by cos square x, that is secant square x. Divide by cos square x. Divide by cos square x. A square plus b square into tan square x. Dividing numerator and denominator by cos square x. 1 by cos square x is secant square x. A square dividing by cos square x. Cos square by cos square 1. Here sin square by cos square is tan square. Then you can put t is equal to b tan x. Put t is equal to b tan x. dt by dx. dt by dx is b into secant square x. So this becomes dt divided by b is equal to secant square x into dx. Limits also to change. When x is equal to 0, t equal to how much we find out. When x is equal to 0, t is equal to tan 0, 0. When x is equal to pi by 2, t is equal to tan pi by 2. We can take it as infinity. So limits will change. Integral from 0 to infinity. Secant square x into dx is dt by b from this. Derivative of b tan x is b into secant square x. So secant square x into dx is dt by b. dt by numerator is dt divided by b. Divided by a square plus b square into tan square x is t square. 1 by b keep outside. 1 by b integral from 0 to infinity 1 by a square plus t square dt. This is 1 by b integral of 1 by a square plus t square is 1 by a tan inverse of t by a. 1 by a tan inverse of t by a. Limits from 0 to infinity. Evaluate the function at upper limit minus lower limit. 1 by ab into tan inverse of infinity minus tan inverse of 0. Tan inverse of 0 is 0. Tan inverse of infinity is pi by 2. So pi by 2 minus 0. That is pi by 2. So we get pi by 2ab. Please learn this. Okay. Very important. Standard one. I have proved it also in general. And also this is also can be proved. You can replace x by pi minus x. Upper limit minus x. Then also we need to apply case 1 of property 7 here. Then it becomes integral from 0 to pi by 2 1 by a square cos square plus b square sin square. Finally get the answer as pi square by 2ab. Even this was found in the NCERT book earlier. Now it's deleted, I think so. In the old NCERT book you can find this question. It's a very standard one. In 2025 JE exam also one question was asked like this. Integral from 0 to pi, I think 8x dx by 25 cos square x plus 16 sin square x. This was the question asked. Something like this. The question was asked. 8 you can keep outside. Integral from 0 to pi x by 25 cos square x plus 16 sin square x. Like this. Similar type of question, I think so, was asked. And you can compare. A square is 25, so A is plus or minus 5. Of course, I'll take A as positive here. B square is 16, so B is plus or minus 4. I'll take B as 4. So this will be 8 into pi square by 2ab. Pi square divided by 2 into A is 5 and B is 4. 4 into 2, 8 cancels. We get pi square divided by 5. This was the question. Answer is pi square by 5. 2 into 4, 8 will cancel. pi square by 5. Just an example is given. I think so this was a question asked in the year JEE 2025, but not pretty sure about this. Numbers I'm not sure, but similar type of question was asked, 100% guarantee. So please learn this as a standard result. And once again, this is pi by 2ab. Integral from 0 to pi by 2, 1 by a square cos square plus b square sin square, pi by 2ab. Question asked in there, 2017. And we have some questions on odd and even function. Odd and even function property, property 8. Integral from minus a to plus a f of x dx is 2 times integral from 0 to a f of x dx if f of x is even function. 0 if f of x is odd function. Very important. And function f of x is said to be an odd function if it satisfies f of minus x equal to minus f of x. And the graph of odd function is always symmetrical about the origin. And even function means f of minus x equal to f of odd function. Okay, even function I have not given here definition. I think so. Given in the next, even function is here. Even function means f of minus x equal to f of x. Graph of even function is symmetrical about y-axis. These points better to remember. And some of the familiar odd functions are given here. Some of the familiar odd functions in terms of log is there, exponential, correct? So in terms of trigonometric functions, sine, tan, cot, cosine, all these things are odd function. And the power of sine is odd number means odd function, correct? Whenever odd function is given and power of odd function is odd number means it becomes odd function. See, if the powers of sine is odd number, power of tan is odd number, correct? 99, 101, and x cos x is also odd function here. Because cos x is even function, x is odd, odd into even is odd function. Among the inverse trigonometry functions we have sine inverse, tan inverse and cosec inverse. Because sine inverse of minus x is minus sine inverse x. Tan inverse of minus x minus tan inverse x. Cosec inverse of minus x is minus cosec inverse x. And all these things we can prove. Sine of minus x, no, minus sin x. Tan of minus x minus tan x. F of minus x equal to minus f of x, odd function. In terms of log we have all these things. Familiar odd functions. All these things better to remember. Log 1 plus x by 1 minus x, log 1 minus x by 1 plus x, log of secant x plus tan x, log of secant x minus tan x, log of x plus root 1 plus x square, log of a plus x by a minus x. All these things are familiar odd functions. Okay, log of x plus root of x square plus 1, log of x square plus x plus 1 by x square minus x plus 1. Many odd functions in terms of log here. In terms of exponential we have here e power x plus e power minus x into e power x minus e power minus x, e power x plus 1 by e power x minus 1, e power x plus e power minus x by e power x minus e power minus x, 2 power x plus 1 by 2 power x minus 1, e power sin x minus e power minus sin x. There are many odd functions. Odd function means it satisfies f of x plus f of minus x equal to 0. And in terms of polynomial function, and x mod x is also odd function. X by root 1 plus x square, x by 1 plus x square. Many odd functions are given here. List of odd functions. And mixture of sine and trigonometry function with x. X by 1 plus cos x, sine by 1 plus cos, sine x by root 1 plus x square, x into log 1 plus x square. All these things is better to remember. Familiar odd functions. They can construct many odd functions because whenever an odd function is given, to integrate from minus a to plus a, answer is 0. Okay. So it's better to remember all these odd functions. List of odd functions is given. So frequently used. And some of the even functions are given here. Among the trigonometry function, cos and sec are even function. And the power of odd function is even number, it becomes even function. If odd function is given, its power is even number, it becomes even function for trigonometry in particular. Sin square x, tan power 4x, x into sin x. A trigonometry function is given. If it is a trigonometry function is an odd function, if the power is even number, it becomes even function. Sin square x, sin x is an odd function, sin x is an odd function, but sin square x is even function. Tan cot 4x also even function. X into sin x is even function, correct? Like that we have all these things. Familiar even function. X power 4 is even function. Cos x even into even is even. Mod x is even. X power 4, x square, x power 100. Power of x is even number means it becomes even function here. X power 6 plus x power 8, all these things. Root 1 plus x square, root 1 minus x square, root x square minus 1, x into log 1 plus x by 1 minus x, x cube into log 1 plus sin x by 1 minus x, x into log of secant x plus tan x. All these things, because odd into odd is even. Even function into even function is even function. Odd function into even function becomes odd function. Product of two odd functions is even function. Okay, odd into odd is even into even is even, odd into even is odd for functions I'm telling. So all these things you must know. Okay, so and also I given the list of the table is given here. F and G are two functions. F is odd and G is odd. F plus G is odd. Odd function plus odd function is odd function. Odd function minus odd function is odd function. Odd into odd is even function. Product of two odd function becomes even function. Even function and even function, if you add it is even function. If you subtract the two even function, you get even function. Even function into even function is even function. If you take f as odd function and g as even function, odd function plus even function is neither odd nor even. If you take x plus x square, x is odd function, x square is even function. X plus x square is neither odd nor even. It's not odd function, it's not even function. Similarly, odd function minus even function, neither odd nor even. If you take the product of odd and even, it is going to be equal to odd function. Okay, this can be compared to minus into minus, plus, plus into plus, plus, minus into plus, minus. Okay, so you must know all these things. And numbers are different and functions are different. If you take two odd numbers, 3 and 5, multiply odd number and odd number, they get odd number only. 3 into 5, 15, odd number. But odd function into odd function is even function. Numbers are different, functions are different. And if you take two even function into even function is even function. For numbers, even into even is even only. That is same. And if you take the product of odd number and even number, 3 into 4, 12. Odd number into even number is even number. Correct? 3 into 4, 12. 3 is odd number, 4 is even number, 3 into 4, 12 is even number. So odd number into even number is even number. Whereas odd function into even function is odd function. Correct? So all these things you must know. And every function f of x can be expressed as sum of odd function and even function. F of x minus f of minus x by 2 is odd function. And f of x plus f of minus x by 2 is even function. Even function, odd function. Okay? Both f and f of minus x are defined in the domain of f. The condition is there. Every function f of x which can be expressed as sum of odd function and even function. Even function is this, f of x plus f of minus x by 2. Odd function is f of x minus f of minus x by 2. So golden tips is given. The power of sine is even number. 2n is even number, correct? Sine power 2nx is always even function. Because power of sine is even number means it becomes even function. Power of sine is odd number means it becomes odd function. Cos power nx is always even function. Whether the power is odd number or even number, does not matter. Cos cube x, even function. Cos power 4x also even function. Power of cos, whatever it may be, no problem. Cos is always even function. Sine will become odd function if the power is odd. Power of sine is odd number means odd function. Power of sine is even number means it becomes even function. Even function, odd function. This is even function. Okay. And sine power nx into cos power mx, product of these two will be an odd function if the power of sine is odd number. Correct? And power of cos can be anything. It can be odd number or even number. So it does not depend upon the power of cos. Cos is always even function. The power is odd number or even number, whatever. Cos is always an even function. Power of sine is odd number means odd function. Odd into even becomes odd function. This product becomes odd function if the power of sine is odd number. And the same product becomes even function if n is even. The power of sine is even number. This product becomes even function. Cos power mx does not depend upon the power. Correct? So remember, sine power nx into cos power mx. This product will become an odd function if the power of sine is odd number. The power of sine is odd number. It does not depend upon the power of cos. This product becomes odd function if the power of sine is odd number. And this product becomes even function if the power of sine is even number. Correct? Power of sine is even number, it becomes even function. The power of sine is odd number, it becomes odd function. Does not depend upon the power of cos. Cos is always even function. Even into odd is odd function. Even into even is even function. Hope it's clear. Okay, questions can be asked based on this. There are some questions here. We'll work out the questions based on odd function, even function property. The value of integral from minus pi by 4 to pi by 4. Log of secant theta minus tan theta. Answer is 0. Because log of secant theta minus tan theta is an odd function. Integral of odd function from minus a to plus a is 0. If you want to prove this is an odd function, take f of theta as log of secant theta minus tan theta. Log of secant theta minus tan theta. This is odd function. I'll prove. Replace theta by minus theta. F of minus theta becomes log of secant of minus theta. Secant of minus theta is secant theta. Tan of minus theta is minus tan theta. Minus of minus becomes plus. Correct? Because we know secant of minus theta is equal to secant theta. Secant of minus theta is same as secant theta. Tan of minus theta is equal to minus tan theta. Add the two equations. If you add the two equations, what do you get? F of theta plus f of minus theta is equal to log a plus log b. Log of ab, correct? Log of secant theta minus tan theta plus log of secant theta plus tan theta. Correct? Log a plus log b, log of ab. Correct? This becomes log of the product of these two. A minus b into a plus becomes a square minus b square. Sum of the log is log of the product. Log a plus log b is log of ab. Multiply these two. When you multiply these two, it becomes secant square theta minus tan square theta. Secant theta minus tan theta into secant theta plus tan theta. Multiplying these two. Multiplying these two again. Secant square minus tan square. This is 1. This is log 1. Log 1 is 0. Correct? F of theta plus f of minus theta is 0. Getting f of theta plus f of minus theta is equal to 0. That means f of minus theta is equal to minus f of theta. Correct? So for it is an odd function. So integral of odd function from minus pi by 4 to plus pi by 4 0. Question asked in the year 2014. Please make a note of an odd function. List of odd function is given. Please learn all the odd function. Then only it becomes easy to solve. Next one we have integral from 1 to 3 x minus 1 into x minus 2 into x minus 3 dx. So here what I'll do is I'll make a substitution for the middle bracket. These three are consecutive numbers, I can tell, correct? X minus 1, x minus 2, x minus, it comes one after the other. I'll take the middle one as t. Put t as x minus 2. Put t as x minus 2. So that when you differentiate this, dt by dx is 1. dt by dx is 1. So dt is equal to dx. dt is equal to dx. Change the limits. Whenever you make a substitution, differentiate and change the limits. When x is equal to, lower limit is 1. When x is 1, t is equal to how much? T is equal to 1 minus 2 is minus 1. When x is equal to, upper limit is 3. When x is equal to 3, t is equal to 3 minus 2 is 1. Correct? When x is 1, t is minus 1. When x is 3, t is 1. So limits will change. 1 to 3, x is 1 to 3, t is minus 1 to plus 1. Minus 1 to plus 1 I get. What is x? Because you put t as x minus 2, from this x is equal to what? X is equal to t plus 2. X is t plus 2. Correct? So x is t plus 2. T plus 2 minus 1. X minus 2 is t. And x is t plus 2. T plus 2 minus 3. T plus 2 minus 3. Dx is same as dt. Correct? I'll get like this. This becomes integral from minus 1 to plus 1. T plus 2 minus 1 is t plus 1 into t. T plus 2 minus 3 is t minus 1. Correct? 2 minus 3 is minus 1. 2 minus 1 is 1. What is t plus 1 into t minus 1? T square minus 1. Correct? This becomes integral from minus 1 to plus 1. T into t square minus 1. T into t square minus 1 becomes a t cube minus t. Integral from minus 1 to plus 1. T cube minus t dt. The power of t is odd number, means it becomes odd function. Integral from minus a to plus a, odd function is 0. So value of this is 0 because this entire thing is an odd function. Integral from minus a to plus a, odd function is 0. Answer is 0. Option C. Question asked in the year 1991. Move on to the next one. Value of integral from minus 2 to plus 2 ax cube plus bx plus it depends upon what? See, power of x is odd number, means it is an odd function. X cube is odd function. X is odd function. So integral of minus 2 to plus 2 ax cube plus bx will be equal to 0. It depends upon the value of c. C is a constant, correct? So every constant function is going to be an even function, correct? So I can write this as integral from minus 2 to plus 2 ax cube plus bx, ax cube plus bx into dx plus integral from minus 2 to plus 2 c dx. Separating and writing, combining ax cube plus bx in one bracket, c in another, correct? This entire thing is an odd function. This entire thing is an odd function. Integral of an odd function from minus a to plus a is going to be equal to 0. This is odd function. Correct? So integral of an odd function from minus a to plus a is 0. And integral of c is cx, limits from minus 2 to plus 2. 2 minus minus 2 becomes 4. So answer is 4c. Depends upon the value of c. Depends upon the value of c. Does not depend upon the values of a and b. Depends upon the value of c, correct? The value of this integral depends upon the value of c. Answer is 4c for this. So it depends upon the value of c. Question asked in the year 2008. Nice question. Move on to the next one. Integral from minus pi by 4 to pi by 4 dx by 1 plus cos to x. So cos is an even function, I told you, correct? So 1 plus cos to x even function. If you want, you can take f of x equal to 1 plus cos to x. F of x is 1 plus cos to x. You can replace x by minus x. If you are not knowing whether it's an odd function or even function, replace x by minus x. You get cos of minus to x. Cos of minus to x is same as cos to x. F of minus x is equal to f of x. So integral from minus pi by 4 to pi by 4. Dx by 1 plus cos to x. This is equal to 2 times integral from 0 to pi by 4 dx by 1 plus cos to x, because 1 plus cos to x is an even function. 1 plus cos to x is an even function. F of minus x equal to f of x. That condition is satisfied. So I can split like this. Minus a to plus a is 2 times 0 to a. So this you can write it as 2 times integral from 0 to pi by 4 dx divided by 1 plus cos to x is 2 cos per x. 2 cancels. And you know 1 by cos per x is secant per x. 0 to pi by 4 secant per x dx. 2 cancels. 1 by cos per x is secant per x. Integral of secant per x is tan x. Limits from 0 to pi by 4. Evaluate the function at upper limit minus lower limit. Tan pi by 4 minus tan 0. Correct? Tan pi by 4 is 1. Tan 0 is 0. 1 minus 0 is 1. Option E. Question asked in the year 2015. 1 plus cos to x, 2 cos per x. 1 by 2 cancels. 1 by cos square is secant square. Integral of secant square is tan. Evaluate the function upper limit minus evaluate the function at lower limit. 1 minus 0 is 1. Option A. This question is also found in the NCERT exemplar book. Same question. Please make a note. Move on to the next one. Question asked in the 2024. Integral from minus pi to pi 1 minus x square into sin x into cos square x. Sin x is odd function. Cos square x even function. 1 minus x square is even function. Correct? 1 minus x square. 1 minus x square is even function. Because it satisfies f of minus x equal to f of x. 1 minus x square is even function. Sin x is odd function. Sin x is odd function. Sin x is odd function. Cos square x is even function. Cos square x is even function. Cos x is even function. Even cos square x is even function. And product of odd and even is odd function. Even function into even function is even function. 1 minus x square is even function. Sin x is odd function. Correct? Cos square x even function. Even into even is even. Even into odd is odd. So resultant is odd function. Integral of odd function from minus pi to plus pi is going to be equal to 0. Correct? Even function into even function is even function. Already a table is given for that. Shown here. That's why all these things you need to learn properly. Correct? Then only it's possible. The entire table is given. F and G. Odd into odd is even. Even into even is even. Even into odd is odd. Even function into odd function is odd function. Product of odd and even is odd function. Correct? Odd into odd, even. Even into even is even. Odd into even is odd. Learn this table. So answer is 0. Question asked in the year 2024. Next one we have f of x given as a polynomial function here. G of x defined like this. F of minus x minus f of x by x square plus 3. Already told that f of x minus f of minus x is an odd function. For any function f of x such that f of x and f of minus x both are well defined in the domain of the function. F of x plus f of minus x is going to be even function. F of x minus f of minus x odd function. Correct? So f of minus x minus f of x. G of x is given as f of minus x minus f of x divided by what we have is x square plus 3. Denominator is even function. X square plus 3 is even function. Numerator is odd function. Correct? You must know that f of x minus f of minus x is going to be an odd function. Is going to be an odd function. So that f and f of minus x both are well defined in the domain of the function. Okay, the condition is there. And f of x plus f of minus x is going to be always an even function. F of x minus f of minus x is odd function. F of x plus f of minus x even function. And negative of odd function is again odd function. So f of minus x minus f of x. This numerator part is there, no? Numerator is going to be an odd function. Numerator is an odd function. X square plus 3 is even function. Odd function by even function is odd function. So whatever given function g of x happens to be an odd function. Integral of odd function from minus a to plus a. Minus 2 to plus 2. Answer is 0. Option C is the answer. Question asked in the 2006. You must know that f of x minus f of minus x is odd function. F of x plus f of minus x is even function. And f of minus x minus f of x also odd function. X square plus 3 is even function. Odd function by even function is odd function. Whatever f of x is there, we are not worried about that. Of course, they are given a polynomial function of degree 2 here. Correct? So numerator is odd function. Denominator is even function. Odd function by even function is odd function. Integral of odd function from minus 2 to plus 2 is 0. Please make a note. Next one we have. Even like this, question asked in there 2023. Minus 2 to 0. Quite big expression is given here. What I'll do is, you can see x plus 1 is highlighted here. And also we see that x cube plus 3x square plus 3x plus 3 is there. Correct? You know, familiar with this. X cube plus 3x square plus 3x plus 3 could be written as x cube plus 3x square plus 3x plus 1 plus 2. Like this, you can separate plus 1 plus 2. What is x cube plus 3x square plus 3x plus 1, which is x plus 1 the whole cube. This is x plus 1 the whole cube, correct? Using a plus b whole cube formula I can get a cube plus b cube. 1 is same as 1 cube. A cube plus b cube plus 3ab into a plus b, or 3a square b plus 3ab square. X plus 1 the whole cube plus 2. So I can simplify this as integral from minus 2 to 0. Minus 2 to 0. This part will be how much? X plus 1 the whole cube plus 2. X plus 1 the whole cube plus 2 plus x plus 1 into cos x plus 1. X plus 1 into cos x plus 1. Here what I'll do is I'll make a substitution for x plus 1 as t. Put t equal to x plus 1. Put t equal to x plus 1. Make a substitution for this. T equal to x plus 1. Differentiate this. dt by dx is 1. Correct? Derivative of x plus 1 is 1. So that dt is equal to dx. Change the limits. When x is minus 2, t equal to how much? When x is equal to minus 2, t is equal to minus 2 plus 1, that is minus 1. When x is equal to, upper limit is how much? Upper limit is x equal to 0. When x is equal to 0, t is equal to how much? 0 plus 1, which is 1. Correct? Limits will change. When x is minus 2, t is minus 1. And when x is 0, t is 1. Correct? X is minus 2, t is minus 1. When x is 0, t is 1. Limits will change now because of the introduction of new variable. Minus 1 to plus 1. Correct? X is minus 2 to 0. T is minus 1 to plus 1. X plus 1 we have taken as a t. So this becomes t cube. T cube plus 2 plus t into cos t. Dx is same as dt. T cube is odd function. T into cos t is odd function. Cos is even function. T is odd function. Odd into even is odd function. Cos is even function. T is odd function. Product of odd and even is odd function. This is an odd function. T cube is odd function. Correct? Integral of odd function from minus a to plus a is going to be 0. This is integral from minus 1 to plus 1. T cube plus t cos t. Group these two in one bracket because they are odd function. And integral from minus 1 to plus 1 to dt. This entire thing is an odd function. Integral of an odd function. Correct? From minus 1 to plus 1 is going to be 0. Integral of 2 is 2t. Limits from minus 1 to plus 1. 2 into upper limit minus lower limit. 2 into 2 becomes 4. Option D is the answer. Evaluate the function upper limit minus lower limit. Integral of constant is constant into t because I am integrating with respect to t. Integral of 2 is 2t. Upper limit minus lower limit. 1 minus minus 1. 1 plus 1, 2. 2 into 2 is 4. Option D is the answer. Question asked in the year 2023. Next one, question number 8, we have integral from minus half to plus half cos inverse x dx. This can be done by two methods. One is by using the properties of the definite integral, of course the odd function, even function property. Otherwise I can do it by integration by parts also. Even though the properties of ITF is deleted, like sin inverse x plus cos inverse x equal to pi by 2, all those things, still we can do it by integration by parts. So we can't tell this question is out of syllabus. It comes within the syllabus itself. So if you're doing by integration by parts, it is like this. Integral from minus half to plus half. Minus half to plus half. Cos inverse x dx is there, no? You can write integral of cos inverse x as x into cos inverse x minus root of 1 minus x square. You can learn this formula. Already I told to remember this. Integral of cos inverse x is x into cos inverse x minus root of 1 minus x square. Limits from minus half to plus half. We can do this. Or else, if you're using the properties of ITF, you know that sin inverse x plus cos inverse x is pi by 2 for all x belongs to closed interval minus 1 plus 1. I'm using that one. Sin inverse x plus cos inverse x is equal to pi by 2. Sin inverse x plus cos inverse x is pi by 2 for all x belongs to the closed interval minus 1 to plus 1. You must know this. So from this I can write cos inverse x as pi by 2 minus sin inverse x. Integral from minus half to plus half. Cos inverse x could be written as pi by 2 minus sin inverse x using this. It's a property of ITF which is deleted at present from the syllabus, from the NCERT book. Okay, but still you can this question can be asked in the exam because you can do it by integration by parts as written here. Integral of cos inverse x is x into cos inverse x minus root 1 minus x square. So I'll be using the property of ITF and do this. I'll use property of ITF and also I'll use property of the definite integral. Definite integral, both I'll be using. Cos inverse x could be written as pi by 2 minus sin inverse x. Pi by 2 minus sin inverse x. And sin inverse of x is an odd function. So integral of odd function from minus a to plus a is going to be 0. Correct? This becomes equal to minus half to plus half pi by 2 dx minus integral from minus half to plus half sin inverse x dx. Sin inverse of x is an odd function. Sin inverse of x is an odd function. Integral of odd function from minus a to plus a is 0. This part is 0. Integral of constant is constant into x. Integral of pi by 2 is pi by 2 into x. Limits from minus half to plus half. And integral of odd function is going to be 0 from minus half to plus half. Correct? Pi by 2 into this will be half minus minus half. Half plus half is 1. So pi by 2 into 1. Answer is pi by 2. This is an odd function. Integral of an odd function from minus a to plus a is going to be 0. Hope it's clear. Answer is pi by 2, which is option C. Question asked in the year 2020. Property of ITF and property of definite integrals. Odd function, even function properties. Odd function. Integral of an odd function from minus a to plus a is 0. Evaluate the function at upper limit minus evaluate the function at lower limit. Half less half is 1. 1 into pi by 2 is pi by 2. Move on to the next one. Integral from minus 3 to plus 3 cot inverse x dx. We know cot inverse x could be written as pi by 2 minus tan inverse x. Correct? Using the property of ITF, we know that tan inverse x plus cot inverse x is pi by 2. Correct? Tan inverse x plus cot inverse x is pi by 2 for all x belongs to R. This property holds. For all x belongs to R. So I can write integral from minus 3 to plus 3. Minus 3 to plus 3 cot inverse x dx is equal to integral from minus 3 to plus 3 cot inverse x is pi by 2 minus tan inverse x. Correct? Because tan inverse x plus cot inverse x pi by 2. Cot inverse x is pi by 2 minus tan inverse x. And tan inverse x is an odd function. Integral of odd function from minus a to plus a is 0. You can write this as integral from minus 3 to plus 3 pi by 2 dx minus integral from minus 3 to plus 3 tan inverse x dx. Integral of constant is constant into x. Correct? Limits from minus 3 to plus 3. And integral of odd function from minus a to plus a is 0. Tan inverse of x is an odd function. Tan inverse of x is an odd function. Okay? This becomes pi by 2 into 3 minus minus 3, 3 plus 3, 6. So pi by 2 into 6, which is equal to 3 pi. Note that tan inverse x is an odd function because tan inverse of minus x is minus tan inverse x. Among the ITFs, sin inverse, tan inverse and cosec inverse, these three are odd function because sin inverse of minus x is minus sin inverse x. Tan inverse of minus x minus tan inverse x. Even cosec inverse of minus x is minus cosec inverse x. Of course, domain of x, domain also matters where it lies. Okay, sin inverse of minus x is minus sin inverse x. For all x belongs to closed interval minus 1 plus 1. Tan inverse minus x is minus tan inverse x, holds for all x belongs to R. And cosec inverse minus x is minus cosec inverse x, holds for all real numbers except the open interval minus 1 plus 1. Correct? If you are doing it by integration by parts, the formula is integral of cot inverse x is x into cot inverse x plus half log 1 plus x square. That also can be done. Okay? Integral of cot inverse x. Integral of cot inverse x is x into cot inverse x plus half log 1 plus x square. Using this also we can get the answer. Without using the properties of ITF and without using the property of the definite integral, one can get the answer using this. Limits from minus 3 to plus 3. We'll get the same answer. Answer will be 3 pi. If you want, you can try this method. Learn this formula. In integration by parts also I told to remember this. All the formulas for integrals of every inverse trigonometric function has to be memorized. Integral of sin inverse x is x into sin inverse x plus root of 1 minus x square. Integral of cos inverse x, x into cos inverse x minus root 1 minus x square. Integral of tan inverse x, x into tan inverse x minus half log 1 plus x square. Of course, add a constant c for every indefinite integral. Integral of cot inverse x is x into cot inverse x plus half log 1 plus x square. Integral of secant inverse x is x into secant inverse x minus log of mod x plus root x square minus 1 plus c. Integral of cosec inverse x is x into cosec inverse x plus log of mod x plus root of x square minus 1 plus c. Okay. So here the answer is 3 pi, question asked in the 2019. Move on to the next one. The value of integral from minus half to plus half cos x into log 1 minus x by 1 plus x. Note that cos x is even function. Log 1 minus x by 1 plus x odd function. Product of odd and even function is odd function. Even function into odd function is odd function. Integral of odd function from minus a to plus a is going to be equal to 0. Okay. Cos x is even function. Cos x is even function. Cos x is even function. Log 1 minus x by 1 plus x is odd function. Log of 1 minus x by 1 plus x is odd function. Integral of an odd function. Product of odd and even is odd function. Correct? If you multiply odd function and even function, the product of odd and even function is odd function. This product is going to be an odd function. Even into odd is odd. Integral of odd function from minus a to plus a is going to be equal to 0. If you want, you can prove this. Log 1 minus x by 1 plus x is odd function. I can prove if you want. You take f of x as log 1 minus x by 1 plus x. If you take f of x equal to log of 1 minus x divided by 1 plus x. You replace x by minus x. F of minus x. F of minus x is equal to what? Log of 1 minus x becomes 1 plus x. 1 plus x becomes 1 minus x. Add the two equations. What we get is f of x plus f of minus x. F of x plus f of minus x. Sum of the log is log of the product. Adding these two means log of multiplying those. Log 1 minus x by 1 plus x. Log 1 minus x by 1 plus x plus log of 1 plus x by 1 minus x. Sum of the log is log of the product. This becomes log of 1 minus x by 1 plus x, 1 minus x by 1 plus x into 1 plus x by 1 minus x. So this becomes log 1. Log 1 is 0. f of x plus f of minus x equal to 0 means I can conclude that f of minus x is equal to minus f of x. Odd function condition is satisfied. So log 1 minus x by 1 plus x is an odd function. So product of even and odd function is odd function. Integral of odd function from minus half to plus half is 0. Question asked in the year 2002. On to the next one. The value of integral from minus pi by 4 to pi by 4 sine power 103x into cos power 101x. Cos is always an even function. It does not depend upon the power. Whatever may be the power, cos function is always odd function. Sine power 103x is odd function. Sine function will be an odd function if the power is odd number. And if the power is even number, it becomes even function. Here sine to the power odd number is given, so it is an odd function. Sine power 103x is an odd function. Cos power 101x even function. Product of odd and even is odd function. Integral of odd function from minus pi by 4 to plus pi by 4 is 0. Correct? Sine power 103x is odd function. Cos power 101x is even function. Product of odd and even. Product of odd and even is going to be an odd function. Integral of an odd function from minus a to plus a 0. Question asked me there 2016. Please make a note. Move on to the next one. Question number 12. The value of integral from minus 1 to plus 1 sine power 5x cos power 4x. Cos is always an even function. Whatever may be the power, it does not depend upon the power. Cos is always an even function. Cos power 4x is even function. Sine to the power odd number is odd function. Once again, sine power 5x is odd function. Cos power 4x is even function. Product of odd and even function is going to be an odd function. Correct? Product of odd and even function is going to be an odd function. Integral of odd function from minus a to plus a. Minus 1 to plus 1. Answer is 0. Question asked this year, 2025. Quite simple question. Same question is found in the NCERT book itself. Correct? On to the next one. Value of integral from minus 2 to plus 2 mod of x into cos pi x dx. Here x into cos pi x, modulus function is there, no? Mod of x into cos pi x is going to be an even function. Cos is an even function. X is odd function. But mod is there, no? Because of this mod, this product becomes an even function. Note that mod of x into cos pi x is an even function. Even function. So I can split this minus 2 to plus 2 becomes 2 times 0 to 2. Correct? 2 times 0 to 2. The given integral is I, I'll call. I is equal to minus 2 to plus 2 mod of x into cos pi x. This is equal to 2 times integral from 0 to 2 mod of x into cos pi x, because mod of x into cos pi x is even function, using even function property. Now, x lies in the interval 0 to 2. So, pi x will lie in the interval which, according to that question, x belongs to the interval 0 to 2. Correct? So, that pi x means multiply by pi. It lies in the interval 0 to 2 pi. 0 to 2 pi means it covers all the 4 quadrants, first 4 quadrants. First quadrant and fourth quadrant cos function is positive. Second and third quadrant cos function is negative. So I'll split this because there is modulus function. I need to split. X is anyway positive. Cos pi x, it may be positive or negative depending upon where pi x lies. Correct? So this you can simplify it as 2 times. I'll split this using splitting property. 0 to pi by 2. First quadrant, 0 to half it is actually. 0 to half. X lies in the interval 0 to half. Pi x will lie in the interval 0 to pi by 2. Correct? If you take 0 to half, x lies in the interval 0 to half, pi x will belong to 0 to pi by 2. 0 to pi by 2 is first quadrant, cos function is positive, x is already positive, so I get mod of x cos pi x is x into cos pi x plus half to 3 by 2. Half to 3 by 2, x lies in the interval half to 3 by 2 means pi x will belong to the interval pi by 2 to 3 pi by 2. Pi by 2 to 3 pi by 2 means it covers second and third quadrant. In second and third quadrant, cos function is negative. So mod of x cos pi x becomes minus x cos pi x. Plus 3 by 2 to 2. X lies in the interval 3 by 2 to 2. Pi x will belong to 3 pi by 2 to 2 pi. 3 pi by 2 pi means fourth quadrant. Fourth quadrant cos function is positive. X is anyway positive. Positive into positive is positive. So mod of x cos pi x is x into cos pi x. Now integrate each of this and apply limits and get the answer. You can apply integration by parts to integrate this, the product of two functions, or else I can use the time saving result for this. The first function is x here, cos pi x is second function according to Eilert. According to Eilert, algebraic comes first, then comes trigonometric, correct? So x is algebraic, cos pi x is trigonometric, first into second. So to integrate that, integral of x into cos pi x, see I'll write in one stretch the answer for this. X into cos pi x, first function keep as it is. Integral of cos pi x is sin pi x. Sin pi x divided by coefficient of x, which is pi, minus differentiate the first function, integrate the second function. Integral of derivative of x is 1. Integral of sin is minus cos pi x divided by pi. Divided by pi is already there, so it becomes minus cos pi x by pi square. Minus cos pi x divided by pi square, correct? First function keep as it is, integrate the second function, minus differentiate the first, integrate the second, correct? Derivative of x is 1, integral of sin pi x minus cos pi x divided by pi square, because pi is already the denominator, another pi comes, pi into pi becomes pi square, correct? So of course we have to add a constant c for every indefinite integral, but now it's definite integral, so no need to add a constant c. Even though if I add the constant, it's going to cancel out. So this is equal to 2 times integral of this is going to be this much, correct? Minus into minus is going to be plus there, x sin pi x plus cos pi x by pi square, correct? So x into sin pi x by x into sin pi x divided by pi, correct, plus cos pi x by pi square. For this I need to apply limits 0 to half for this. For this 0 to half, plus into minus is minus. Here integral of this is x into sin pi x divided by pi plus cos pi x divided by pi square. Limits from half to 3 by 2 plus for this x into sin pi x divided by pi plus cos pi x divided by pi square. Limits from 3 by 2 to 2 for this. Evaluate the function at upper limit minus evaluate the function at lower limit and go on simplify it. What we get? When you put the upper limit here, 3 by for this half, sin pi by 2 becomes, when you put x equal to half, correct? And cos pi by 2 is 0 there, correct? All those things you should apply properly. 2 times, when you put x equal to half, sin pi by 2 is 1, correct? X equal to half into 1, correct? When you put x equal to half, sin pi by 2 is 1, 1 into half by pi, which is 1 by 2 pi. 1 by 2 pi, correct? Lower limit is 0, this becomes 0, correct? Upper limit 1 by 2 pi, putting x equal to half, here x equal to half, pi into half is pi by 2, sin pi by 2 is 1, 1 into half by pi, which is 1 by 2 pi. Lower limit is 0. For this, when you put the upper limit x equal to half, cos pi by 2 is 0, lower limit you put x equal to 0, pi into 0, 0, cos 0 is 1 by pi square, so it becomes minus 1 by pi square. Coming to this, when you put x equal to 3 by 2 here, sin 3 pi by 2 is minus 1, correct? Minus 1 into 3 by 2, minus 3 by 2 by pi. This is minus of, correct? When you put x equal to 3 by 2, 3 by 2 into sin 3 pi by 2 is minus 1, so minus 3 by 2 pi. This is minus 3 divided by 2 pi. And when you put the lower limit x equal to half here, Sine pi by 2 is 1. Half into 1 by pi minus 1 by 2 pi minus 1 by 2 pi for this. And when you put the upper limit for this 3 by 2, cos 3 pi by 2 is 0. 0 by pi square is 0. When you put lower limit half, becomes pi by 2. Cos pi by 2 is 0. For lower limit, upper limit and lower limit, this part is 0. This part becomes 0 for upper limit as well as lower limit, because cos of odd multiple pi by 2 is 0. Cos 3 pi by 2 is 0. Even cos pi by 2 is 0. So I can close the bracket for this. Coming to this here, when you put x equal to 2 here, sine 2 pi is 0 and sine 3 pi by 2 is minus 1, correct? For this, put the upper limit and lower limit. When you put upper limit, it becomes sine 2 pi. Sine 2 pi is 0, correct? 0 into 2 becomes 0. 0 by pi is 0. Lower limit, you put 3 by 2. 3 by 2 into sine 3 pi by 2. Sine 3 pi by 2 is minus 1. Minus 1 into this. So this will be upper limit 0. Lower limit is how much? Sine 3 pi by 2. Sine 3 pi by 2 is minus 1. Minus 1 into 3 by 2. Minus 1 by, no. 3 by 2 into minus 1, minus 3 by 2, minus 3 by 2 pi get, minus of minus plus 3 by 2 pi, because it is the lower limit, no, minus of minus it becomes. And for this upper limit, when you put cos 2 pi, it is going to be equal to 1, correct? 1 by pi square I get. Lower limit will be 0 because cos 3 pi by 2 is 0, correct? For this upper limit, this is cos 2 pi is 1, 1 by pi square I get, 1 by pi square. So simplify this, what do you get? 2 into 1 by 2 pi minus 1 by pi square minus 3 by 2 pi minus 1 by 2 pi, so minus 4 by 2 pi, minus of minus plus 4 by 2 pi plus 3 by 2 pi plus 1 by pi square. 1 by pi square is going to cancel, correct? These two will cancel out, opposite side. So what do you get? 3 by 2 pi plus 4 by 2 pi, 7 by 2 pi plus 1 by 2 pi, 8 by 2 pi. So this is 2 into 8 by 2 pi, which is going to be equal to 8 by pi answer. 2 cancels, answer is 8 by pi, which is option A. Similar type of question was asked in JEE 2025 also. Also, this type of question is found in NCERT book itself. Please make a note of this question asked in the year 2018. Use a time-saving result for this. Integration by parts. First function keep as it is, integrate the second, minus, differentiate the first, integrate the second, continue this until it becomes 0. After this on next term will be 0. Next term becomes 0. So at this it is going to end. It's going to terminate. Move on to the next one. Which one of the following is not correct? This we can answer orally. Minus a to plus a f of x dx is 2 times 0 to a f of x dx is not correct, because that holds only if it is an even function. If f of x is even function only it holds, otherwise it is not true, correct? And the second one is true. This is property 1. Integral from 0 to a f of x dx is same as integral from 0 to a f of t dt. dt it is. dt here. Okay. dt. Change of variable is allowed. Correct? Change of variable is allowed. Property 1 this is. This is property 2. Integral from a to b f of x dx is minus b to a f of x dx. This is property 2. That is also correct. This is property 5. Integral from 0 to a f of x dx equal to integral from 0 to a f of a minus x. X can be replaced by a minus x. Correct? So statement option A is not correct, because this holds only if it is an even function, not always. Correct? So option A is not correct. Question asked in the year 1994. Move on to the next one. Next one, we have integrals of this type. Integral from minus a to plus a f of x dx. When f of x is neither odd nor even, we use this formula. 0 to a f of x plus f of minus x. Learn this. When the function is neither odd nor even, when they give integral of this type, minus a to plus a f of x dx, we can use this. Integral from 0 to a f of x plus f of minus x. And normally they ask questions of this type. f of x by e power x plus 1. Denominator is 1 plus exponential most of the time. Even in JEE Main and JEE Advanced also this type of question is commonly asked. Even in 2025 January shift one question was there, April shift also one question was there of this type. Even for CET exam we can find two questions of this type. Denominator is 1 plus exponential, 1 plus e power x, 1 plus pi power x or 1 plus pi power x. Such kind of functions will be there in the denominator. And numerator is normally an even function. Numerator is normally an even function. We'll take up problems based on this. First one we have integral from minus pi by 2 to pi by 2 dx by e power sin x plus 1. This function is neither odd nor even. So I'll be using this formula. Integral from minus a to plus a as 0 to a f of x plus f of minus x. Integral from minus a to plus a f of x dx is equal to 0 to pi by 2, 0 to a f of x plus f of minus x. Integral from minus a to plus a f of x dx is equal to integral from 0 to a f of x plus f of minus x. Use this. Now to work out this problem, I'll be using that formula. So integral from minus pi by 2 to pi by 2. Integral from minus pi by 2 to pi by 2 dx by e power sin x plus 1. E power sin x plus 1 which is equal to integral from 0 to pi by 2, 0 to pi by 2, right, f of x plus f of minus x. Dx means 1 dx, correct? So 1 by e power sin x plus 1, 1 by e power sin x plus 1 plus f of minus x, 1 by e power minus sin x plus 1. Sin of minus x is minus sin x. Integral from minus a to plus a f of x is 0 to a, 0 to pi by 2, right? F of x plus f of minus x. F of minus x means replace x by minus x and right. This is equal to integral from 0 to pi by 2, 1 by e power sin x plus 1, e power minus sin x means 1 by e power sin x. So this will be 1 by e power sin x plus 1, correct? So this is equal to integral from 0 to pi by 2, what we have is 1 by e power sin x plus 1. Here you take LCM as e power sin x, that will go to numerator, e power sin x by 1 plus e power sin x, e power sin x by 1 plus e power sin x is equal to integral from 0 to pi by 2. Take e power sin x plus 1 as common denominator. E power sin x plus 1 is common denominator. So add the numerator, we get 1 plus e power sin x. This will cancel, becomes 1. Integral from 0 to pi by 2, 1 dx. Integral of 1 with respect to x is x. Limits from 0 to pi by 2. Evaluate the function at upper limit minus lower limit. Pi by 2 minus 0 is equal to pi by 2. Answer is option C. Integral from minus a to plus a f of x dx equal to integral from 0 to a f of x plus f of minus x. Write the same function first plus write the function f of minus x. Got by replacing x by minus x. Sin of minus x is minus sin x. E power minus sin x, 1 by e power sin x. Take LCM there. After taking LCM, denominator goes to numerator. E power sin x by 1 plus e power sin x. Denominator is same, correct, common. So add the numerators. Numerator, denominator cancels because they are same. 1. Integral of 1 is x. Apply limits. Upper limit minus lower limit. Get the answer. Question asked in the year 2017. Move on to the next one. We have integral from minus pi by 2 to pi by 2 cos x by 1 plus e power x. As I told, denominator is normally 1 plus exponential function and numerator is most of the time it is an even function. Remember this. So using this formula, integral from minus pi by 2 to pi by 2 cos x by 1 plus e power x. Cos x divided by 1 plus e power x is equal to 0 to pi by 2, 0 to pi by 2 f of x plus f of minus x. First write f of x. cos x by 1 plus e power x plus f of minus x cos of minus x divided by 1 plus e power minus x is equal to integral from 0 to pi by 2. What we have? Cos x divided by 1 plus e power x. Cos of minus x is cos x divided by 1 plus e power minus x is 1 by e power x. E power minus x is 1 by e power x. Then take LCM and simplify. Integral from 0 to pi by 2 cos x divided by 1 plus e power x. E power x goes up. E power x into cos x divided by e power x plus 1. Taking LCM in the denominator, denominator goes to numerator. Denominator is same, so we can add the numerators. Integral from 0 to pi by 2. Denominator is same, 1 plus e power x. So add the numerator, cos x plus e power x into cos x. Integral from 0 to pi by 2. Here cos x is common. What remains is 1 plus e power x divided by 1 plus e power x. 1 plus e power x is going to cancel here. What we get is integral from 0 to pi by 2 cos x dx. Integral of cos x is sin x. Limits from 0 to pi by 2. Evaluate the function at upper limit minus lower limit. Correct? Sin pi by 2 minus sin 0. Sin pi by 2 is 1, sin 0 is 0, 1 minus 0 is 1. Option B is the answer. Question asked in the year 2020. Please make a note. Move on to the next one. Application of the formula sin to x as 1 minus sin x minus cos x the whole square. So one question is asked so far, and this type of question you can see in the NCERT miscellaneous exercise also of the chapter 7 integration. Okay, so integral from 0 to pi by 4. Whenever numerator contains sin plus cos and you can see sin to x in the denominator, we put t as sin x minus cos x. Learn this technique. Numerator contains sin x plus cos x and denominator contains sin 2x. In that case, we put t equal to sin minus cos and express sin 2x like this. 1 minus sin x minus cos x whole square. Suppose numerator contains sin minus cos or cos minus sin and denominator contains sin 2x, then we put t as sin plus cos. Okay, you must know that technique of simplifying. Because denominator is containing sin 2x, I'll put t as sin x minus cos x. Put t as sin x minus cos x. Put t as sin x minus cos x. So that derivative of this is going to be equal to cos x plus sin x. Cos x plus sin x into dx. And whenever you make a substitution, you differentiate and you need to change the limits. These limits are valid only for x. When x is equal to 0, find out t equal to how much? When x is equal to 0, lower limit is 0, t is equal to sin 0, 0, cos 0, 1, 0 minus 1, minus 1. When x is equal to upper limit is pi by 4, when x is pi by 4, t is equal to how much? Sin pi by 4 is 1 by root 2, cos pi by 4 also 1 by root 2, 1 by root 2 minus 1 by root 2 is going to be 0. So also write sin 2x like this, 1 minus sin x minus cos x whole square. Because you know, sin x minus cos x whole square is sin square plus cos square minus 2 sin x cos x. Sin square plus cos square is 1, right? 1 minus 1, 0. Minus of minus 2 sin x cos x will be plus sin 2x, which is same as left hand side, correct? So sin 2x you have to express like this, 1 minus sin x minus cos x whole square. Okay? So given integral becomes, given integral we'll call it as I is equal to integral from 0 to pi by 4. Numerator is sin x plus cos x divided by 3 plus sin 2x. This is equal to integral from 0 to pi by 4 sin x plus cos x divided by 3 plus sin 2x, will write it as 1 minus sin x minus cos x whole square. 1 minus of sin x minus cos x the whole square. 3 plus 1 will become 4. Now we can put t as sin minus cos as shown here. Change the limits and write x is 0 to pi by 4. T is minus 1 to 0. Minus 1 to 0. Sin x plus cos x into dx is dt. Numerator is dt. Denominator is 4 minus t square. 4 is 2 square. Use the formula of integral of 1 by a square minus x square. 1 by 2a log of mod a plus x by a minus x. This is 1 by 2a. 1 by 2 into a is 2. Log of mod a plus x by a minus x. Log of 2 plus t divided by 2 minus t. Limits from minus 1 to 0. Evaluate the function at upper limit minus lower limit. 1 by 4 into. Evaluate the function at upper limit. 2 plus 0 by 2 minus 0, correct? Log of mod 2 plus 0 divided by 2 minus 0. Log of mod. Here 2 minus 1 divided by 2 minus minus 1. Correct? 2 by 2 is 1 there. Log 1 becomes 0. This part is gone, 0. Correct? So what you get is 1 by 4 into. This will be 0 minus log of 2 minus 1 is 1, 2 plus 1, 3. Log 1 by 3 is minus log 3, correct? So this becomes 1 by 4 into log 1 by 3 is minus log 3, minus of minus plus. So 1 by 4 log 3 is answer. 1 by 4 log 3, option C is answer. Using 1 by a square minus x square formula. Integral of 1 by a square minus x square is 1 by 2a, a is 2. 1 by 2a log of mod a plus x by a minus x. 2 plus t by 2 minus t. Limits from minus 1 to 0. Evaluate the function at upper limit minus evaluate the function at lower limit. 2 plus 0 by 2 minus 0. Log 1 it becomes. Log 1 is 0. Here 1 by 3. Log 1 by 3 is minus log 3. Minus of minus plus. 1 by 4 log 3 is answer. Question asked in the year 2010. Next we have the Wallis formula. Okay, it's a quite important formula. Integral from 0 to pi by 2 sin power nx, or if it is 0 to pi by 2 cos power nx. In both the case we can apply, and it also depends upon whether the power is even number or odd number. Okay, if the power is even number, then we get into pi by 2. If it is odd number, we get into 1. Suppose integral from 0 to pi by 2 sin power nx is given. The answer is n minus 1, n minus 3, n minus 5. Go on, continue writing until it becomes 0 or negative. 0 and negative don't write, stop. Divided by n into n minus 2, n minus 4, etc. Into pi by 2 if the power is even number, or else into 1 for odd number. Okay, so learn the formula, Wallis formula, quite useful. Integral from 0 to pi by 2 sin power nx, 0 to pi by 2 cos power nx, both are same. Okay, in that case if n is even, it is taking this form. N minus 1, n minus 3, n minus 5, go on, continue. 3 into 1 negative last term, divided by n into n minus 2, n minus 4, go on, continue. 4 into 2, into pi by 2 for even, into 1 for odd number. Okay, if you want, you can write into 1, same thing, into 1. And integral from 0 to pi by 2 sin power mx cos power nx. There also we have m minus 1, m minus 3, m minus 5. Go on, continue until it becomes 0 or negative. If it becomes 0 or negative, don't write. Multiplied by n minus 1, n minus 3, n minus 5. Keep on writing until it becomes 0 or negative. If it becomes 0, don't write. If it becomes negative, don't write. Divided by m plus n into m plus n minus 2, m plus n minus 4. Keep on writing until it becomes 0 or negative. Into pi by 2 if both m and n are even. Otherwise, it is 1. If at least one of them is odd number, into 1. Otherwise, into pi by 2. K is pi by 2 or k is 1. Both m and n are even, then into pi by 2 comes. If at least one of them is odd number, then into 1. Learn this formula. Quite useful. Okay, Wallis formula is also called Wallis reduction formula. We have one question on this. Integral from 0 to pi by 8 cos cube 4 theta d theta is asked. So what I'll do is first I'll make a substitution first. Put t is equal to 4 theta. Put t is equal to 4 theta. Differentiate this. dt by d theta is 4. dt by d theta is 4, correct? So d theta is dt by 4 from this. D theta is equal to how much? dt divided by 4. D theta is dt by 4. Change the limits. When theta is equal to 0, find out t equal to how much? When theta is equal to 0, t is equal to 4 into 0 is equal to 0. When theta is equal to pi by 8, upper limit is pi by 8. T is equal to 4 into pi by 8 is pi by 2. Integral from 0 to pi by 8. Integral from 0 to pi by 8 cos cube 4 theta d theta. Cos cube 4 theta d theta is equal to limits what? Theta is 0 to pi by 8. T is 0 to pi by 2, correct? So 0 to pi by 2 I'll get. Cos cube of 4 theta. 4 theta is taken as t. And d theta is how much? dt by 4. dt divided by 4. dt by 4 means keep 1 by 4 outside the integral. 1 by 4 integral from 0 to pi by 2 cos cube t dt. 1 by 4 integral from 0 to pi by 2 cos cube t dt. Now we can apply Wally's formula. Integral from 0 to pi by 2 cos power nx d. So that type where the power is odd number, correct? So odd number means you can write into 1 at last. This is n minus 1. N minus 3 don't write because 3 minus 3 becomes 0. If it becomes 0 or negative, don't write. Divided by n into n minus 2. N minus 4 don't write because n minus 4 becomes negative. Into 1. That's it. So answer is 1 by 4 into 3 minus 1 is 2 divided by 3 into 3 minus 2 is 1. 2 ones are 2 fours are. So 1 by 6. Correct? 2 ones are 2 twos are. 2 into 3 6. Answer is 1 by 6. Question asked in the year 2004. Please make a note of application of Wally's formula. Wally's reduction formula. Next we have limit of a sum. Okay. Learn this formula. It's a deleted part actually. It's not included now. It's a deleted part. I've given it here. Limit n tends to infinity 1 by n sigma r is equal to 1 to n function of r by n. If it is that form, you get 0 to 1. Integral from 0 to 1 f of x dx. Limit n tends to infinity 1 by n summation r is equal to 1 to 2n function of r by n. Then it is integration from 0 to 2 f of x dx. Learn these two formulas, correct? If n r is equal to 1, no, this becomes 1 by n. N tends to infinity, no, 1 by infinity is 0. And if r is equal to n, n by n is 1, correct? As n tends to infinity, it's 1. So limit of 1 is 1, upper limit is 1. So r by n is becoming x here. When r is equal to 1, lower limit is 0. When r is equal to n, upper limit is 1, correct? So likewise here. When r is equal to 1, r is equal to 1, you put 1 by n. As n tends to infinity, 1 by infinity is 0. When you put r is equal to 2n, 2n by n becomes 2. Limit n tends to infinity of 2 is 2. Upper limit is 2. So learn this formula. Some problems are there based on this. We'll work out from the PYQs. Okay. The first one we have this. Limit n tends to infinity. N by n square plus 1. We have n by n square plus 1 square plus n by n square plus 2 square, n by n square plus 3 square. Likewise it goes on. Last term is 1 by 5n. You should observe the pattern here. That's more important. Okay. The given expression I can write it as limit n tends to infinity. Limit n tends to infinity. This 1 by 5n is there, no? If you concentrate on this 1 by 5n, I can write this as n by n square plus 4n square. Correct? Because n square plus 4n square is 5n square. N by 5n square is same as 1 by 5n. So I can write n by n square plus 4n square. This is same as n divided by n square plus 2n the whole square. Correct? N by n square plus 4n square is 2n the whole square. So this is equal to what? Limit n tends to infinity. Limit n tends to infinity. What we have is numerator everywhere we got n, c, n, correct? You can generalize and write. So I'll write express in terms of summation here. Summation r is equal to 1 to 2n. See, this term is varying here. 1 square, 2 square, 3 square, here 2n the whole square. N square plus 2n the whole square, correct? So there are 2n terms altogether. Summation r is equal to 1 to n. Numerator everywhere we have n, correct? N. Denominator is going to be n square plus 2r the whole square, correct? N square is fixed number. See, n square is fixed in the denominator first term. And this number is varying. 1 square, 2 square, 3 square. Lastly, we have 2n the whole square. That I'll put it as r here. So, r square. When you put r is equal to 1, I get the first term. When you put r is equal to 2, I get the second term. R is equal to 3, I get the third term. Correct? When you put r is equal to 2n, I'm going to get the last term, which is 2nth term. Altogether, we have 2n terms. My aim is to reduce this integral to this form. Limit n tends to infinity. I should get this form. Limit n tends to infinity. 1 by n function of sigma r is equal to 1 to 2n function of r by n. In this form I should get. That will be equal to integral from 0 to 2 f of x dx. Correct? This form. So limit n tends to infinity. Sigma r is equal to 1 to 2n. N by n square plus r square. This expression, I have to reduce it to this form. Function of r by n I want. Also I want 1 by n outside the summation. So I'll divide numerator and denominator by n square. Dividing numerator and denominator by n square, this becomes limit n tends to infinity, summation of r is equal to 1 to n. You divide by n square for numerator and denominator. N by n square is 1 by n. Correct? N square by n square is 1. Plus r square by n square, which is r by n the whole square. Dividing by n square for both numerator and denominator. 1 by n you keep outside. So this is limit n tends to infinity. 1 by n summation r is equal to 1 to n. What we have is 1 by 1 plus r by n the whole square. Correct? Limit 1 by n summation of function of r by n. This becomes integral from, of course there are 2n terms. No? 2n terms. So this becomes integral from 0 to 2. 1 by 1 plus r by n becomes x. Correct? Altogether we have 2n terms. R is equal to 1 to 2n. Correct? Divide numerator and denominator by n square. N by n square is 1 by n. 1 by n is kept outside. So what you get is 1 by 1 plus r by n the whole square. Correct? Dividing by n square for numerator and denominator. R by n becomes x. Integral of 1 by 1 plus x square is tan inverse x. Tan inverse of x. Limits from 0 to 2. Evaluate the function at upper limit minus lower limit. Tan inverse 2 minus tan inverse 0. So answer is tan inverse of 2. Tan inverse of 2 is the answer. Option C. Question asked in the year 2024. In 2024, a tragedy happened, of KCET paper. The 15 questions were out of syllabus, okay? Because up till 2023, we had a full syllabus of NCERT. Then it was reduced syllabus from 2024 onwards. But they asked the old syllabus only. I mean, the full syllabus was included. But at present, what we're studying is only 80% of NCERT. 20% is deleted part. Deleted, okay, 20%. So from the deleted part also, questions were asked in 2024. Okay, so this question from 2024 paper, and there are 2n terms. 1 by 5n is n by n square plus 4n square. Because n square plus 4n square is 5n square. N by 5n square is 1 by 5n. 4n square is 2n the whole square. Generalizing and writing in terms of summation. Okay, r is equal to 1 to 2n. There are 2n terms. Integral of 1 by 1 plus x square is tan inverse x. Limit n tends to infinity 1 by n. Summation r is equal to 1 to 2n function of r by n. If it is function of r by n, I can write this integral from 0 to 2 f of x dx. R by n becomes x. Okay, hope it's clear. Answer is tan inverse of 2. Move on to the next one. We have like this. Limit n tends to infinity 1 by n plus 1 by root of n squared minus 1 plus 1 by root of n squared minus 4 up to n terms. We can write this as limit n tends to infinity. This expression I'll write as limit n tends to infinity 1 by root of n square minus 0. Because n square minus 0 is n square. Root of n square is mod n. Mod n becomes n because n is approaching infinity. It's a positive indication, positive number. Correct? Root of 1 by root of n square minus 1. 1 by root of n square minus 4. 4 is 2 square. Correct? 1 is 1 square. 0 is 0 square. Like this it goes on up to n terms. To n terms. This is limit n tends to infinity. I can write this as limit n tends to infinity. What we have is 1 by root of n square minus r square. Correct? How many terms are there? R is varying from 0 to n. Correct? I'll write in terms of summation here. Limit summation is missing. Because if you put r is equal to 1, I get the first term. R equal to 0, I get the first term. Correct? Summation r is equal to 0 to n. Summation r is equal to 0 to n. 1 by square root of n square minus r square. R is equal to 0, I get the first term. R equal to 1, I get the second term. R equal to 2, I get the third term. R equal to n, I get the nth term. Correct? So now I'll divide by n square for numerator, divide by n for numerator, denominator. Divide by n. Summation r is equal to 0 to n. Dividing by n for numerator. Dividing by n for denominator. Root of n square minus r square divided by n. This 1 by n I'll keep outside. What we get? Limit n tends to infinity. 1 by n. Summation r is equal to 0 to n. This n, now if you take inside the root, now it becomes n square. So n square by n square is 1 minus r square by n square. So I'll get 1 by root of 1 minus r by n the whole square. If you put r equal to 0, 0 by n is 0. Correct? So 0 it becomes. R by n becomes 0. Correct? When you put r is equal to 0, 0 by n is 0. So lower limit will be 0. Upper limit is n, no? N you put, n by n is 1. So r by n becomes 1 for n is equal to 1. So integral from 0 to 1 f of x dx. Limit 1 by n summation function of r by n becomes 0 to 1 f of x dx. 1 by root of 1 minus x square. R by n becomes x. Integral of 1 by root of 1 minus x square is sin inverse of x. Limits from 0 to 1. Evaluate the function at upper limit minus lower limit. What you get is sin inverse of 1 minus sin inverse of 0. Sin inverse of 1 is pi by 2. Sin inverse of 0 is 0. Pi by 2 minus 0 is equal to pi by 2. Answer is option B. Question asked in the year 1991. Correct? It can be r equal to 0 to n also. Does not matter. If it is r is equal to 1 to n also, limits from 0 to 1 only. R is 0 to 1 also, it is integral from 0 to 1 only. Because when you put r is equal to 0, r by n becomes 0. Correct? So lower limit is 0. When you put r is equal to n, it becomes n by n. N by n is 1. So upper limit is 1. Integral of 1 by root of 1 minus x square is sin inverse of x. Upper limit minus lower limit gives the answer as pi by 2. Question asked in the 1991. Move on to the next one. We have third one here. Limit n tends to infinity. 1 by n plus 1 plus 1 by n plus 2 etc. up to n terms. So here I can write it as limit n tends to infinity. Limit n tends to infinity. What we have is 1 by n plus 1 plus 1 by n plus 2 up to n terms is given. Correct? Up to n terms is equal to limit n tends to infinity. I'll write this in terms of summation now. Summation r is equal to 1 to n, correct, 1 by n plus r, correct. R is equal to 1, we get the first term. R is equal to 2, we get the second term. R is equal to n, we get nth term. Now I'll divide the numerator and denominator by n so that I can express in my form, correct. Limit n tends to infinity, dividing by n for numerator as well as denominator. Divide by n, 1 by n, divide n by n is 1 plus r by n, dividing by n for both numerator and denominator. This 1 by n will keep outside the summation. What we get? Limit n tends to infinity, 1 by n, summation of r is equal to 1 to n, 1 by 1 plus r by n. Now it is in the form of limit n tends to infinity, 1 by n, summation of function of r by n, which is integral from 0 to 1 f of x dx. This becomes integral from 0 to 1, r by n becomes x. So 1 by 1 plus x. Integral of 1 by x is log of mod x. Integral of 1 by 1 plus x is log of mod 1 plus x. Evaluate the function at upper limit minus lower limit. X equal to 0 to 1, correct? So upper limit is 1. So it becomes log of 1 plus 1, 2, minus log of 1 plus 0 is 1, correct? Log 1 is 0. So we get log 2 minus 0, which is equal to log 2. Answer is log 2. Option A is the answer. Question asked in the year 1992. Please make a note. Work out the problems on limit of sum because it will be useful for many other competitive exams. Even though it's deleted for KCET, it is useful for J exam and many other competitive exams. Move on to the next one. Question number 4 we have on this. I think this is same question, correct? 1 by n plus n is almost same as this. 1 by, last term is 1 by n plus n, correct? But the asking way is a little different. Here up to n terms was given, but here the nth term is given like this. 1 by 2n it is given like this. So 1 by 2n is 1 by n plus n, correct? So there are n terms only. So we'll get the answer as log 2 itself. 1 by n plus 1, 1 by n plus 2, etc. 1 by n plus n. That is what we had, correct? Same thing. So we'll get the answer as log 2. Again, I won't work out this problem because it is almost same as the previous one. Log 2 is the answer. Question asked in the year 1993. Move on to the next one. Limit n tends to infinity. We have n by n square plus 1 square, n by n square plus 2 square, n by n square plus 3 square. 1 by 2n, we can write it as 1 by 2n is n by 2n square, correct? Multiply numerator and denominator by n. So this will be n divided by n square plus n square. Last term is n by n square plus n square, which is nothing but 1 by 2n. So limit n tends to infinity. I can write this as limit n tends to infinity, n by n square plus 1 square, n by n square plus 2 square, n by n square plus 3 square. Last term is n by n square plus r square, n by n square plus n square. That means there are n terms. Summation is r is equal to 1 to n. R is equal to 1 to n. Numerator is fixed number, n, correct? Denominator is n square plus r square. R is equal to 1, we get the first term. R is equal to, we get the second term. R is equal to 3, we get the third term. R is equal to n, we get nth term. Now I'll divide numerator and denominator by n square. If you divide numerator and denominator by n square, what do you get? Summation r is equal to 1 to n by n square, that is 1 by n. N square by n square is 1, plus this is r square divided by n square. This 1 by n you keep outside the summation. What do you get? Limit n tends to infinity, 1 by n, summation of r is equal to 1 to n. What you get is 1 by 1 plus r square by n square is r by n the whole square. Correct? This is limit 1 by n, summation of function of r by n becomes integral from 0 to 1 f of x dx. R by n becomes x. So this is x square. Integral of 1 by 1 plus x square is tan inverse of x. This is equal to tan inverse of 1 minus tan inverse of 0. Tan inverse of 1 minus tan inverse of 0. Tan inverse of 1 is pi by 4. Tan inverse of 0 is 0. Answer is pi by 4, which is option B. R by n becomes x. Integral of 1 by 1 plus x square. Tan inverse x. Tan inverse 1 minus tan inverse 0. Tan inverse of 1 is pi by 4. Pi by 4 minus 0. Pi by 4. Question asked in the year 1996. Move on to the next one. And this question is also same as the previous one, right? Same question, see. 1 n by n square plus 1 square. N by n square plus 2 square. Correct? N by n square plus 3 square up to last term is 1 by 2n. Correct? Same answer you should get. Pi by 4. 1997. I won't work out this question once again. Same as the previous one. And this question is having last term as 2n terms. So this is, I'll work out. Limit n tends to infinity. See 1 by 3n is, 1 by 3n is my last term. Correct? 1 by 3n is my last term, which is 1 by n plus 2n. Correct? That means there are how many terms? 1 by n plus 0, 1 by n plus 1, 1 by n plus 2. Last term is 1 by n plus 2n. That means 0 to 2n. There are 2n plus 1 terms. So given expression becomes limit n tends to infinity. This is 1 by n plus 0. Correct? So summation r is equal to 0 to 2n. 0 to 2n. Numerator is fixed as 1 only. Denominator is n plus r. If you put r is equal to 0, I get the first term. R is equal to 1, I get second term. R is equal to 2, I get the third term. R is equal to 2n, I get the last term. Correct? So this is, I can divide numerator and denominator by n for this. You divide numerator and denominator by n. Summation r is equal to 0 to 2n. What do you get? 1 by n divided by n is 1 plus r by n. This is limit n tends to infinity. 1 by n you keep outside. Summation r is equal to 0 to 2n. 1 by 1 plus r by n. Correct? 1 by n you keep outside. Summation r is equal to 0 to 2n. 1 by 1 plus r by n. So this is function of r by n. How many terms? 2n plus 1 terms. If you put r is equal to 0, 0 by n, so 0. Lower limit is 0. Upper limit you put r is equal to 2n. 2n by n becomes 2. N tends to infinity of 2 is 2 only. So there are 2n plus 1 terms. Limits is from 0 to 2. Correct? Limit 1 by n summation function of r by n becomes integral from 0 to 2. Correct? This is 1 by 1 plus r by n becomes x. And integral of 1 by 1 plus x is log of mod 1 plus x. Log of mod 1 plus x. Limits from 0 to 2. Evaluate the function at upper limit minus lower limit. X equal to 2, you put 2 plus 1 is 3. Minus log of, put x equal to 0. 1 plus 0 is 1. Log 1 is 0. So I am getting log 3. Log 3 minus 0 is equal to log 3 as answer. Log 3 means log 3 base 0. This is option A. Question asked in the year 1999. On to the next one. This question is given like this. Evaluate it as a limit of a sum, but it's not required unnecessarily. Directly I can integrate this. It's a faulty question. Framing the question is faulty. A sentence is faulty actually, but I can do it directly. Integral from 2 to 3 x square dx. Integral from 2 to 3 x square dx. Integral of x square is x cube divided by 3. Limits from 2 to 3. We can evaluate it directly. Correct? 1 by 3 into upper limit minus lower limit. 3 cube minus 2 cube. 3 cube is 27. Correct? 2 cube is 8. 27 minus 8, which is 19. So 19 by 3. Option D is the answer. Question asked in the year 2022. Just use integral of x cube by 3. Evaluate the function upper limit minus lower limit. 1 by 3 is kept outside. 3 cube minus 2 cube. 27 minus 8. 19 by 3. Next one, we have some miscellaneous questions. Given like this, dx by integral of dx by a plus b cos x. 1 by root a square minus b square. Cos inverse of b plus a cos x by a plus b cos x. integrand is given as answer is given, the primitive of that, and we want to find this integral from 0 to pi dx by a plus b cos x. So just apply limits for this 0 to pi because already integral value is given, correct? So integral of dx by a plus b cos x, integral of dx by a plus b cos x is equal to 1 by root of a square minus b square cos inverse of b plus a cos x divided by a plus b cos x. Integral from 0 to pi is given, correct? For this apply limits 0 to pi. 1 by root of a square minus b square, that to keep as it is. Evaluate the function at upper limit minus lower limit. When you put upper limit, no, cos pi is minus 1. So this becomes cos inverse of b minus a divided by a minus b. Correct? When you put x equal to pi, cos pi is minus 1. Lower limit is 0. So what you get cos inverse of x equal to 0. But cos 0 is 1. I get b plus a divided by a plus b. Correct? B minus a and a minus b, if we cancel, we get minus 1. Correct? So we get 1 by root of a square minus b square. This is cos inverse of minus 1 minus cos inverse of 0. Sorry, cos inverse of 1. B plus a by a plus b is 1, right? A plus b same as b plus a becomes 1. Cos inverse of minus 1 is pi and cos inverse of 1 is 0. 1 by root of a square minus b square. Cos inverse of minus 1 is pi. Cos inverse of 1 is 0 because cos 0 is 1. Correct? Cos 0 is 1. So cos inverse of 1 is 0. Cos pi is minus 1. So cos inverse of minus 1 is pi. Cos inverse of 1 is 0. So we get the answer as pi by root of a square minus b square. Pi by root of a square minus b square, which is option A. Question asked in the year 1997. Move on to the next one. This is almost same as the previous one. If you want, you can do it again by putting t equal to tan x by 2. The method is there actually. Dx equal to 2 dt by 1 plus t square. Cos x is 1 minus t square by 1 plus t square. All those things. Okay. Put t equal to tan x by 2. The method of doing this problem. Put t is equal to tan x by 2. Dx is equal to 2 dt by 1 plus t square. 2 dt divided by 1 plus t square. And cos x is 1 minus t square by 1 plus t square. Go on, substitute and also change the limits. When x equal to 0, t equal to 0, correct? When x equal to 0, t is equal to how much? Tan 0 is 0. When x equal to pi, upper limit is pi, t is equal to how much? T is equal to pi by 2. Tan pi by 2 is infinity. So this will become integral from 0 to infinity. Dx is 2 dt by 1 plus t square. Dx is 2 dt by 1 plus t square divided by a plus b into cos x is 1 minus t square by 1 plus t square. You can take LCM as 1 plus t square. That will cancel out. 2 you can keep outside. Integral from 0 to infinity dt by denominator will be a into 1 plus t square plus b into 1 minus t square. Correct? 2 is kept outside. 1 plus t square is cancelled after taking LCM. A into 1 plus t square plus b into 1 minus t square. 2 into integral from 0 to infinity dt by what we get is a into 1a, b into 1b, a plus b, correct? A t square minus bt square. So I can write t square common there, a minus b remains. T square into a minus b. To integrate this, we can put u is equal to t into root of a minus b. Put u is equal to t into root of a minus b. U is equal to t into root of a minus b. And change the limits. When t is equal to 0, u is 0. When t is infinity, u is infinity. Correct? So limits will change. 2 times 0 to infinity. What is dt from this? Du by dt is how much? Du by dt is equal to root of a minus b into 1. Differentiate with respect to t. Root of a minus b into 1. So dt will be du by root a minus b. Du divided by root of a minus b. Correct? A plus b is how much? A plus b plus t square into a minus b is u square. Correct? This 1 by root a minus b keep outside. 2 by root of a minus b I get. And integral of 1 by u square plus a plus b is root a plus b square. Takes 1 by a square plus x square form. 1 by a tan inverse x by a. So 1 by root of a plus b. 1 by root of a plus b into tan inverse of u by root of a plus b. 0 to infinity. Correct? So this will be equal to 2 by root a plus b into root a minus b is root of a square minus b square. Evaluate the function at upper limit. Tan inverse of infinity is pi by 2 minus tan inverse of 0 is 0. 2 cancels. I'll get pi by root of a square minus b square. Pi by root of a square minus b square. 2 cancels, we get pi by root of a square minus b square. Option A is the answer. Question asked in there, 1993. Next one we have integral from 0 to pi dx by 5 plus 3 cos x. You can remember this as a standard result, integral from 0 to pi dx by a plus b cos x, correct? Pi by root of a square minus b square. That is what we got in the previous question. Integral of dx by a plus b cos x. We got it as pi by root of a square minus b square, where a is greater than b. So remember this as a standard result. Pi by root of a square minus b square. Here we want to find integral from 0 to pi dx by 5 plus 3 cos x. 5 plus 3 cos x. Put a is equal to 5 and b is equal to 3. Pi by root of 5 square minus 3 square. Correct? Compare a is equal to 5, b is equal to 3. So we get pi by root of 25 minus 9, which is pi by root 16, which is equal to 4. Pi by 4 is the answer. Pi by root of a square minus b square. A square is 25 because a is 5, b is 3. 25 minus 9, 16. Root 16 is 4. Pi by 4. Question asked in the year 2002. Move on to the next one. Here we have given like this integral. Want to find the value of this. Okay. So here what we'll do is directly I'll put x is equal to a is equal to, in fact, a is equal to 2 I'll put, so that x square plus 4 I'll get. B is equal to 3 I'll put, and C is equal to 0. So that x square plus 0 it becomes, x square cancels, correct? So consider this, put a is equal to 2, b is equal to 3, c is equal to 0, I'll get the answer. Consider this, what is given, 0 to infinity, x square divided by x square plus a square into x square plus b square x square plus c square. This is equal to pi by 2 times a plus b, b plus c, c plus a is given. Pi by 2 times a plus b into b plus c into c plus a. Like this is given. Correct? Here you put a is equal to 2. Put a is equal to 2. b is equal to 3 and c is equal to 0. We'll get the answer. So this becomes integral from 0 to infinity x square divided by x square plus a is 2 square 4, x square plus b is 3 square 9. This is x square plus c is 0 square into dx. X square cancels. Integral from 0 to infinity x square divided by x square plus 4 into x square plus 9 into x square, correct, dx. Putting a is equal to 2, b is equal to 3, c is equal to 0. This will be what? Pi by 2 into a is 2, b is 3, 2 plus 3 is 5. Correct, 2 plus 3 is 5. b is 3, c is 0. So 3 plus 0, that is 3. Here c plus a, 0 plus 2. 0 plus 2 is 2. Correct. This part, see x square is going to cancel here. X square cancels. What you get is pi by 2 into 2 is 4. 5 into 3 is 15. 15 into 4 is 16. So answer is pi by 60. Option A. Pi by 60. Question asked in the 1993. On to the next one. We have this. F of m comma n is given like this. And f of m comma n is also given like this. Want to find f of n comma n. So start from this. F of m comma n is equal to integral m by m plus n. M by m plus n into f of m minus 1 comma n minus 1. F of m minus 1 comma n minus 1. Correct. So what we need to find is f of n comma n. That means we replace m by n. F of n comma n. This will be equal to n by n plus n. Correct. M becomes n. M becomes n minus 1 comma n minus 1. N by n plus 1. N by n plus n is n by 2n. N by 2n is half. Correct? Half into f of n minus 1 comma n minus 1. F of n minus 1 comma n minus 1 becomes, this half you keep as it is. Again you apply the same formula, what is given. This will be 1 by 2 into f of n minus 2 comma n minus 2. Repeatedly apply this formula. You get 1 by 2 into 1 by 2. This will become again 1 by 2 into f of n minus 3 comma n minus 3. For this, if you apply f of n minus 3 comma n minus, becomes half into f of n minus 4 comma n minus 4. Correct? Likewise, go on, continue. This is 1 by 2 the whole cube into f of n minus 3 comma n minus 3. Likewise, go on, continue. Will end up with finally 1 by 2 power n into f of 0 comma 0. Correct? You get n minus n. 1 by 2 power n f of n minus n comma n minus n. N minus n is 0. Of course, f of 0 comma 0 can be found using this. Put m equal to 0, n equal to 0. What do you get? F of 0 comma 0 is equal to integral from 0 to pi by 2. Put m is equal to 0. Cos power 0, that is 1. Cos 0x. 0 into x is 0. Cos 0 is 1. 1 into 1 is 1. Integral of 1 is x. Limits from 0 to pi by 2. Evaluate the function at upper limit minus lower limit. Pi by 2 minus 0, which is equal to pi by 2. So this is 1 by 2 power n. 1 power n is 1. F of 0 comma 0 is pi by 2. Correct? This becomes pi divided by 2 power n plus 1. Pi by 2 power n plus 1. Option D. Question asked in the year 1997. With this, all the questions have been completed. One more question is there. Actually, this is not in the syllabus. secant hx. This is a hyperbolic function. If you want to give the definitions of hyperbolic function, if you go to engineering, all these things are useful. This is actually deleted. Okay, it's not there in syllabus now. Secant hx they can't ask. Sin hx is actually definition of sin hyperbolic x is given by e power x minus e power minus x by 2, and cos hx, cos hyperbolic x is given by e power x plus e power minus x divided by 2. If you know these two, remaining we can write. Tan hx is sin hx by cos hx, cot is cos by sin, and secant is reciprocal of cos, cosec is reciprocal of sin. If you know these two, we can write other remaining 4. Okay. So now integral from 0 to infinity secant hx. How to read this? Secant hx, secant hyperbolic x. Okay. So integral from 0 to infinity secant hx is equal to, this is equal to integral from 0 to infinity secant hx is 2 by e power x plus e power minus x. Secant hx is reciprocal of cos hx. Cos hx is e power x plus e power minus x by 2. Secant hx is reciprocal of that. 2 divided by e power x plus e power minus x. Correct? Reciprocal of cos hyperbolic x is secant hyperbolic x. And of course, you can write e power minus x as 1 by e power x. 2 you keep outside. 1 by e power x plus e power minus x is 1 by e power x. This e power x, take it up. So this becomes 2 times integral from 0 to infinity e power x divided by e power x square, that is e power 2x plus 1. To integrate this, will make a substitution that t is equal to e power x. Derivative of e power x is e power x. dt is equal to e power x into dx. Change the limits. When x is equal to 0, t is equal to e power 0, which is equal to 1. Correct? E power 0 is equal to 1. When x is equal to infinity, t is equal to e power infinity is going to be equal to infinity. E power infinity is infinity. So this becomes 2 times integral from x is 0, t is 1. And when x is infinity, t is infinity. E power x into dx is dt. E power 2x is t square plus 1. dt means 1 dt. Integral of 1 by 1 plus t square is tan inverse of t. Limits from 1 to infinity. Evaluate the function at upper limit minus lower limit. Tan inverse of infinity minus tan inverse of 1. So this is equal to 2 times tan inverse of infinity is pi by 2. Tan inverse of 1 is pi by 4. Pi by 2 minus pi by 4 is pi by 4. 2 into pi by 4, which is equal to pi by 2. Pi by 2 is the answer. Option D. Okay. E power minus x, 1 by e power x. Take LCM, e power x goes up. E power x by e power 2x plus 1. Use method of substitution. Take t equal to e power x. Derivative of e power x, e power x. Also change the limits. Whenever you make a substitution, differentiate and change the limits. Because these limits are valid only for x. X varies from 0 to infinity. T is from 1 to infinity. Because e power 0 is 1. E power infinity is infinity. So 1 to infinity becomes e power x into dx is dt. E power 2x is t square. E power 2x is t square. Because e power 2x is e power x square. T square plus 1. 1 by t square plus 1. Tan inverse t. Evaluate the function at upper limit minus lower limit. Tan inverse of infinity is pi by 2. Tan inverse of 1 is pi by 4. Pi by 2 minus pi by 4 is pi by 4. 2 into pi by 4 is pi by 2. Answer is pi by 2. Question asked in the year 1993. Okay. So with this, all the questions have been completed of definite integration from the year 1984 to 2025. Many more videos will be uploaded in the coming days connected to KCET and many other competitive exams. Please subscribe to my channel and forward to your friends. And with this, I conclude. Thank you.